Artificial intelligence is changing the world as we know it. Until now, people were using tools like Photoshop to generate real looking photos, and graphic designers had to spend hours working on the same. But now, this can be done in just few seconds. Let that be, an image itself can be manipulated. Like you feel your own image is too serious, with one click, you can add a smile to your face. A few months back, we went through a Ghibli trend, the art form that needed artists to sit and spend hours designing characters. And that now can be done within fraction of second. Today, as a web developer, you don't have to write code line by line. All you need to do is give a command to the AI agent and it will do the work for you. The task that required a team of devs can be done by one single person without moving the needle. See what Andrej, the ex-director of AI at Tesla, tweeted recently. He said he doesn't use a keyboard anymore. By just using Cursor Composer, Claude Sonnet and giving commands, he's building an entire project. It is unimaginable what AI is already capable of. Automatically replying to emails, writing emails for you, helping you in your studies, helping you with your work, giving you health advice, applying for jobs without you doing anything, working as your virtual assistant. The possibilities are totally endless. And all these things are nothing short of new global revolution. Artificial intelligence is already impacting everything. The job market is going through the change. The way of studying in schools and colleges is going to change, and so are the political systems are going to change. Listen to what Sam Altman said in recent podcast with Varun Maya.
There will be some jobs that totally go away, where the AI just does them end to end. Mostly, I think it'll be a case of a new tool where people are just much more productive and can do work at a higher quality. So there will still be people that are in charge of, making a website look great, but the expectations of how good a website looks just go up a lot, and we all get better stuff. And then and then in terms of like entirely new jobs, the first example we saw of that was prompt engineer. Before AI came along, there was no such thing as a prompt engineer. Not only that, it would have been hard to conceptualize that there would be such a job.
Now, to support this statement, here is something the World Economic Forum has forecasted. According to their research, AI is going to restructure 85 million jobs and create 90 million new jobs. Are you ready for this shift? If you're not, it's high time you get ready. And to help you in this journey, we are here. Today, through this video, we are going to cover the deep learning fundamentals that are like building blocks for all these AI innovations, and how to use tools like LangChain, Hugging Face to create your own AI models and get ahead in the generative AI game to remain relevant in job market of 2025 and beyond. This course is no bullshit exploration of things you should know about the building blocks of generative AI and how you can train your very own generative AI model to become a skilled generative AI engineer. The prerequisites for this course include mastery over Python, machine learning, and a little bit of deep learning. If you have that, this is the resource that you ever needed. Let me take you through the agenda for this course quickly. We'll begin this course by getting ourselves introduced to the term GenAI. Then we will look into deep learning algorithms like RNNs and LSTM that sit at the foundation of most GenAI tools. Next up, we'll discuss about transformers, its architectural components like encoders, decoders, attention mechanism, etc. Moving on, we'll talk about generative pre-trained transformer and move towards the discussion about large language models, what they are, their types, etc. After done with that, we'll discuss about RAG and LangChain. We'll also talk about prompt engineering, how to do it, training generative AI model on your own, etc. with a complete hands-on demonstration. So don't miss anything from this particular course. That being said, let's start with the very first topic on our list.
So firstly, it's our introduction to the generative AI part. So I'll be discussing a brief about what exactly this technology is, why we need this, how exactly we are going to achieve generation in the AI, and everything that is related. Moreover, once we start deep diving it together, we'll discuss about the difference between RNN versus LSTM. That is like the very first stepping stone towards your generative AI journey. So basically, guys, if you are aware of, so I think everyone over here is already aware of RNN, recurrent neural networks. What I assume is everybody knows about what exactly RNN is. After RNN, what we are going to do is the second particular step that we are going to climb is called as LSTM. Okay. a more advanced, a more regressive, a more appropriate solution to context study. Then the third thing that we are going to study after an LSTM will be your transformers, or the concept of encoder and decoder, a more advanced concept. Or in short, this is also called as transformers. These two things makes up a transformer. So this will be our journey that we are going to follow up. Okay. And this is how we will be studying the whole part of generative AI. After this, we'll directly jump up to the LLMs, okay, your large language models, then to LangChain, and then further ahead, we may read about RAGs or VANs or something like that. Okay. Chalo. So now let's kickstart our session. The very first question from my end, what do you understand by the terminology of AI? What exactly is AI? I think this is the very easiest, okay, the most easiest question. You might think, hey, this is not the kind of question we are expecting, but still, let me ask you one anyway. What exactly is generative AI, guys? What exactly is the meaning of AI, and what exactly is the meaning of generative AI? Is both the things. So have a check, guys, onto a diagram that I'm going to draw. Developing ability to think and make decisions through machine. Okay. So let's say, guys, if I draw a circle over here, for instance. Okay. So this circle that is there, it is artificial intelligence. Okay. Now, inside this circle, there's one more circle actually that you guys have already completed, that is ML, machine learning. How exactly the machine learns, okay? And inside this part, there's also a circle that is called as deep learning, if I'm not wrong. That you guys have also done. Is my understanding correct? You have completed AI, you have completed ML, and you have also completed deep learning. Yes. Now you might be thinking, oh, hey, I think you have covered the entire concept of machine learning and AI. Where this generative AI falls? So basically, guys, generative AI is another subset of AI over here somewhere. Okay. Now, whenever I'm talking in the terms of generative AI, you might be thinking of what this generative AI part is and how exactly this is going to work. So let's start discussing about them one by one. So let's say that if you go ahead, okay, and if you want to like just do anything, you don't want to like go ahead and you don't want to put any data as such, you have a question you want to ask it out, right? So a generative model can take what it has learned from the example. So basically, guys, generative AI is such a technique that uses, okay, the previous examples, or you can say previous data, to learn, and using that learning, it tries to answer up your questions or whatsoever task it is you are going to perform. That is what generative AI is basically. In AI, you are basically doing the same task but using a acceleration. You are basically accelerating your technology, your particular part of doing task. You're accelerating the way, the speed, the accuracy, the efficiency. But in generative AI, things works a bit different. We work with the previous data. Your machine learns and it tries to generate something entirely new. Okay, so it is not something that is old or from previous data. We are not doing a regression over here. We are trying to generate something that is new. That is what generative AI is. So let me give you a brief about the description of what exactly generative AI and when the AI comes. So when do you think the first concept of AI came into play? Like when was the first time this AI word was heard? Think of it. Just take an idea. Or maybe what could be the year, not the date specifically. What could be the year actually, guys? So let me tell you this answer, okay? When this AI stuff started and what was the very first AI tool that we were having. So basically, guys, if I talk about the history of artificial intelligence, okay, so this will go back to 28th century. Okay, it's not something that is new. The groundworks actually started in the early 1900s. Okay, that means now if you talk about AI, so it's been like 122 years since we are talking about the AIs. Okay. And then the major developments were done around 1950s, everybody. Okay. So this is like the history, like this particular thing started in 1990s somewhere, and the first research paper came around 1950. Before that, actually, I don't remember the exact year. It was like 1939 or 1940 when the first research paper on AI came. Okay. So let me tell you. So in 1921 there was one research. Then in 1929 there was one research, and then in 1949 there was one more research. I think that research of 1949 was the one of the most important research in the history of AI. It was done by Edmund, if I'm not wrong, it was Edmund Callis who has conducted the research. And guys, that research is still available on internet, by the way, if you want to read. So it is called as Giant Brains, okay, or Machine Can Think, okay, Machine That Think. So this is the very famous research paper that was actually delivered by Edward Callis to compare the newer computers to human brain. Then actually the first AI came into play, everybody. So let me show you that AI actually, and that will be very helpful for you all. So this AI was called as Eliza. So if you're not aware about this thing, so let me give you a good idea about it. So Eliza was a computer. It was the first and the most basic natural language processing computer. And it was, I think, developed by MIT, if I'm not wrong. And this program was from 1964 to 1967. Okay. So if you guys are thinking actually that they why you're discussing these all things, so it's not about the history, guys. It's about telling that this thing is not new to us. Okay, this whole thing about AI is not something new to us. It has been going from the very, 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 very long time. Okay, it's just in the year 2019 we got a new terminology called as generative AI, or maybe GPTs, if I'm not wrong. Right. So, on what year actually GPT was launched? What was the year in which the GPT was launched? Chat GPT. I think it was 2020, if I'm not wrong. I was trying to take an idea. So actually, the paper came around 2020, guys. If you just want to take an idea, so the paper came around like in the early or the in the last of 2019, and the product was launched on 30th November 2022. And from that particular period of time, this particular technology took a boom. That is your generative AI. So nowadays in the market now you can see a lot of generative AI stuff happening. Like you have GPT, you have DALI, if I'm not wrong. Then you do have Gemini, and then you do have your like Sage, Descend. A lot of things are there. Like a lot of GPTs. So the main agenda behind discussing this whole thing was to give you a brief idea on what exactly is the technologies that are there in the market, what we are going to use those technologies for, and how exactly these technologies came into existence. Okay. Now let me discuss this very new thing to you. Okay. So since you guys are from already have learned AI and you already have an idea of deep neural networks and this recurrent neural networks and this convolutional neural networks, right? So let's say, guys, if I'm talking about this recurrent neural network terminology, okay, and I want to give you a brief idea about what exactly the issues are. So let's say if there's a sentence, okay, and the sentence says, "Hey, I am Dave." Okay. Now tell me, guys, if I want to do a generation after this particular statement, okay, I want to generate a few more statements over here. How would I do that? Which particular neural network will be helpful for us in this situation? LSTM? Okay. What about RNN? Then what is the issue with the RNN, guys, if I'm talking in the terms? Can we use RNN over here for generation? I think we can use that, right? So let me give you a more better idea. Let's say if I'm having a stock data with me. So firstly, tell me, guys, if I'm talking about data of the stock, so is the data sequential or not? The stock data I'm talking about. Is the stock data sequential or not? Sequential means you're having a data that is continuous, like this. It is sequential. So that means our stock data can look something like this, if I'm not wrong. Now tell me, guys, in order to predict any value that is going to be in future, we need to consider all the past values. A very, very great example. Now have a check. If I'm talking in terms of this particular point, okay, let's say this is today. We know the price of today. Now, in order to predict the price of tomorrow, what is going to be our next step? We are going to check for the previous values. We are going to check for the historical data. We are going to check for the what are the data that we are having with us, right? But here is the issue with RNN, guys. So, okay, so let's talk a bit about RNN. RNN don't remember the previous data. It doesn't have a very, very big memory to remember all the data that it does. So let me tell you how exactly this RNA stuff might have worked. So by any chance, do you remember the architecture of RNN, guys? So see, what is the architecture of RNN is? So if you, let's suppose if this is your input over here, okay, now your input is obviously going to be connected with some weights, correct? And then it will also be passed down towards some sort of bias, right? And this whole summation, this whole weighted sum will now go to an activation function over here, correct? And then again, after this activation function, you might have another loop, then you might have another set of bias, let's say, and this might result into output. So this structure that you are seeing over here, guys, everybody, you tell me, guys, this is a structure of a recurrent neural network or this is a structure of a normal neural network? Normal neural network. But let's say if now I put a loop over here, for instance, now which kind of neural network it is? Everybody. This is your loop actually, RNN. Now let's say this is going to have some more other weights. And what is this loop called as? This is called as your feedback loop, if I'm not wrong, correct? Recursive. Now what this feedback loop does, everybody? Basically your feedback loops makes it possible, okay, it makes it possible for us to use sequential data, okay, because using this feedback loop your model can remember what is going, okay, what are the data, what is the context is, okay. So let's try to understand it using an example, by the way. Okay, so let's say guys, if for consecutive days based upon previous data there is some prediction needed to be done, okay, let me give you this example. Let's say you are going to have some particular data and you're going to do some kind of prediction. For example, okay, see, you want to just decide that if it is going to be a kind of like a high weather, low weather, like what's going to be temperature. So let's say over here I've set high. Here we are having at the lower bottom low, and in the middle we are having medium. Okay. Now have a check, guys. If let's say situation over here is if for consecutive day, okay, consecutive days based on previous data, okay, you have to predict future values. Now tell me guys what you will do over here. Let's say for the given day 1 and given day 2, okay, this is your day number 1, this is your day number 2, and this is your day number 3, for instance, okay. Now have a check for day number 2. Let's say the weather remained low, okay, here this is the weather, and on the second day also temperature remained low, okay, so 2 days data. Now using this data of 2 days, what you guys have to do is you have to tell me what is the prediction of third day. Now tell me guys how you're going to do it. Low? Tell me guys why low? Because of the previous pattern? Very simple answer. Because of the previous pattern. Now you might see guys, so if the price or maybe if the temperature that you're seeing right now, if it remains low for 2 days, so it will remain low for the next day also. That is according to our understanding, yes, right? Now see, if the price is going to remain or if the temperature is going to remain high for the upcoming days, let's say over here, if we are having high particular values, okay, so in the upcoming days as well, we are going to have high values, right? Now, similarly, guys, now let's understand the situation, okay? Let's try to understand the situation and how exactly RNN is going to run this data and how exactly RNN is going to predict this data. So please have a look. So let's just say if we scale our data, okay, if I'm going to scale our data, or like we are going to basically standardize our data, where I make the mean equals to what you can say 1, okay, and standard deviation equals to 0, okay, right? So since there is a loop in RNN, okay, since we are having this feedback loop, okay, so we can add the yesterday's and today's price sequentially. Yes or no, guys? We can easily add our yesterday price from previous day price. Let's say if I pass today's price over here, okay, then using this feedback loop, we can again pass the next price and we can again add it up. If you want, you can understand like a pipe. Okay, so see, this is a pipe over here and there is a loop over here. Suppose. So if a data goes inside this loop, it comes over here, okay? And well, till the time it is getting processed the loop, another data that we can pass. So they can again combine together. Okay, then there's a new data over here. So I think we can do it over here as well, guys. So guys, since this RNA is going to have a feedback loop, we can add the yesterday's and today's price sequentially. Now then what is the issue over here? Then what is the issue that we are going to have? Let's try to have a check on this, okay? So let's say everybody, if I draw the same thing over here in a bit smaller format, so have a look over here in this corner on the left corner of mine. So according to our understanding on the first day, second day and third day, okay, on the first day and second day, we were having a very low temperature. Okay, this is your low, this is your medium, and this is your high, let's say. Now, according to the very basic understanding of neural network, what will we do, guys? If we do the calculation, it will be basically yesterday, whatever is the value of yesterday, multiplied by weights plus bias. Is my understanding correct, everybody? Yes, no? For the first iteration. So let's just say over here, for example, we have taken we will take any random value, okay? At any particular random value. So again, once the loop will start running, okay, if the loop will start running, the input will go from over here, it will add the bias, it will take the weights, okay, it will go inside the loop, it will do its operation. Now tell me guys, again, if you want to pass one value more, it will be more complicated because again the values will go inside, this value will come from over here, and this value will get summed up over here somewhere, right? And again it will go in activation again back to the loop. So it's basically a bit hard to understand when we don't unwrap, okay, when the RNN is really closed. So what we can do for this, we can start unfolding the RNN. Okay, so what is unfolding strategy means? So have a check, guys. Okay, So let's say if I draw this diagram, you guys let me know if you're able to understand it more easily or not. So if I say over here yesterday, for example, okay, this is your yesterday temperature, you can say. Now, if I take this yesterday temperature with some weights and if I give some bias to it, okay, and then if this weights and bias goes into a activation function, okay, have a check on it, and then ultimately it goes out with another set of weights and bias to produce the output. Okay, but are we interested in this output, guys? Everybody, this is our yesterday's price. We want to predict tomorrow's price. So, are we interested in this particular result? No, Atul. Why will be interested? Because see, our target over here is to find the price of tomorrow, right? So, this is not our final result, right? Correct, everybody? That means, can I say after the activation, whatever result we'll get, everyone, okay? What we'll do, we'll connect to another set of RNN. Let's say with the today's price, because we are already aware what today's price is. So now this loop will handle the next activation. Okay, we'll go into some set of weights and will be multiplied with bias, and then it will produce you a output. Which output is correct? This one or this one? Second one, because this was the price of t minus one. Okay, we were standing on t, and we need to get the value of t plus one. Okay, so this is the value of t plus one over here. Okay, so a neural network with two inputs and two outputs, okay, with a feedback loop can go ahead and can solve this problem, if I'm not wrong, right? Or maybe what we can simply say is that the better way over here is to unfold the neural network, this recurrent neural network, and we can get a better output to it. Okay. But now there's one problem that comes with RNN, guys. Okay. RNN has two very big problems. The first problem I think you're already aware of, that is RNN has a very short memory. Okay, that means let's say if I have 10 data points with me, okay, let's say that if I take the price of something, is it 20, 20, 23, 24, 22, 27, or 21, 23, and 24. These are the sets of data that we are having. Now, if I talk about RNN, guys, the issue over here is, let's say if I start RNN from over here, okay, and will move forward. It will remember this point and this point together. Again, it will move forward. It will remember this point and this point. But after this, since due to this short memory limitation, what will happen is once RNN will jump over here, okay, what will happen is it will remember this part, and this last part over here that you are seeing, it will be no more in the memory. Okay, and that is the issue with the RNN. I guess you all are aware about this situation already. This is the first issue that we are having with RN. Second issue, if I talk about, it is the problem with the vanishing and exploding gradients. If you keep on iterating forward in a recurrent neural network, since due to your short memory limitation, if since your recurrent neural network is having a very short memory actually, due to that, what will happen? It will forget the previous context. Okay, whatsoever you have learned previously. Now let's say if you take this example again, once we'll move forward, right? If we talk about the recurrent neural network, it will forget the last part, the last context based upon its memory. Okay. And that is the issue for us, because in order to predict the data values more perfectly, we need to understand what is the context is going on, how the things are changing, what are the things, right? Perfect. Now, if I talk about the next problem that we are having, it's vanishing and the exploding retrieval problem. So this was the first problem. That is, RNN has a very short memory. Second problem is with the gradients parts. Let me tell you what exactly exploding and the vanishing gradient problem is. Okay. Before that, what I'm going to do is I'm going to discuss one of the very interesting part over here. Okay. About RNN specifically. So let me cover up that as well. So as I said, one problem is when we unroll, okay, when we unroll a recurrent neural network guys. Okay. Now tell me guys, right now we are only having two sequences that we are training. Okay. So now have a check guys over here. If you see this neural network that is in front of you, the recurrent one that we are trying to unroll. So right now we are only looking at two sequence of data. Suppose guys we are having 10,000 sequence of data or maybe 1 lakh sequence of data. Is it possible for us to train that neural network using this structure that you are seeing? Yes or no? Or if even if you're okay with training that, don't you think it will take a lot of time over there? So tell me, if we unroll a very, 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 very complex recurrent neural network, don't you think the training, as the time passes, it will keep on, like the training will keep on increasing its complexity and the time, and the efficiency will also keep on decreasing. Correct? है? Now over here, and this problem that you see right now of increasing the training time and decreasing the accuracy and the efficiency is called as the problem of exploding gradients. Okay, this problem is caused by the exploding gradient problem. Okay, and moreover, there's also one more problem that happens in this particular recurrent neural network is basically a vanishing gradient. So we are going to discuss this both problems firstly. So these both problems are actually related to the weights. Okay, so basically, guys, whenever we are trying to unroll, so let me give you a very easy example to it. So let's say this is your input. Okay, now your input basically goes directly to an activation function after all the mathematical calculation. Okay, and then this particular activation function passes its feedback to the next particular activation function. Okay, and then this passes the next part to the next particular activation function. Basically, into the next neural network. Okay, so these are all are having their some set of inputs and outputs. Okay, see, current it. Okay, now the thing is, all the neural networks have some set of weights associated with them. Issue is, let's say, think of it in this way, guys, everybody, okay? Let's say over here, if the weight, okay, let's say if I'm talking about weight number one. If I talk about weight number one, let's say weight number one is two, okay? Once I pass this data to this particular column over here, okay? Since the formula is wx plus 1 plus b, right? Now tell me, guys, how many times we are having this recurrent neural network over here? How many times the neural network is having over here? Three, if I'm not wrong, three times we have unfolded. So can I write it w to the power 3, w1 to the power 3, because we'll be multiplying it three times, right? So now tell me, guys, right now we are having 2, but let's say if we are having some higher weight, let's say if I'm talking about 16 as a weight, 16 multiplied by 16 is 256, multiplied by 16 is how much? I think 4000 something, 4096, or maybe I think 3000 something if I'm not wrong, 4096. Okay, so if I'm talking 4096, so tell me, guys, is this a very big number as compared to your weight? Yes or no? Is a very, 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 very big number, right? This is your amplified output. Okay, your output has been now amplified. And this particular amplified output, okay, if you take 50 days of data consecutively, think of it, guys. I'm just taking it for 3 days right now. Think of it if you're having the sequence for next 50 days. What will happen to your output, guys? What will happen to this data? Don't you think if we keep on adding this data for the next 50 days, your learning rate will become so large that your model, if you draw the diagram of learning rate, okay, like this, okay, if I draw the learning rate diagram, okay, yeah, now coming back to the problem of the exploding gradient, let's have a look onto this diagram, everybody. So let's suppose we started at this point, okay, exploding gradient problem. Now let's say the learning rate over here was 0.02. But as soon as we keep amplifying our input, guys, don't you think our learning rate will keep on increasing and increasing and increasing, right? So tell me, in this given situation, our local minima is somewhere over here. This is our local minima, right? So now tell me, guys, if you're having a very, very, very big learning rate, don't you think your model will just keep on bouncing here and there because of the high, big learning rate? Will it be able to reach the optimal state anytime? No, because it will keep on bouncing. See, because with every each upcoming iteration, your learning rate is increasing, and with increasing learning rate, your distance to reach and the probability to reach the optimal state will keep on decreasing. This problem is known as exploding gradient problem. फट जाना, basically in Hindi. This exploding gradient problem part. So now let's talk about vanishing gradient ones. Okay, that is more easy than this. Okay, have a check. Now, if I draw a diagram for you all, okay, let's read the same diagram. Okay, this one actually. Have a check, guys, onto this diagram. Now, let's say instead of taking a weight that is bigger, okay, let's say if our weight is less than 1. Okay, let's say the first weight is 0.02. Now, tell me, guys, what is 0.02 multiplied by 0.02? It is, I think, 0.0004, a more diminished output. And now let's say if I divide again multiplied by the second time, won't be 0.00008, or do the same thing for 50 times. Don't you think the output that we'll get from over here, it will be so minimal that we can simply say it is zero? So what will happen from this part? What will happen from this particular situation? Don't you think earlier we discussed the problem of exploding gradient? Now see this situation, guys. In this situation, tell me if I'm correct or not. If I draw the same diagram that we have seen earlier, let's say, okay, now have a check. If we start from this point where the learning rate is again 0.2, 0.02. Now, since our outputs are diminishing, so obviously our learning rate will also decrease, right? Because of the short output, the machine will have to go ahead and machine will have to learn the complex pattern, right? But when the gradient will have a very, 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 very small number, because see, what is weight over here? Weight is 0.02, right? A very, very small number, right? So bias and weights are only your gradients that you will try to optimize. So what will happen is, since we are having very small step, the result will be something like this. Have a check again, and it will keep on getting closer and closer and closer and closer, and this will be very, very, very much closer. Now tell me, guys, if I'm running this machine for 10,000 times still, so for the, let's say, for 100 iterations, we had the learning rate at 0.02, and then once it will start decreasing, don't you think it will keep on decreasing like this? 0.002, 0.0002. And now, if you're having a learning rate like this, do you think we'll be able to reach the local minimum? Will be able to reach local minimum anytime? It will not take more number of epochs. Your number of epochs will be over before you reach local minimum, because obviously you're not going to run the machine for infinite time, right? Let's say if you're running a machine for 1,000 times, still you won't be able to reach it out. Okay, and this problem is known as vanishing gradient problem. Because if you might notice, your gradients are now vanished. What is your current learning rate? It's 0 point some particular zeros. Okay, let's say if I take a bar and two, correct. And maybe due to this also your weights are also decreasing, because as I said earlier, if we check the feedback back loop, let's say the weight is 0.02, so the new weight will be 0.0004, a more small value. Again, if we talk about a hair, so maybe the weight could be 0.00008, right? So after a point of time, your gradients will completely vanish and you won't be able to reach the situation. And this particular problem is known as vanishing gradient problem, everybody. Yes, no, plus, minus, positive, negative, cleared? Sure. Okay. So now how to tackle up this situation? Okay, how we will try to sort out the situation of having low memory, vanishing gradient and everything. Okay, let me tell you. So I think the very beginning of the class, I told you a topic that we are going to discuss that is called as LSTM. Have we, everybody? So basically, guys, as we said earlier, as we discussed earlier, this particular problem is with every RNN. Okay, we are having this problem with every particular RNN that you guys have studied. So in RNN, we have used the feedback loops. We are using the same. We used to unroll the layers. Okay, if you might have noticed, we were trying to unroll the layers like this. Okay, but here we used to have a problem that is having a vanishing gradient or exploding gradient problem. Now, to avoid this exploding gradient and vanishing gradient problem, we use LSTM. Okay, though LSTMs are more complex and have completely different structure than RNN, but it can help you solve out these both problem together, because the full form of LSTM says long short term memory. Okay, so it can handle the long term memory as well as the short term memory, guys. So now let's start talking about what exactly these all things are. So before going ahead with LSTM, I believe you guys have already learned about this activation functions. Okay, so tell me, if I write this sigmoid over here, okay, sigmoid activation function. So what exactly is the core idea behind the sigmoid activation function, everybody? What is the most core idea about the sigmoid activation function? 0 to 1. So if I draw a line over here, let's say for instance, so this is your sigmoid activation. Yes, correct. This will be y, and the output is going to lie between the range of 0 to perfect, everyone. So what is the formula of f of x over here, guys? Is it e to the e by e to the power 1 plus e to the power x? What's the formula for sigmoid? I think it's 1 by e to the power minus x, if I'm not wrong. 1 by plus e to the power minus x. So now there's also one more formula to it if you multiply it out. So can I say, if I multiply this whole terminology by e to the power x, can I write it something like this? E to the power x divided by e to the power x plus 1. We can do that, right? And now let's say, guys, if the value of x is 0.1, or maybe like let's say 10, the value is very 10. Okay, so if you put these values over here, e to the power 10, e to the power 10 plus 1, you might get a value something like 0.9995. You can might have a check. Okay, so basically what I was trying to tell you is, whatever point you put, it tries to convert either into 0 or either into 1 between these two particular terminologies. Perfect. Okay, now, have you guys ever heard about this tan hatch activation, by the way? Have you guys ever heard of tan hatch activation function? Okay, so what does tan hatch does? everybody? Because these are very important for you all guys, by the way. Before starting LSTM, we need to be aware about these activation function. That's why we are covering it. Okay. So I'm talking about the Stanage part, guys. So everybody have a look how exactly Stanage looks like. So it is something like this, if I'm not wrong. Have a check. Right? Here is a zero, here is a zero. Actually, here is a zero, zero. Minus one, one, right? So basically, guys, it takes a x, it converts into a y, and the range over here is basically minus 1 to 1. Now look at the formula for this particular equation. So can I say the formula goes something like this? 1 by e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. This is the formula for tan h case. So by the way, if you want to put any values, let's say if I take a value as 5, so e to the power minus 5 minus e to the power 5 divided by e to the power 5 plus e to the power minus 5. Then this will result to minus 1. You might have a check as well. Perfect. So, guys, tell me this thing, everyone. Okay, let's try to understand this concept of LSTM using a very, very, very easy explanation. Now, think of it in this way: if there exists a neural network, okay, if I say this, if there exists a neural network that that doesn't have any such concept of weights and bias. Okay. Now think of it in this way, guys. If there's a neural network, if there's nothing as such in that, there is no concept of weights over there, there's no concept of bias over there, then what will be the situation, guys? Everybody tell me. If there's no weights, there's no bias. So what can be the advantages of that neural network can be? Anybody? What could be the advantages of those neural network? Okay. Whatever neural network doesn't supports the weights and the bias part. Okay, you have a neural network, a simple neural network, and it is just going ahead and doing its task without using any weights and bias concept. So how exactly it is beneficial for us? Can I say, guys, if there is no such concept of weights or bias, it will allow us to flow through that series of unrolled unit without causing any vanish or explode gradient problem. Yes or no? Let's say if in this situation, if I go back here, okay, in this unrolling situation, so if you check it out, if I remove this concept of weights and bias, okay, if there's no weight, okay, and if there's no bias associated, will we have any problem of vanishing or exploding gradient? Yes or no? Will we have this problem? Tell me, guys. No, right? Tell me, no such problem as such. That is what exactly LSTM is, everybody. Okay. This is a kind of neural network that will help us to flow all our data without worrying about the weights and the bias concept. Okay. So if you want to have a look, as I said earlier as well, the LSTM it's basically having a very complex architecture, but at the same time, it's also rather easy to understand if you have a look onto it. So let me show you how exactly the LSTM looks like in a very, very, very short picture. Okay. So we need the architecture to LSTM, right? So you guys can let me know if you are able to see this picture that I'm sharing to you. No, okay, chalo, let me create it then. I think might not be visible at your ends, so let me create it. So basically, guys, if you look onto the LSTM, okay, have a check. So LSTM has two things, okay. So let's say if I design a box over here and then we start comprehending this structure. So this box is called as the LSTM working area, okay. So I'll tell you what in the specific we call it. So now there are two things that the LSTM takes in consideration. So there is the first thing that is called as long term memory for remembering the things that we need to keep in the long run. And the second thing that you remember is the short term memory. Okay. Now these are two things. So basically, if you see this particular line, okay, so this is nothing, it is coming from the previous LSTM. So I can write this is the output of t minus 1, okay, for the long term. And this is basically the output for short t minus 1, okay, for both the sequences. Now have a look on to over here, guys. What happens is this short-term memory and long-term memory they work together actually. So over here, if you look onto the LSTM diagram, the architecture remains very, 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 very simple. Okay. So let's now create this whole pattern to understand how exactly this whole thing works. So this particular thing that you're seeing over here, this is called as cell state, everyone. Okay. This is called as cell state, by the way. Okay. Now over here, what you're looking at, it's called as input or the hidden state. Okay, this is your input and your hidden state. Okay. And now guys have a check over here. There are three gates that are there in this particular LSTM process. Okay. So what happens is once your input goes inside, okay, once your input starts going inside this LSTM, it follows a long process, by the way. Okay. So there's a lot of calculation that are associated, but again, we will go with the calculation without any particular issues. It will be a bread and butter for us. Okay, so have a check. If I draw this diagram, the first part of it, okay, the very first part of it is called as the forget gate. Okay, where we remove those particular data that is not relevant to us. And here we use the sigmoid. Okay, and this will return you a output X, let's say. Okay, so this first gate that you are seeing in front of you, this I'm talking about, let me color it up. This first gate is called as forget gate, everybody. This first gate basically is called as what gate? Forget gate. Then we are going to talk about the second gate over here. So have a check, guys. If I start talking about the second gate over here, this also takes sigmoid function. Okay, this is your sigmoid. But here's the catch. What does it? It also takes a tanh function over here. Okay, now check it, guys. This and this, they combine together to give you a certain output. We'll talk about how exactly we're going to get this output, no need to worry about it. And this then whole operation then is clubbed to the output. Okay, see, there's a plus operator that I'm writing over here. So this is state that you have just observed is specifically talking about this particular part of the state. This is called as input gate, from where the information enters. Okay, this is your input gate, guys. From here, the input, your data will enter the sequence. And then there's the last gate that we have to study, that is called as the output gate. So have a check onto it. So this is your last gate, guys. Okay, have a check. Here again, we are going to have your sigmoid. Okay, and the sigmoid will return you output X, let's say, and this output will be later in go to a tanh function. It will convert into either 1 or -1, and then this will be passed to your long-term memory that will give you the output for that particular state. Similarly, you'll get the short-term output. Have a check. Whatsoever is going to the output for short-term, it will deliver from you from over here. So this is the 2 or 3 parts of LSTM, and this gate that you are seeing in front of you, this is also has a name. This is called as output gate. Okay, this is your output gate over here. Okay, so this is the structure of a LSTM, guys. Okay, this is basically, if you can say, this is your architecture. Okay, this is your architecture of LSTM. Okay.
Just a quick info, guys. Intellipaat offers generative AI and prompt engineering course, which will help you gain proficiency in creating generative AI chatbots and other GenAI tools, along with mastering the latest tools and techniques with hands-on projects and real-world case studies. And the best part, this course will be taught to you by IIT faculty and the top 1% industry experts. What's more, you'll be getting your generative AI and prompt engineering certification from Microsoft. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description down below. Without a doubt, this course can set your careers to new heights. So visit the course page link given down in the description below and take your first step towards your journey as a Gen AI engineer.
The stock that we are using over here is Apple. If you want, you can use the stocks of Google, you can use the stocks of Microsoft, you can use the stocks of Nvidia, and whatsoever stocks are available. Okay, why not use a real problem? Because see, the thing is, this stock, if you go ahead and you predict it from over here, right, and if you apply the same thing in the real life, maybe the predictions can be a bit different over there. Okay, so that's on you. If you want to go ahead and you want to use this information in stock, because as say, this particular data is real time, but it is used for research and the educational purposes, not for financial or any kind of profitable purposes. Okay, so now let's begin with the data part. So the very first thing that I'm going to do over here, okay, is to import the libraries. Okay, step 1 is to import the libraries. Okay, whatsoever libraries we need, we are going to import over here. Okay, so there are a few things that I will import over here. So my first is my configuration libraries. Okay, I think you guys are already familiar with these kind of stuff, but let me still brief you. So configuration libraries are those libraries through which you can configure the way you are coding. So let's say if I import warnings, for instance, so warnings will help me to ignore or to eliminate all the warnings that we are having from the particular given data or particular code. Okay, so that is the use case of warnings. Moreover, if I use date and time, so it will be used to grab the important dates or maybe to grab a sequence of dates from the given data. Okay, so this is the first part of your data load required. Now, if I talk about the classical libraries, okay, the common ones that you use, okay, the common libraries. So let's tell me, so I'm going to use NumPy, Pandas, Seaborn, Matplotlib over here. Okay. Moreover, what we are going to do is we'll be using some machine learning libraries also. Okay, so your machine learning libraries are onto over here. Okay, have a check. And let's import some of them also over here. So I'll say from sklearn.metrics import star. Okay. Moreover, let's import from sklearn. Sorry, we did keras actually over here. So keras.layers import LSTM. We did LSTM over here. Then also from layers we need dense. That we mentioned over here, dense layer as well as what we need is, again, from the keras itself we need a model. What kind of model it is? It is a sequential model or a normal model or a probabilistic model. What kind of model we're working on over here? So we're working on sequential model. Moreover, what we are going to do for scaling the data, what we will do is we will try to import your min-max scaler. So scalar pre-processing import min-max scaler. Okay, and since this data is working on time series, what I will do is I also want something from keras as well. That is keras.pre processing, if I'm not wrong, processing dot sequence. We are trying to process sequence, import time series, time series generator. I want time series generator. Okay, this will help us to generate a sequence of time series for us. Though we can generate it manually as well, but this can help us a lot in easing up our task. So saying time series generator is not available. I think I might made a mistake. Yeah, this is not, this should not be capital, it should be small. Again, the same thing, time series generator is, I think it's working fine. Current import from keras issue. Let's have a check. Let's have a tackle on the issue actually. There's a current import. Okay, from keras.processing.sequences. So, okay, we'll see on this particular thing why this is giving us error. Once we'll start it. So we'll have a check wherever we'll be using it. tf.processing.sequence.generator. Actually, earlier it used to work directly, if I'm not wrong. Okay, I'm not very sure, but earlier it used to work directly. Let me move in TensorFlow also over here. Sorry, not as I am still in the world of Java. So I think there might be some issue actually. Okay, import TensorFlow as TF. Okay, it's correct. See again, it is saying TF is not found. No issues. I'll have a check on it why it is giving us error. I think might be some issues. But right now, let's ignore it. We'll move forward with that, and about time series generator, I'll tell you what is the exact code. There might be a possibility that the code or the particular function might have been updated, so we'll have a check onto it. No, don't worry about it. The very first thing that we are going to do over here is to access the stock API. Okay, that is very crucial. So we are going to access the stock API. Okay. So I need to firstly import the Y finance over here. So we write Y finance as YF. If I import this gave me a green tick. And if in case, guys, when it is not getting uploaded directly, so you just install it once. Okay. You need to install it firstly. If in case, okay. If in case it's not getting installed or it's not getting updated and throws modular. Okay, in this case, you just need to pip install the Wi-Fi lines and then you need to import it, guys. Perfect. Okay, so we have imported data over here. Okay, the Wi-Fi nice data. And now see how exactly you grab the data from Wi-Fi nice. Okay, this is very important. Let me mention in the comment as well. Grabbing the data from Wi-Fi nice. Check it out. So what we'll do over here is I'll say data equals to YF. And there's something called a sticker over here. Okay, see, dot ticket. Now what this ticker does it, let's say if I say Apple, okay, it will make a request to Wi-Fi lines and it will grab the data for you. Okay, so see, first say data. So this is data, this is basically an object of a data. Okay. And now if you want, let's convert this data into a period of, let's say, 1 month each. Okay, like what is the data in 1 month period? So the data history, I will say period equals to 1 month. As soon as I write it, you might see, guys, in front of you, there is a record. Okay. And look at the most latest date. What is the most latest date, guys? What is the most latest date? It is a complete real-time data. Now, I guess a lot of people will understand this why I was saying this is a complete real-time data. So this is why finance, guys, a real-time stock data. Okay, I think this is what you guys needed. Okay, I think yes, in yesterday there are a lot of people told me, yeah, they if you can bring a real-time data. Okay, it's not actually all of it. Okay, so if you want, you can grab the information about everything about that particular organization through for which you are fetching data. So it is saying data info. We don't do data info. We just need to do data info. So have a check, guys, everyone. If you want, you can have a check that this gives you entire history about Apple. So what is where the Apple is, what's the customer care number is, what is the history, on what departments they deal, who is the CEO. See, the CEO is Timothy D. Cook. What his age is he, like every information that a company should be publishing, all the information is available in this particular database. Okay. Simple. Why have the ticker? Ticker will be a function that will make the request and you can pass your Microsoft, sorry, not Microsoft, pass your whatsoever data or whatsoever stock you want. So if you want Microsoft, you can pass Microsoft over here. If you want Nestle, you can pass Nestle over here. If you want to search for Google, you can search for Google over here. You want to find Adobe, you can find Adobe over here. Whatsoever you're comfortable with, you just put the name, it will be showing it to you. Okay. If in case, how do we identify the stock code like Apple? Okay, the ticker symbol you're asking what's in, right? That what I have written, AAPLE. Okay, very nice question. See, go to this documentation. Okay. Now see over here, everything will be available. Okay, like what kind of like what is the basic or all the particular things available. So let's say if you want, you can search like this. See, there was a particular code. I again forgot that. Actually, it was somewhere over here. See, ticker symbols, if I'm not wrong. There used to be a code to find all the ticker symbols. I'm again not sure what was the code. I also forgot that. Okay, I'll let you know, sorry. Okay, but by the way, nice question. I'll just let you know what was the code was. Okay, so it's like ticker.show or something like that. I'm forgetting and putting a code. You may just have a check and let me know. So now let's have a look onto it. So here you might see that we have got the information. Okay, a whole lot of information, like how is the cash flow and everything, even the information that is not relevant to us. Now what I'm going to do is, guys, since this data that we are having is in the series format, I'm going to convert this data into date time format actually. Okay, so that we can easily use that data by the end of the day, or you can directly use the data in the data frame format. Okay, so let's say I'm firstly grabbing my current date. So my current date is how much? Is 14, right? So if I write date time dot now, okay, this particular piece of code, this code will help you to grab the current date. Okay, see guys, everybody, this particular function is going to help you to grab the current date, by the way. Okay, I will check. Perfect. Once we have got the current date, it means the date of today. So do I want the data for the current day or till the previous day, guys? Everybody tell me, guys. If I'm defining a variable start data or start date actually, so if I say date time, okay, I need a date basically. So when I say current date dot year, that means whatever is the current year, right? And if I say current date dot month, okay, and current data dot day, where's the month, year and date? Okay, I want all of them to be present. Okay, perfect. Check. It'll be date. Sorry, I'm just completely pressing. Yeah, and it's also data. And I subtract -1 to it so that we can get the previous day data at least. Okay, I'll so when what will happen, we'll get the current day data and it will be correct. So this is current date month, this current day year, current day date. Okay, now have a look at the start date. So in current data is not defined. Where we have written current data, where here is our current date. Have a check, guys. Is this a date that we are trying to fetch up? 2024 8/13/00. Yes or no, everybody? Is it a date that we would like to work upon? And even if you guys want now, you guys can change it. So if you guys want, you need to go with the data of stock maybe near about like 2020 or 2022. You can go ahead and you can put it over here and you can get the data. Okay, so I will check now how exactly I'm going to retrieve the data. So I'll say data equals to yfinance.download. Okay, I'll mention over here I need Apple data. Okay, and then I can mention my start and the current date. So I will mention my start date from where I have to start basically. So let's take a year back. Okay, let's take 1 year data completely. So I'll say start date till the current date. Okay, this is going to be our sequence, guys, everybody. Okay, so it's downloaded and let's have a look onto it now. This is our data, guys. Perfect. So let's move forward now. So if you might have seen, the data is already there with us, and if you might see the dates actually, so it's from the last year, okay, dated with 14th of August 2023. And if I show you the tail of the data, it will be around 13th of August 2024. See, okay, perfect 1 year complete data that we are having from the stock part. Now let's try to visualize this data. Okay, let's try to visualize the data for understanding the crucial parts of the data. Okay, the crucial part of data. Okay, so for this, actually, I'm going to use plotly. So I'll say px dot line. Okay, data equals to x. Okay, and not data equals to data equals to data. Actually, this is our data, right? Yeah, x equals to let's say we are going to work with close, and then title equals to Apple stock data. Okay, so once you have grabbed this data, guys, everybody, you can just show it up, and this is how your data looks like. Everybody, see, you might notice that all it's in XGB format. Okay, see from over here, if you see right now, see going up and down. So if I start from 2023 September, okay, the lower one. So see, we reached close of 2007 and we started with 179. So looking at this particular graph, guys, can you please tell me what is your inferences, everyone? Like, what are you thinking currently right now? What might be going good or bad with Apple? So we'll put a Y column. In Y, I'll mention close so that we can only plot close column. Yeah, now it's full. Have a check date, everybody. So according to the given graph, everybody, what can be inferred? Can I say that in the last year, around about the same time, the stock prices are very low. Like if we see the time frame, it's clear about the year of 2023 into September part, you guys can, I think you guys can easily see over here. I'm talking about this part, everybody. Okay. And I think round about this particular part, we are nearly reaching the same particular stage. This guys, yes or no? I think right now we are in September 2023, and right now also we are like somewhere around September. Okay, it's already like mid of August, I think. So previous year, actually, if you see the prices, so there's a huge inflation out there that we have been huge difference in the prices. Like last year at September it was 190, and again, if you check out the maximum pricing in the July itself was around 230. So it was guys the stock that we using. What kind of nature of that stock is that? Means it is a rising stock. It's a gaining stock basically. Can I say like that? Everyone, it's no plus minus everybody. Can you say like that? Because you might have noticed it is basically closing at a very good price, right? So keeping that thing in inference, let's try to go ahead. Let's try to do a idea of it. Okay. So firstly, let's take the data information part in consideration. Okay. So how do you extract the information of a given data, guys? Everybody, can you please tell me how do you go ahead and how do you uh, grab the information about data? It's basically data.info, simple as that. Okay, and once you do that, you will get the idea about your data. So I can see over here, I've done 6 columns in total with open, high, low, close, adjusted close, and volume. Okay, and in total we are having 253 entries, everybody. So now you might be having question there, why only 250 entries? Why not 365 entries, right? Correct, everybody, because you might be having question in 1 year, right? If we are talking about 1 year, we have around 365 days, correct? Right? Now tell me, guys, if you're talking about 1 year, in 1 year, how many weekends are there? How many Sundays are there? 52, right? 52 Sundays, correct? And 52 Saturdays, correct? Now, guys, in total, it's 104. If you subtract 20 holidays, leave it. Holidays are not even considering at all. Okay, I'm just considering a part of weekends. Okay, so if it's 365 minus 104, what are the final values? 365 minus 104. Everybody, roundabout summing up, it will come approximately 261. Now, are you guys getting it? Why exactly it is 253, everybody? Why only 253 entries are there in total? Because obviously the stock market is also closed on the weekends, right? It's not there. There's no flow of assets on the weekend. No. So we can also see over here that all of the columns are there. They all include except the volume, which is in integer. Okay, it means volume is basically how much quantity of assets or how much shares okay you have purchased or something like that. So this is the information about data. Okay, this is telling us okay we have 6 columns, all sorted. We are having all the float values. Everything seems fine. But according to me, we can work with our things over here. Like we can work upon our date column, okay, because date is actually indexed right now. So maybe if we want, we can use it. for some further data analysis or something. Otherwise, we can keep it as it is. Moreover, the weekends are not there because since the market is closed on weekends, so we need to check for that. Okay, so here are my influences to this particular given data. I will check and do let you know if this is correct or not. Everybody, data information. Now, let's have a look on to over here, everybody. Okay, have a check. The next procedure that I'm going to go ahead with, I want to get a description about the given data. Okay, I want to grab the description, okay, description of the given data. How do you get the description of the data like, statistically? But how do you get the statistical description of the given data? They are just a very big perfect. Okay. Now this is the important part of it. Okay. So if you notice it out, we can ignore the count column that is currently in our basically. Okay. But now if I check about the other columns, okay, let's say if I'm talking about open or if I'm talking about close or if I'm talking about any other column. So if I'm talking about open column specifically, have a check. So normally on average the market always opens at 188 points. Okay. I've been just now a deviation of 16. That means on average there's 16-point deviation. Can we say everybody? So can we take a rough idea from over here how much the market will be fluctuating on a daily basis? Right? Eventually, right, if you notice it out, the minimum and the maximum, okay, they're not having a too far range. And even the 70% and 20% are not having very far range. Even if you notice around the mean and median are actually on the same page, okay, they are not very far away from each other. Right. So tell me guys, if I want to plot a distribution, okay, if I plot the distribution, okay, for let me make in the comment active for open column, how we can do that? Tell me guys. I want to plot a distribution for the open column, how I can do that? That's a very easy question, matter. Okay, you guys let me know what kind of distribution you can expect over there. Everyone. Okay, will it do a speed or normal? Let's have a check. This is the distribution of the given data. Okay. So you might notice it is basically normal at this point, but again, there is skewness at the right. Okay, that means there are some very few bigger values at the end also. So this is what kind of distribution works. Since it is pushed from the right hand side, is the right to distribution, right? This distribution tells us that even after having good amount of data points being scattered around the mean and the median for them due to the bigger point. Perfect. Right? So we like just trying to take an idea to understand how exactly this data is going on. Okay, because that is very crucial over here. You guys need to understand that how exactly you need to look the stock market. Right? Let's suppose right now I've learned about open, right? Now let's suppose I want to talk about the high. I mean, what about the closing values? I can see over here that if you take close value in consideration, for instance, I'm saying so on average the market always closes around 188 point with 16 deviation and normal day. Okay. So that means things if I supplement data also now, you will have the same kind of prediction. We're already going to close, so we are already getting an idea from over here. But there is a lot of information in this particular data. So this is how you read this graph firstly. So we check the average value, check to get an idea that okay, the market is close at 188 and maybe the deviation you can expect over here could be of 16 points. So roughly around like 9 to 8% of fluctuation. Okay. And then if we talk about the minimum value, so it will be around 154. So that means you can expect that if the market goes lower, it will hit a mark of like 164 or something. And if it takes you to the highs, so it will reach around like 134 or 140 roughly. Okay, so that is how you read this graph, everybody. If it's clear to what? Yes, no, correct. Let me change the data actually. So it's 16 dollars. Okay. Now, if you guys are clear with this, right? So what I'm going to do is we are going to focus on the more practical part of it. I'm going to get the information. I'm going to grab the information about the part of closing price. So that means we will try to work upon the closing price to get an idea about how exactly these prices are working here and there. Okay. So what I'm going to do is firstly let's visualize the summary. Okay, because visualizing away tells us a story about the topic. Let's visualize. And what I'm going to do is, here we got figure, I want to design a figure of size like this 15 10, for instance, or maybe 15 6. Okay, and let's do a plotting where I'm using data about closed and I'm taking color equals to red. Okay, moreover, what I'm going to do is, in order to find some title, date, and price. So date of stock which equal to automation data of stock and closing price. I will check on the given data, guys, and now it's your task to tell me what exactly this particular thing is telling me. This is on the closing price, by the way, gentlemen. So please go ahead and tell me what exactly this graph represents. We're talking about the close column now. So what exactly are the inferences that you can derive from this graph? Firstly, you need to understand how exactly the time frame is going. So I know that the data I have taken it from the previous year till the current year, 1 year time span data. Now I will check on to it. If you see the last or the very first point in the graph, it's basically near around like in between 170 to 180. Roughly, I can say it will be 188 versus. Okay. So now check out the graph with the time frame. Okay, split the time frame track also. Okay. If you see September, then if you see the period of there to November and then January. So in between this period of time, there will like a similarity that is going on that you can observe that in the peak or like in the mid of or the very start of September, there was a peak in the price and the stock, and then it suddenly depleted by the near about the month of October in the previous year. And then again it's depleted near about the mid or the you can say the end of the October. Then it started increasing and it increased in December and then again fall down a bit in the starting of January and then again continued to like rate and then again was fallen sharply near about the May of this year. So you might notice it out over here. I'm talking about this very region where okay. This region I'm talking about here. Okay. And then after May, it started increasing. There was some few declines, but fine. And it went to the mark of higher, that is more than 230 points. Okay, more than 230 points for close actually. So is this now understandable, Derek? How to read this kind of graph? They retire everyone how to read this graph, how to understand them. Because see, why understanding is important. If you guys are able to understand the way it is written down, so it will be very easy for you to compare and to take an idea about what is going to out the future is. Okay. Looking at this data, guys, what do you understand what is the future is everybody? Like, can we see that in the clinical future, there would be rise, but then with continuous decline and then with continuous ups, can we see like that? Everybody, yes, no, plus, minus, correct? Is my understanding perfectly correct? Now, what we are going to do next is we will try to grab the information about the volume or the quantity that we have sold. Okay, and how many quantities of assets we have traded. Okay, when you find out the point of instance, see like what is the information on the volume of assets sold. Like if I want to give a question, information on the volume of assets sold. Does it answer the first question? So then you can say like it partially answers the first part of the question. Like was the about the change in the price? Okay, that's putting the question. Okay. So if I take this question and if I write the answer over here, let's say, was the price of the stock changing up like with respect to time? So obviously, yes, as it can be seen here, the price of the stock is completely different. Okay, it's completely different from what we had seen in the last year, around about the same time. Correct? Everybody, if I'm writing this the particular statement, then that proves the particular question correct. Yeah. Now, I have this question with me. Okay, information on the assets sold. Have a check guys how to go ahead and how to understand the assets all apart. Okay, so firstly you need to understand what exactly assets are. So as it is written over here that it is the number of the quantity of assets sold or traded between daily close and daily open. That means how many quantity of stocks or other options that are available in market are actually sold, okay, at what quantity they are sold. So if you want to analyze that, what we are going to do is, let's write a code again. So I'll say pnt dot figure. Okay, we already have this. So we have volume of stock, data of stock, and that's all. I will check everybody. Now looking at this data, everyone, okay, and by the way, this data is in 1 to the power e to the power 2, that will send to about 8. Let me know, guys, what is your understanding to the given data. Now I think you guys can easily read up the stocks. So provide me inference like this, okay, that what we have tried to grab over here. Have a look at the data because you know what they are the inferences that you actually grab. So if you look onto this given data provided to you all, so you can see that in the very early phase, in the very first part of the data, we didn't have that many fluctuations going on. Okay? So there was a very easy graph that is going on like in the very start. So we can say that the sales were not that, like not the sales, the trade in the very start was not that good because obviously the market was low, the price was low. And then if you see the next part of the data, guys, over here, if I'm talking about. Okay, see, if I talk about this part of the data, And then if you compare this part of the data, okay, so they are mostly similar. Okay, so there is still the trading is going on, but not in a large quantity. But if you notice on this time frame, after this time frame till this time frame, check out the variability. Okay, check out the times the bars are fluctuating. Okay, so you will see that there are a lot of number of bars with high peaks actually. So can we see where in the May? Okay, starting from the March of 2024 till the July of 2024, there was a huge lot of trading of this particular stock that went ahead. Yes or no, guys? Looking at this chart, because as you might have observed, here there are a lot of things that are going on. Correct? Right? So what could be written over here? Like what can be the influence that I can go ahead and return the write from over here? Can we write something with this as a business objective? Okay, we have to write according to business objective. So can I write something like this? Using the given graph, we can conclude that the trade of assets was normal in the initial phase of the data, initial phase of the data. But as soon as we touched a new year, okay, roughly around March, I would say roughly around March till July, there was a huge explosion in the volume of stock being traded. Now, guys, tell me, is this understanding correct, everybody? If I write this particular thing, it is appropriate to say that, yeah, if you check out, so the daily production or the daily trading that is happening, it is basically has changed from the March part. Yes or no, guys? Have a read at that this in the first until let me know if it is yes or no. I'm just a single read, okay? Just a bare read and do let me know if it is correct or not. Correct? Again, using the given document to the trade of asset was normal in the initial phase of data, but as soon as it touched the new year, roughly around the March till July, there is a huge inflation in the volume of stocks being traded. Okay. So if you want to be more specific, then you can also mention it over here like this. Okay. See, like uh, in the July, there were a lot more trading done as compared to other months. Correct? So that's writing you just giving you a brief idea about how exactly this thing goes around. Okay. And now what I'm going to do, guys, is I'm going to start working with moving averages. So how many of you are already aware of the moving average concept? I guess you might have learned it in your time series part, right? So why do we perform this moving average, guys, everybody? So see, moving average is actually used to find out the updates. Okay, that means let's say if you are working on a one month data and you want to understand that how exactly the first week was different from the second week and how the second week was different from the third week. So obviously you're not going to calculate each and everything that is present over there, right? It is very hectic to calculate each and every different present to some. What moving average does, right? It tries to frame a window for you. I mean, we are kind of lighter. You can have the data, you can analyze the data of 7 particular days. Okay. That is what exactly the moving average does. Okay. Make data smooth and our practitioner. Yes, correct, Sudhir. Exactly correct. So what we're trying to do is we will try to find the ML for the given data. But here we don't know like for how much time frame we going to take so that our data can be that smooth. We don't want our data to be very smooth, obviously, because if it will be very smooth, we won't be able to understand the curve, we won't be able to understand trends or anything. And you don't want to be too short so that we can understand everything. Okay, it should be between sort, okay, perfect. Okay. So what we're going to do, we are going to find the MF for the given data for a different time frame. Okay, we'll try to find for different time frame. Okay. So what could be done over here is first we say that we will take the MA value. Okay, we'll say moving averages. Okay, and we'll say I'm going to define three moving values. Let's say for 10 days, 20 days, and 50 days. So right now we have taken 3 days in consideration, and we can also take four depending upon the use case. So we'll try to find out the moving average for these particular 4 days. Okay. Now have a check everybody how exactly we find that. Okay. So I'll say for X in moving average, for X in moving average, what we want to do is we want to calculate the column name first. Okay, have a check case. And here I can type F and we correct this. And let's try to put the sale into this data column first, where we will take the column name and we'll try to find out the rolling mean. Okay. So I'm providing the rolling mean over here and we are taking the mean. Okay. I am basically moving averages. If I run the code, it should actually go ahead and should grab all the information. Okay, about the moving average part. Okay, see. column names, close or true names or text. Okay. So if you see the data now, let me go ahead and don't mute data over here. Have a check this, everybody. When you see the data frame now, guys, everybody, there will be three new columns added. Check it out. And for 10 days, and for 20 days, and for 50 days, everybody. Right? Everyone, everybody, is this part clear what I have done over there? Let's go plus minus piece. So clear हुआ, everybody just stay with me on screen text. Yeah, work, save work, perfect. So basically what I want to do here was I want to take the data in concentration so that we can go ahead and we can calculate the particular moving average for the given date. Okay, and then what we'll do, we'll try to visualize this too. Okay, so for visualization, it will be very easy. It's not going to be very hectic and hard because you already have data with us. And if you're worried about the SAN values, say have you with 10 SAN values or 20, you have yeah. So let's try to visualize the 20. Okay, so visualizing to understand. Okay, do we understand the moving average data? Okay, and just forget the spelling mistakes, guys. I know I do a lot of spelling mistakes, so just ignore that. Now what I'm going to do is I'll just simply forward plotly over here. I'll just pick equals to create plot line. Okay, we want to grab a line chart. I'll say data x equals to index, y close this particular date, and then figure dot show. Okay, if I run this code, how much I get and now you guys tell me based upon the given data. Wait, what do you think which MA is more better? Which MA is more suitable? The 10 days, 20 days, or 50 days one? They all have different colors in it. So you guys let me know which one do you think is more appropriate. I'm giving you guys the ample time to just think about it. Okay, just think about it. What could be the possible answer over here? If you want, you can do ask me for the help. I'm there. Please, do line up. Try to understand the graph, guys, because whenever you guys are going to work with the stock data or any kind of this fluctuating data, the graphs will be very useful for you. Okay, that is what I'm trying to give. 10 days. Now let's try to analyze this firstly. So guys, we have three different colors over here. Okay, so let me take a specific time frame in consideration. Let's talk about this time frame. So if you take this time frame in consideration, actually, what will happen is if you see the red line, if you see the blue line, if you see the purple line. So basically, blue line is telling you the original value. Okay, that is the perfect original value of your data. And we do have the green, red, and I think it's a violet. So violet is for 50 days moving average, red is for 10 days moving average, and green again is for 20 days. So now if you compare the three lines together, what will happen is if you're seeing 50-day graph, right? It's very actually complicated to see, right? Because there is no such fluctuation that you guys can see. Can you observe any fluctuation over here? Just let me show you. If I talk about the purple line, basically the 50-day line, see this one. It's very smooth. It's too smooth. We can't identify any trend over here, right? Similarly, if I talk about the original line, that is the blue line, those having a lot of spike. That means the kind of original data. So to smooth it out, what I thought is let's take either 10 moving average or let's take either 20 moving average. That will be very perfectly fine. So you guys can let me know in your inputs on the same. Is my understanding correct, everybody? Can we take and go ahead with 10 or 20 days moving average? Because I feel it is more appropriate to understand the trends and how exactly the curvature of data goes like, right? Yeah. So with this particular consideration, okay, first they put some particular comments over here so no one should forget. So I'm putting this in this way, have a read on it and do it if it is correct or not. Everyone. Okay. So based upon the graph, I have written some of the things. So you guys can just read it once. Just acknowledge it once you guys are done. Okay. That together you are perfectly fine. Perfectly. Clear? So based upon the graph, we can say that the MA taken for 50 days is not able to give the complete information about the trend. It's too smooth with respect to data. Perfect. Yes. If you look on the 10-day, 20-day data, it seems to be more promising as it captures more information. So we can move up forward with the MA data having average rule of around 10 to 20 days. Recommendation is 10 days because it seems more promising. Okay. So I said, yeah, we will go with 10 days because it is again more promising. It gives you a more better idea about different things. Okay. Now you might notice without base, we have already captured the average, okay, that's how exactly an exposure attached proceeding. Now what we'll do is we'll try to understand, okay, we'll try to answer the second question out from here. What is the daily return of that stock based upon the average? Okay, this is the question is. And I think that this is the most important question if I'm not wrong. So whenever you invest in stock, you do want that how what is the return value, okay, how much percent of error you're targeting and how much like particular percent of error you are taking while investing a particular like investing into a particular project, or maybe into a particular stock, or maybe into a particular security, or maybe into a particular fund. Okay. So as written over here, this will help you understand the risk associated in investing each stock. So to judge that, we will have a look at daily changes, what is happening in the stock. Okay. Because here again, the absolution work, we can't make assumptions over. Right. So guys, do the thing. If you guys want to understand how exactly the fluctuation is. Okay. So what we'll do, we'll try to calculate the return plus minus. Can you tell me here what exactly that does it means? Firstly, we need to understand the fluctuation actually. Okay. How much we are fluctuating. You can say fluctuation, or you can say that changes. Okay. Whatsoever you're comfortable with respect to time. Okay. That is what we need to understand first. So what I'm going to do is I'm going to take data, and I'm going to take daily return. I guess that was the column. I'm going to calculate the percentage thing. That means how much is the percentage change in the given data, okay, with respect to close. So this will add a new column in our data set. Our check guys. Okay, you will have a new column named as daily return. Okay. And we'll have actually the percentage change and how much of the stock is changing on daily basis. So you might can notice it out onto over there on the very right hand pan on the last column of the data. So using this particular function, you can get an idea about okay how much is the daily change and everything. Okay. Or maybe also what we can do, we can visualize the thing. Okay, we can visualize the time, or not even time actually. We can visualize the percentage that has been changed. Okay, from the last past year. In the last past years. Okay, how much it is. What I'm going to do is I'm just going to plot really quickly a new plotting. I'm going to the data index, then returns. Okay. And let's keep the title also over here. The title may be like change in the stock per daily basis. Okay, change in the stocks on daily basis. Okay. Perfect. The code looks fine to me. There's no issue that done it. Let's have a check. Perfect. So you might notice it out, guys, as discussed. So you may see if you try to insert the same graph in the previous one that we have seen, right? So you might notice that in the initial phase of September 2020, as discussed, little low volume of trades and little low prices, maybe there were not a lot of fluctuation that is happening. But as it came across the part of July, there is a long fluctuation that is going on. Where can we see, guys, everybody, that this fluctuation that we are seeing right now in front of you and you all, it's because of this particular condition over here. Is my understanding correct? Because if you see over here in September, there's a huge lot of trading that is going on. Sorry, July of this year. And you might notice it out over here, that's the same condition. See, fluctuation. So what could we say from over here, guys? Can you please let me know what could be the inference from over here, everybody? See, what I can say from over here, this graph is good for you all to understand, okay, that how exactly this data is changing over the period of time, but not that good to like understand this completely. Okay, so what we are going to do is we'll try to go ahead and we'll try to plot a histogram so that we can understand the sequence of the data. Okay, like how much, or maybe how what is the frequency of everything is. Okay, so let's try to analyze that. So we'll see. Figure equals to px dot histogram. Okay, we can say data equals to data equals to returns and bits equals to 100. No, we don't need n bins actually. Okay, what we need over here is we need a title, maybe saying that yield in stock pricing I should win percentage. If I run the code, now having a base, so you might observe that mostly, okay, on average basis, if you see the frequency of the return, okay, it's between minus 0.2 to 0.2. That means you can expect that a stock price may fluctuate to around about like 2%. Okay. Because if you look into the other section of the graph, you might observe that there's not a lot of things that are going on. Yeah. But if you see the very portion of us, so there's a lot of going. Okay. Good at way, this is understood. If you look onto this part of data, okay, specifically I'm talking about this part of the data. You might observe that here the frequencies are quite high. But if you see this part of the data, you might observe that there is low frequency data is there. Okay, see, here's one point. So can I say, guys, if we are investing, or if we are investing in this stock, okay, there is a fairly high chance, sorry, not change, it should be chance that the that the fluctuation or the changes are going to be between minus 0.2 to plus 0.2. Okay. Now what we are going to do is, now comes the interesting part. Okay. What we are going to do over here is we will try to implement the network. Okay. But before that, what we are going to do is we'll try to go ahead and we'll try to understand how exactly data has to be feed. Because if you remember, then there's a CNN problem. Okay, sorry, not CNN. It's a RNN problem. Okay, it's based upon a complete sequential database data, right? So if we are using database data, everybody, so and if you're using some time series problem or by some time series techniques like recurrent neural network or maybe like LSTM or something. So what is going to be the sequence of data graph? Because if you might observe, our current prediction will depend upon the previous prediction, right? So does that mean that I will have to carry a previous prediction also? I'll have to carry the previous prediction also. Yes or no? Is my understanding correct? If we are talking about in terms of RNN or less team, that is how it works, right? Where to store, we need to remove the context, correct? Okay. So let's just say there's a data of 10 days. So what we are going to do when we are going to define the LSTM, we'll try to create a sequence for the given data. Okay. And maybe it can be in batches. Maybe we can go ahead and we can create all the data by ourselves. That is entirely upon. Okay. What we want over here is we want to work upon with our data page. So what is the next thing is, since we have already analyzed a lot of things, so the thing let's start working with the training and the testing data. Okay, because that is a crucial part over here. Okay, let's try to work upon it. Okay. So see guys, firstly what I'm going to do, since we have done a lot of changes to this our previous data, okay, this one, so you might see they are having volumes and all that. What we'll do is we'll download a fresh new data for us. Okay, so I'll say data equals to wire dot download. Okay, and maybe we can download the same data atom. It is double APL. And then for the start, you can mention over here what at what date we want to start. So maybe like a year back at 15th, maybe I think like 1508 and it was 2023 if I'm not wrong. It has to be given US format, so it will be like 2024 08 2023. Okay, the date what we will start with. Okay, and for the end date, okay, and for the ending date, I can say date time dot now. That is the current date. That is whatever is going on right now. Okay, whatsoever the date. But run this, we get a data. Okay, and let me show you the data actually, the same amount of data. So I'll just click the equals to px or line, and we copy this from somewhere. And this might work for us. I go a bit down, even if I okay, scroll down. So I'm just throwing my data in there. Now, if you might notice the same data which we are going to fit, which we are going to work on. Okay, it has not taken data in consideration. Why? Because why we have not taken data in consideration? So data, okay, it's only having one data. Okay, 2024 it is into our 2023. Yeah, now it is fine. September 2023 to July, August. Now, what we are going to do is, firstly, what we will do is we will try to create a separate, okay, data frame, okay, that will only have the target column over here, okay, target column for prediction, okay, because obviously we are going to work with the close, like how much, and we are going to actually forecast the value for close. So we'll try to keep it in a different data frames, but whatsoever experiment we want to do, we can do over here. So the df close equals to data close, okay. In df close, we'll have all the values of this close column, and we put it in a data frame model. So we'll have this double braces, and it gives an error now. So it will solve that error. Not long, it won't give error. This is a df close column that will handle everything. Well, let's take a length of it. Okay, what is the length of the df close? It's 253 records only. Okay, we need it a bit bigger actually. Let's do one thing. I don't need this much small data. Let's take it from this date. Okay, a more bigger data to trade on. Okay, starting on 2020, 2014 till now. Okay, that will be a very big data that we can work on. So now the data set length is 2673. Okay, and then just a random assumption. So again, if you guys can have a look onto the graph, you can easily observe in the initial phase the prices were too high, and then again as we cross the April 2020, there's a boom in the pricing. Okay, like a sudden boom in pricing. Okay, so I have created a new and a very particular data set through which we can start working on. Okay, so what I'm going to do is we will try to clean around 95% of data for training purpose. Okay, for the training purpose. but we have enough amount ample of data to go ahead and train our model. So I would say train length equals to, let me break it down. So the length of df underscore close, and I want to take out the 95% of it, whatever it's going to be. Okay. Now, moreover, this should give us the steel value, not the floor value. So I'll just include into a steel value. Okay. And steel can also return the float in TS. So I can just type as into float. Okay. So int p, length of float 95%. If I now do a train length, that means what is the length of the train data? So the length for train data is 2540 records. That means on this amount of data, our model will be going to be trained. Okay. So we'll try to grab around these many records. Now let's build the data for prediction. Okay, that will be our next step. Step number 7 is going to be building the data for prediction. Okay, like we need to actually create our own sequence. We need to generate our sequences actually, so that we can work on it. I will check this. How exactly we'll do that? So firstly, what we'll do is we'll start with the scaling of the values. Okay, so I guess you already know that why do we scale the values? So that all the bigger values, all the dominant values can come to a same page, right? So let me mention it over here. Scaling the values, okay, and why it is going to be done to remove the ahead bias of the data. Okay, and that's fine. That's all. Okay. So let's scale it. So for scaling, what I'll do is I'll call the min max scalar over here. So scalar equals to min max scalar. Okay. This is our scalar over here. That will help us to normalize the data. And what we'll do is we'll have to say data is scaled. Okay. That is, we are going to scale our data and we'll try to fit plots on the given data. Okay. We're trying to normalize the given data. If I run it, now data has been done and tested. So if you want to have a look, if you check out the data frame part of the scene, data frame, if I put DL explained over here, and if I punch in the column as uh, maybe scaled data or a scaled column, so if I notice this is the data, how it looks like. If I put 2672 records in total. Okay. Out of this 2672 record, we'll take out around 2500 records for our training purpose. Okay. Chalo. So let's start working on that. What was the step number 1, 2, 3, 5, 6, 7, right? So we are on to the 8th step. Step 8 is going to be, let's see, think of it. So we have already created it, right? So we will split the data into training and testing purpose or testing data. Okay, how it will be done? So first thing we need to create a training data. Okay, we write, okay, we need to create the training data for us. Okay, that means I will simply say train data equals to data is scaled till the length. Okay, starting from 0 till the training length. That means this will be the length of the data. And moreover, I'm not specific about any column, so I'll leave it as open. That means only grab the rows. This will training data over here. Okay. Moreover, what I'll do is later on, we will try to split this training data into training and testing. That will basically into X and Y I'm talking about. Okay, so I'll say X train and Y train equals to 2 empty list. Okay. See, as I mentioned in the comments as well, so that if you guys want to understand, you can understand really good. Okay. And then after this, what we'll do is we will try to create a sequence of data, okay, where we will use a training of past values, okay, to predict the upcoming future, okay, predict the upcoming future values. Okay, so for that, actually, what we are going to do is if for I in the range of 0 to, let's say that I'm for right now, what I'm doing is I'm just going to consider that will take around 2 months, to 2 months of time actually to predict the new value. Okay, so that means each sequence of data that we make and each prediction that will be made actually in the given data will take last 60 days in consideration to go ahead and to predict the value. So let's work upon it. So if I say X train dot append, okay, I'll say from the training data, just take this consideration. Okay, how a check goes. What I'm saying is start from I, whatsoever I is, okay, 0 minus 60. So it means start from 0, okay, and go till I, like whatsoever is I going to be. Like, okay. So basically, this is how you create a SQL server. So I'm taking finish it about like 30 days. You can also take some other days like 30, 45, 20-day in consideration. You can take any of your days in consideration. So this particular code is creating the sequence for you for a given data. Once done, everybody, what we need to do is we need to convert the given data into NumPy array for the model. Okay, so I have a check this. I can say X train and Y train equals to np.array X train, np.array Y train. Simple like that. Conversion pull and file, we are done. So it is saying setting an array element with a sequence, the requested data is having inhomogeneous, where shape was this plus inhomogeneous part. Okay, where we have done a mistake. Let me have a check. Guys, could you please spot any mistakes? Because according to me, everything is going probably fine. Okay, yeah, we have done a mistake over here. It should not be 0, it should be 60. Okay, yeah, correct. Now it should work fine. Let me read the entire code. Restart and run off. I think this is because of this, okay, because we have mentioned I equals to I minus 60, right? So if it is not 60 over here, 60 minus 60 will obviously, like 0 minus 60 will be minus 60. So it won't be able to create the sequence thereafter, right? And that will be an issue. Correct. So that is the issue that is happening over here. When we actually messed up in the for loop, it should be 60 at the very initial place. Okay. Other than that, everything was fine completely. I think now it should run fine, if I'm not wrong. Let's wait. Let me check till what point we have already run the code. Okay, pinging is still okay, it's running. Okay, perfect. Let's wait. Yeah, now see. Now everything is fine. Because we are considering 60 days, so our starting point will be 60, right? Because see, 60 minus 60 is 0, so that means it will start from the first index and will go till 60. Then again, for the second time, it will be 61, so it will start from 61 minus 60. That means from the index 1, and again we'll put 60 values in consideration. Okay, so that is why we have taken something in that. And then what we will do is we'll try to wait. Yeah, this. Then what we are going to do is we are going to reshape the array for better consideration, because it is right now in 1D into in 2D. I'll say x train equals to np dot reshape. Okay, x train dot shape 0. Okay, in what shape basically you want, and the next is going to be x train dot shape 1. Okay, that's it. That's all we need. Okay. If we need X-ray, we need to reshape it into whatsoever shape of X-ray was earlier. So row, column, and your particular channel. Okay, X, Y, Z, three values, 3D. So you can see over here what is the new shape. It is 2480 multiplied by 50 length, width, and Z. All three values are right now prepared. Now actually we can start working with the LSTM. Okay, have a check guys. So firstly, let's create a sequential model. Okay, let's create a sequential model over here. Also, model equals to sequential. Okay, once done, what I'm going to do is we have created the more sequential model, and now we need to add the LSTM layer. Okay, let's see, adding the LSTM layer with the model. I'll say model dot add LSTM will take let's say 128 neural working units in terms sequence and put equals to extrain 1 1. Okay. Similarly, let's add one more LSTM layer over here. Okay, maybe this will have less number of neurons, let's say, so 64 only. And yeah, that's it. Okay, and I want the return 30 reels. Okay, and the final return should be a one value only. So this is my network actually. So the two LSTM layers, one gets there to process all the things, and one gets there to return everything. So I run the code. Our network is now built. Now what we'll do is we'll try to compile our network. We'll try to compile the network just related. Okay. So I'll say model.compile. Okay. We'll compile the model and we'll use the optimizer. Okay. Optimizer equals to Adam. And maybe what we can do is we can use the loss equals to, sorry, not loss equals to mean squared error, since we're using regression, because time series is a regression kind of problem, right? We are trying to regress over here with respect to time. Okay. So if you compile your model, okay, it's done. Okay, that means our network is now done. Now it is a very crucial phase. We are going to fit the data into the model. Okay, so it's a model.fit X train and Y train. I'll also take a batch size actually. So every time we are just going to feed only one batch at one time. And currently, I'm just taking a very small epoch space, so it will be around 2 or 3. You may change it according to your benefit and advantage. Okay, so if I run the code and run it for 2 epochs, you might see, okay, so now see, yes, loading the data now. Okay, it's also evaluating the loss side by side. Let's wait for this moment to get completed. Meanwhile, if there's any question, please do let me know. And we do one thing. And we set the epoch to one only, and it's a read only. Maybe with some different advantage. Maybe with GPU. To GPU runtime because it was taking a lot of time over here to get trained. So you guys can actually switch to GPUs if you want to accelerate your workflow of any particular ANN or DNN or NN works. Okay, it is very good. Okay, so let's just wait. Yeah, it just came to the epochs part directly. Now it is fitting the data. It will start fitting in Windows job. Now, yeah, while it is doing its job, let's focus on our job. So once our particular model is started, what we want to do is we want to create a testing data, okay? So that we can test the model. So I'll write test data creation. Okay, we'll try to create test data and do exactly the same way, okay? So I'll say test data equals to uh, data is field training minus 60. Like whatsoever is after 60 is going to be our testing data. We'll take that in consideration. Okay, and it is still like going ahead. Okay, loss is quite low. I can see over here as such. Okay, and then after this, what we are going to do is we are going to create the subset, or you can say the sequence for testing data as well. Okay, so again the same thing for I in the range of 60. That was we are taking 60 days in consideration. The length of data and everything as well. I will check like it will be X test. We have not created the sequence of X test. It will create that as well. It will be X test equals to an empty list, and Y test is going to be a DF dot, and DF will also close that because this is our testing data, right? So one can take it directly. There's no issue with that. When DF close, and we'll take dot values actually provide dot values. And what one is the DF close? I think C was capital if I'm not wrong. Yeah, perfect. Test data is not defined. Okay, we have already defined a test data. This is already defined. Well, I guess I'm grabbing it out. Guys, any issue as such again? I'm facing a difficulty over here. Maybe saying length of test data. It is saying over here that it is not defined. It's to be defined. Okay. Okay. So we have created a subsequence of testing data also. So now let's again same thing convert into a numpy array. Okay. So converting into a NumPy array. Okay, so that we can have all the things into one person in consideration. I'll say x test equals to np dot array x test. Okay, and then what we can do is we can reshape it as well. Okay, so reshape the data. So again, the x test equals to np dot reshape. Perfect. So it is basically x test 0, 1, 1, and we need to write over in. All done. Now, what we can do is we can simply predict. Okay, we can work with that prediction part. Prediction. Okay. So I can say predictions is going to be predictions equals to a model that predicts X test. Run that, it's going to start predicted. And now let's inverse transform it, okay, so that we can get the proper results. Because we have scaled it, so we can also inverse transform. Prediction equals to scalar dot inverse transform prediction. And this particular process, it is for inverting the values back to normal. Okay, so you can get the correct results actually. Okay, but when you see the predictions, you will have the exact accurate amount of results. Okay, so see over here, guys. If I wouldn't have done that, you wouldn't have got this value. Okay, the perfect values of prediction. Okay, so let's have a check on how perfect we are. Okay, because I'm going to evaluate it. So let's work on the evaluation now. Evaluation. That is basically error analysis over here. We are trying to do the error analysis. I'm going to find the RMSC. I'm going to say that np dot square root of the mean of the predictions, okay, minus whatsoever prediction has been. Actually, it won't be predictions firstly. It should be y test firstly. Y test minus prediction. Okay. And then what we can do is for the predictions part, we need to do a whole square. Okay. And then we need to take the mean. Okay. Perfect. So this is our RMSC by the way. So RMSC score over here. It's going to be RMSC itself. Let's have a check. The RMSC came around 6, guys. So is it a too high or is it a normal error? Like normal amount of error. So let's now try to visualize this thing so that we can understand how good our model was in predicting these all this stuff. So what we'll do is, since we are having two different data that are training and testing data, what we'll try to do is we'll try to combine them. Okay. So I'll say train equals to dx close train data and test data. I will check it. Without train data and without test data. Okay. And then what I'll do, I'll make a prediction data for us. Okay. I'll try to make a prediction data for us. I will check. I'll say maybe I think we should have got it previously itself in this one. Here, prediction data. Okay, train and prediction data. And the prediction data itself, prediction data, what I can do is I can add a prediction also. Okay, see. And what we'll do is we can say we can like distribute the two values into A and B. So A equals to, we'll have prediction data. If we have a check in what exactly the prediction data holds right now. So prediction data and dot head. If I check it out, so these are the values. We have close and we have prediction. So in order to plot, we'll just take these two values really quick. So prediction values dot close, and B we can have prediction values dot prediction. Okay, both the entities in the thing. I think we should have taken the values in consideration rather than just simply taking the columns. Perfect. Now it will be easy for us to just visualize it. Okay. I'll just create a simple line plot. Okay. If I have train data, train dot index, y will pass a close, and this will be title equals to Apple soft price prediction. It will go LSTM. Okay. Let's add some bits paragraphs, or say add scatter. Okay. X equals to, we have prediction data or index, data prediction or index, and then y equals to b. There the first a actually, and I'll give it a label or maybe name of actual data. Okay, and the same thing I will do for the second part as well. But here it will be prediction data. Okay, will be your prediction data. Okay, perfect. Now let's see the picture now. How exactly it has been painted. I wish I guys everybody. If you notice it out the last part, actually, you might see the predictions over here. I will. This red line is basically actual data, and the green line is your prediction data. Okay. So this is how the LSTM has treated it. So over here, it won't have any content or very much. Okay. Let's basically work it on. What is the main application? What is the main principle that is working over here in the prediction part? It is the long short context. Okay, it's the combination of the long short context, guys, that is helping you out to figure out the things really quick. Okay.
Just a quick info, guys. Intellipaat offers generative AI and prompt engineering course, which will help you gain proficiency in creating generative AI chatbots and other GenAI tools, along with mastering the latest tools and techniques with hands-on projects and real-world case studies. And the best part, this course will be taught to you by IIT faculty and the top 1% industry experts. What's more, you'll be getting your generative AI and prompt engineering certification from Microsoft. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description down below. Without a doubt, this course can set your careers to new heights. So visit the course page link given down in the description below and take your first step towards your journey as a Gen AI engineer.
Sequence to sequence. Okay. For that, actually, we have an architecture that is called as encoder to decoder architecture. Okay, so let me give you a very firstly high level overview of how exactly this architecture look like. So this is your high level overview of the same. Okay, so if you talk about the high level overview of a transformer or encoder decoder architecture, it basically looks something like this. So see, you have a encoder over here, okay, and you have a decoder over here. Simple as that. Okay, it's the most simplest architecture that you might have seen. Now what happens is your input goes through over here. Okay, this is your input. So if I take the input, for example, so we'll take this same statement. Okay, this is statement. Okay, if we are going to use this statement as the input, right? So let's have a check. So paste, yeah, have a check, guys. This is your input that you are going to put to this model. So now, guys, if you look out at the example, the encoder decoder architecture. So the very first thing is that we are having an input over here. Input is basically a sequence. Okay. The task that I'm trying to perform over here is basically conversion of English to, okay, a very simple machine that we're trying to frame. So guys, in what ways the machine accepted the input? Does the machine accept the input in this way or the numerical way? Tell me. Machine accept the input in the numerical way, correct? Now thing is, what we will do is we'll firstly convert this whole thing into a numerical aspect, okay? Or else since it's just a high level overview, what I'll tell you is this input will go in the encoder, okay? And this encoder, after understanding, okay, inside the encoder, their encoder will try to understand, okay, it will try to understand. After understanding, this will produce a vector for you, okay? This will produce a vector that is called as context vector. And this context vector will go to decoder, where decoder will process the output, process the context vector, and based upon the same, it will generate a output. Now, the thing is, the output will be of variable length. Okay, this will be of variable length. There's no such correspondence that it has to be the same as your input. It can be of the variable length, everybody. So this is what is the high level overview of a encoder to decoder architecture is. Okay, so we started with machine learning, where you had a tabular data, you were dealing with a set of commands, algorithms, and you were doing your task. Then we had the concept of non-linearity, where if we are having a relationship like this, so machine learning algorithms are not able to understand this. So we had then the concept of deep neural network, in which the activation function was trying to solve the problem of non-linearity. Then we had images in our consideration, okay, where we had CNN for the image kind of problem, okay, right? Then came the data in the sequence, like your time series data, like using the data of 10 days, you're trying to produce the output for the 11th day, right? So for the same kind of problem, we had RNN and LSTM. We had RNN and LSTMs for the data in sequences. Now, thing was, in the RNN or in the LSTM, the issue was we were able to produce only one sequence out of the given sequence. That means the input can have like a bigger length, but the output that we were getting from the input was very very small, right? It was not very big, okay, or we were not able to go ahead and we were not able to find out a very large sequence out of it. So there was a problem of sequence to sequence data that came into picture, okay, and for solving that picture to picture, like sorry, the sequence to sequence data, we have this architecture that is called as uh, encoder to decoder architecture, okay, or encoder and decoder architecture, or this is very famously known as the transformers, okay, that helps you to transform the data. So this is what we have discussed till this point of time. So if you look onto this diagram over here, dear, so this is like a high level overview of how exactly the encoder looks like, encoder decoder architecture looks like. So here, if you might see, we have encoder, it takes an input, it tries to understand the input and then produces a context vector. And using the context vector, that is basically nothing, it's just a numerical representation of what your machine has understood. It passes this context vector to the decoder, where the decoded output can be shared to the particular user. Okay, and this is what exactly is the encoder to decoder architecture is in a gist case, everybody. Now let's say guys, if I want to process this statement through my particular LSTM or the encoder layers, so the sequence will go something like this. Have a check. 1, 2, 3, 4, 5, and 6. Okay, you are having 6 LSTM layers with you, and this is your encoder architecture. Now what will happen is, at each particular given timestamp, so let's say at timestamp given 1, 2, 3, 4, 5, and 6, we'll give one word. So here we will have B, V, we'll give R, we'll give in, we'll give Paris, we'll give enjoying over here, and we'll give pizza. Okay, and this is basically your cell state, and this is your hidden state, and then these are all are linked actually. I hope you all have got the point what I'm trying to say over here, right? So after doing this all thing, after doing whole operation over here, you will get the context vectors. Okay, thus generate context vectors, CTX vectors I'm mentioning at. Okay, now this context vectors, they go inside the decoder that you have seen right now. Okay, now let's have a look onto the how exactly this decoder architecture works for the same example. So over here, you're having a decoder architecture. Okay. Now, as I said you earlier as well, the very first cell in the decoder is going to be a starting sequence. This will tell you that, okay, please start. Okay, see, have a check. This will tell you that, okay, please start the sequence. And at the last, You will have an ending sequence or a stopping sequence telling you to stop. Okay, start and stop. Now have a check, guys. What you might be thinking that here we are having 6 words, so we'll have 6 LSTM layers. Yes, you're correct. You're going to have 6 different LSTM layers over here. So 1, 2, 3, 4, 5, and 6. So we are having 6 LSTM layers in total. But here's the issue, guys. Whenever we are producing or whenever we are working with this particular thing of the decoders, right? So ultimately, if we are passing if we are passing a vector, so can I say, guys, that if you're passing a vector over here, like any particular context vector, like let's talk about this, right? So ultimately, the output that we are going to get will be also a vector. Is my understanding correct? Ultimately, the output that we are going to get that's going to be a vector only, right? So how exactly this vector can be converted to a data or to a kind of data that we can understand? So for the same, we have a softmax layer on the top of your coder. Okay, this is your softmax. Okay, now guys, if I'm talking about a softmax, that means what exactly is the output that we are going to, in what context, in what kind of technique, or in what kind of format we are going to get the output? Tell me. Context, like softmax is something that you guys have learned a long back. So what is softmax is? So guys, basically, let's say, guys, here we are having 6 particular words right now. Okay, so what softmax will do, it will take the particular vector that is generated, and it will try to put it into probability format. Okay, you will get a vector of probability. Okay, this will return you a vector of probabilities. That means for all the 6 words, you will have different probabilities: x1, x2, x3, x4, x5, dot dot dot. How many number of sequence you are having? Now have a check onto it, guys. Let's say for this particular word v, okay, what was the context vector? It was 1 0 0 0 0 0. This was the vector, right? We sent this vector into this LSTM, and this vector was then forwarded to the decoder for the further generation. Now have a check, guys, how exactly a decoder knows, or if we are going to say decoder, hey decoder, decode the particular input, right? So that means, according to our expectation, the very first LSTM cell that we are seeing over here, right? If I say the expected output, okay, so this expected output is going to be V. The first word that was passed to the encoder, I think we are expecting the V on the same end of the decoder. Yes or no? Correct? But see, when you are going ahead and when you pass a vector, maybe could be a scenario that the vector that's generated from over here, the vector that is generated from over here, after translation from the softmax function, it might give you output like this. Okay, like 0.1, 0.2, 0.39, blah 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 blah, some particular probabilities. Now tell me, guys, looking at this probability vector that you have received, or looking at the probability sequence that you have received, according to my understanding, the very first sequence is going to be for the V, okay, or the very first probability is for the V. So according to the theory, or according to the theory of the softmax part, you let me know whatever is the highest probability of any given sequence, that is the answer. So in this case, is V our answer? Is V a tick or is V a cross? Are we receiving V as the output? Yes or no, guys? Are we receiving V as the output looking at the probabilities? No, right? Correct? So what happened over here eventually? What was the issue? Anyone? What is the issue over here? Basically, issue over here is that our particular decoder, right? The particular decoder that you are seeing right now, it was not able to comprehend, it's not able to grasp the output exactly. No context, plus the issue was it was not able to go ahead, it was not able to understand the data completely. So for the same, I think you guys might have read about a topic called as back propagation. So basically, dear, what we are going to do is we need to adjust our weights. Okay, we need to adjust our weight. We need to go ahead and we need to change our feed forward network, right? That is going to pass our data. Correct. So yeah. So after doing back propagation, ultimately after for some particular moment of time, your outputs will be stabilized. Okay, so let me talk to you about the whole process again about the encoder and decoder so that you guys can get a more good and more clear picture about it. So firstly, what we need to do is we need to do word to token. Okay, that is the step number 1. Word to token. You need to convert the word into a tokens, unique tokens basically, right? So if you take one more example over here, like let's say if I say I love cat, okay, So if I go ahead and if I try to convert this word into a tokenized format, maybe the words could be like 816, comma 8129, comma 312. Anything I've taken randomly, okay? So this is our encoding, or this is our tokenized input, basically, okay? This is our tokenized input. Now then if I go with the second step, we need to convert this particular tokens into embeddings, okay? Now I'm talking a much more deeper, guys, okay? So I'm trying to take you step by step, firstly giving you overview, then talking in the technicalities. So the second step is going to be token to embeddings, okay? Everyone is aware about the concept of embeddings, what embeddings are, okay? How many people over here are aware about embeddings concept? So let me quickly tell you what embeddings is. So it's basically a very simple thing. It's the same thing that you guys are seeing in tokenized input. When I say the vectors that are thus generated, right? So embeddings are the way to represent the complex data like your text, maybe your images as a numerical vector. So when you tokenize the input, this is just a tokenized way of seeing the same data that you're having. It's not the vector format of it, right? Embedding are basically that particular technique that convert your token. Okay, this converts your token into vectors. Okay, that is what its job of the embeddings are. Okay, so these vectors are designed, okay, these embeddings are designed to capture the semantic meaning, okay, semantic as well as structural meaning of any particular given word. Okay, if you're not aware about the word semantic, it's basically mean the context. Okay, these particular embeddings are very powerful. They understand the context and the structure between the data points. If I talk in a very simple term, so embeddings allows us to convert the abstract concept into a format that computer can understand, right? So let's just say if I'm talking about a particular word called as king and queen, right? See, if I talk about a word called as king and queen, are these two words similar or not? Like in the terms of context, are these two words similar or not? Correct? I think king and queen, both they both, if we talk in the context, they both show royalty, right? The royalty, wealth, power, right? So what will happen, guys, if you see the embeddings of these two words, so they will be mostly very similar, right? Let's say if I'm creating an embedding for it, okay? Just for instance, I'm just trying to tell you something. Now, guys, if you might have noticed, as per you guys have said and as per I have confirmed, the embeddings are basically trying to capture semantic as well as the structural context, okay? So basically, dear, if these two words are similar to each other, like king and queen, so you might notice their vector form is also very much similar. Have a check. It is 0.2, 0.5 minus 0.3, and for the second one, you can see it's 0.1, 0.4 minus 0.2. So can we see now that this particular two particular words were now represented in a much higher dimension, okay? In a much higher dimension with the context similarity, right? Since these two are in similar context, so we are having similar kind of embedding. So basically, dear, the very firstly few keywords that you need to note down in the part of embeddings is it's basically just a you can say a powerful way to represent any complex data into numerical form. Okay, second thing is the semantic part. It captures the context, okay, it remembers the concept. Okay, everyone clear with the part of embedding, what embedding is, how exactly it is working, what exactly is the part of vector that I'm trying to say. Now let's go back to the discussion over here. So once your tokens are converted into a higher dimension, that is your second particular process, this one, token to embeddings. Okay. So this embedding matrix that you will get, okay, this embedding matrix is a table where each row corresponds to a vector of a token, right? So let's just say, for instance, for this given word that was I love cat, okay, if I'm going to generate an embedding for I love cat, for instance, okay, I love cats, for instance, I'm just saying. So maybe this embedding can go something like this in 3D because I can't visualize something more than 3D right now. So I'm going with a 3D vector. Maybe I'm just trying to take some abstract sequences. Now, by the way, guys, let me ask you this question. Have any one of you a thought, or have any one of you given a thought, Dave, what are these particular vectors represent? Was thinking that, Dave, you have made it in 3D, but what exactly is 3D, or maybe what exactly is 4D is? Let me say, it's a nice and interesting topic, actually, the embeddings part, and you'll get to learn a lot about it. See, guys, the thing is, as I told you, this is semantic, okay? This whole thing is semantic. What does that mean? So have a check onto it. What exactly is semantic means to. So whenever I'm talking about semantic, that means context, right? So let's say if I'm talking about I, okay, this word I basically. So I can be used in different contexts. Let's say the very first context is introduction. Okay, you're trying to introduce yourself. Second may be like you can say cooking. right? And third might say like yourself. Okay. So now guys tell me, if I've given you three contexts, right? So you can easily say that okay, this particular context is not basically directly related to the I word. Is my understanding correct? Is cooking anywhere related to I? Is cooking word anywhere related to I? Because according to my understanding, no, right? They both are very far away from the contextual, right? That is what embedding is, guys. Okay, it tries to understand the nature, the signature, and the very deep meaning that is basically behind the data. Okay, so this is the concept of embedding. Now here is where the decoder will also come into play now. Okay, because now we have got our data. Now it's very important for you all to know that this is a very simple example, right? Okay, so in production level, the transformers can use the embeddings in very high dimension, maybe hundreds or maybe 200s, and can be much more complex to generate their positional embeddings as well. Okay, so that is one thing that is very crucial for you all to understand, that here the example that we are taking, it's just for like for making you guys understand basically, if I would say. Okay, now what I'm going to do, guys, I'm going to quickly discuss the whole process of this encoder decoder architecture, like how exactly everything works. Okay, in this particular sequence itself, we will be discussing about the attention mechanism. Okay, today I think won't be discussing about in very depth. Okay, so basically, guys, attention mechanism, because see, the thing is, let me give you just an overview. Let's say if I give you a text from over here. Okay, so I happen to have a news article. Let me see a news article for you all. Okay, guys, tell me how much time it will take for you all to convert that particular statement in Hindi. You let me know how much time it will take for you all to print or to convert it into any particular different language. Seconds, everybody, right? Now tell me your idea on this one, everybody. How much time it will take for you all to convert this particular statement? You got stuck, right? It will take us some minutes or maybe hours also to figure out okay what could be the particular translation of it. So actually the same issue is with the machine also, guys. Okay, so see, the thing is, let's say if you're having an encoder with you and if you're having a decoder with you. Okay, this is your encoder and this is your decoder. The issue is, let's say for assumption that if your words exceed more than 25. Okay, so the problem that we just faced right now is the same problem that the encoder and decoder also faces, because in order to process and in order to understand the input, it takes time. And basically, see, if you're working with an encoder, there is a summary generated at the very end. Okay, now if the word or if the length of the data, if the corpus is small, okay, so that there is no issue with the summary. But as soon as you start increasing the corpus of the data, as soon as the load of the data increases, what happens is the load on the summary part increases. Eventually what happens is when the data is passed down to the decoder, already the data that is generated in the summary is not very appropriate. Okay, and that is the issue. So for tackling this issue, let me give you a very good idea for the same to make you guys understand. Let's say I have a statement with me. Okay, the statement says turn off the light. Okay, very simple statement. Now, what will the translation of this statement, guys? This will be light. Okay, correct. Light band karo in Hindi. Now, tell me, guys, everybody. Yeah, I am taking a very simple example, by the way, to make you guys understand. But I think you guys will get the point from over here. So, if I am creating a encoder decoder architecture over here, let's say, okay, this is your encoder sequence, and this is here your decoder sequence. I'm just going to briefly mention every particular thing over here. So let's say this is your hidden context, okay, HT, and these are your basically cell states. So mapping them up. Here we have four words, that is your turn off the lights. So turn off the lights. Okay, these are your particular four given sequences. Now, if you look on the decoder, what is the first and the last statement, guys, over here? What is the first and what is the last? I think last is basically stop, and the first is going to be the start, right? Start, stop. Perfect. Now tell me, guys, if I go ahead and if I process this whole input from over here to over here, can there be a particular technique, or can there be a particular algorithm, or can there could be a particular way in which our machine don't have to read the entire particular given data? Instead, what we can do is we can just focus upon that part of the data that can give us the relevant output. Like in this case, let's say if I say light, okay, right. So let's say if I'm talking about light over here, okay, if I'm talking about this word light over here, what do you think which word out of this four given sequences is more appropriate in order to get the output? Everybody, which sequence over here will be more appropriate in conjunction to the given output? This one, right? So that means if we could have focused more onto this particular word, we could have got a better result. Light, light, context is matching. We can easily go ahead and we can easily reproduce the sequences, correct? This is what exactly the attention mechanism is. Okay, you try to give attention to one part of the statement, okay, or to a particular part of the data through which your generation or the way of creating a sequence to sequence architecture is much faster and much way possible. Okay, so whenever we are talking about this multi-head attention or basically a self-attention mechanism, so like there are multiple attention mechanism by the way, guys. So we'll be discussing about that in the upcoming like few minutes. So there is a particular attention mechanism that is called as multi-head attention. Okay, the sequence is processed multiple times. Okay, so in multi-head attention layer, the input sequence is processed multiple times. Okay, and this particular multiple processing, okay, this multiple processing of sequences, okay, is called as head. Okay, this is called as heads. This is termed as heads basically. Each head has a different weight metric. Okay, that means each time you are going to iterate, each time each of the head is going to have a different weight. So I guess weight is something that I think we you all are aware of, right? The importance. Okay, now using this weight metrics that you create, okay, using this weight metrics, okay, your model is able to understand different patterns and the relationship between each of the input sequences. Okay, the multi-head approach is what allows the model to understand the meaning of different part of the input in parallel. Okay, because whenever you're performing LSTM, everything goes in parallel. So the idea behind using multi-head attention is that your model is able to understand the different patterns, the relationships, the inputs in the given sequence. Is this correct? Now, here each of the head that you are saying, okay, let me talk about each of the head, okay, they are going to have their own vectors. Okay, these all the heads are going to have their own vectors, and these vectors are, by the way, termed as the head outputs. Okay. Now, these head outputs represent the knowledge that the head has got. Okay. That means whatever knowledge we have got, this particular output will represent that. Okay. Then these head outputs are further down concatenated to ensure that model has accessed all the information. The metrics produced by the concatenation from all of this head output are now being used, like basically this is multiplied by your weight metrics that you are seeing over here. Okay, and then the final output is used to go ahead with the knowledge. You can say this is knowledge rate, for example. Okay, that how much knowledge you're having. Okay, how much knowledge this particular head is having. Okay, each head that you are having in your data, each head that you have in your model is specialized in different patterns. Like for, let's say, for some of the heads, they can be very good with the shorter terms relationship, and some of the head can be very good with the long term relationship. Okay, so head is nothing, guys, just it's kind of like, you can say, a vector that represents different kind of relationship. Maybe some of them can be going ahead, can be good with the very short term relationship, and some of them can be very good with the long term relationship. After embedding and your positional encodings are processed, the self attention mechanism computes a query. Okay, let me write over here. After this process, okay, following after this process, after the computation part, okay, after the computation of your positional embeddings and your encoding sequences, what happens is this self attention mechanism, okay, it tries to go ahead and tries to compute three values. Okay, the first value is called as query. Okay, second value is called as a key, and third value is called as a value. Okay, so let's say if we take the previous example, that is I love cats, right? So we were having a embedding vector something like this, if I'm not wrong. It was 0.44, then we were having 0.01, and then there was 1.51, right? Similarly, over here for the second one, it will be minus 0.96, 1.48, 0.83. And this is actually from a previous diagram itself, guys. If you want, you can just reiterate through it. Once I'll share the files, you can check it out from where I have got these values. So this is your encoding, okay? Your basically, you can say embedding, okay? Embedding vector. Now, the self-attention mechanism multiplies this embedding vector with a set of weights, okay? So for each different given particular set, we will have different set of weights, right? So let's say, for example, here the weights are represented by weights epsilon, okay? Some particular weights I'm just trying to define, weight K and weight V. There are three kind of weight. You can also mention it like 1, 2, 3, okay? So now if you look onto the equation, if I say about I, so this whole thing that you are seeing in front of you, okay, this particular sequence will be multiplied 3 times. I will check. let's say that this particular sequence is a equation number 1, this is a equation number 2, and this is a equation number 3. So this equation number 1, equation number 2, and equation number 3 are going to multiply by all the set of weights that you're having. Okay, once you have multiplied this all things, okay, once you have combined these two things together, okay, so this weights are learned during the training and is shared between all the embedding vectors, okay, one by one. And these matrices are used to perform the representation of a vector into a query. Okay, so if you're still confused between what is a query, what is a value, and what is a key is, so query basically determines the relevancy of the other word in the sequence. Okay, let's say if I'm talking about your, okay, so what are the other relevancy, other words that you might have with respect to yours? Okay, so this is basically your query. Okay, if I talk about the key over here, so key basically determines the relevancy of the word from the perspective of other words. That means how relevant, okay, how relevant this word your is with respect to other words. And then value determines that how a word is compared with the other word. Okay, we can think that this is the one, this is the word that is being highlighted. Okay, it stands out and is important. Okay, so using this value, the transformer knows that it has to pay more attention or less attention. That is the concept of query, key, and value, guys. Everybody, chalo, let me give you an idea. Okay, no, it will not be a bouncer then. Chalo, let's have a example. Okay, देखो आप, let's try to understand like this. There are two friends. Okay, Atul and Prathanesh. Okay, we are having two friends in the class. Now the issue is they both are very good friend, but Atul doesn't knows Prathanesh. Okay, and Prathanesh doesn't knows Atul's language. Okay, both are having a language. So let's talk in Telugu. And okay, now we are having an issue, right? Because both of them are not able to understand each other language. So if both of them are not able to understand each and every language, so we need a translator. Correct? Tell me, guys. Just keep saying yes or no, and everything will be sorted. Okay, just keep saying yes or no so that I can get an idea. Now, see the translator that you have got, right? So, what is the job of a translator? Let's say Pradhanesh is the translator for me, right? Okay, and I don't know a nickel about Hindi. Okay, so tell me, dear, or as you are my translator, tell me if I'm going to say a word to you. Okay, what are the major things that you will be trying to take in consideration? Maybe the words that I'm saying, maybe the importance of the words that I'm saying, and maybe the way that word has been spoken, right? So is it the same thing that we have studied till this point of time? Now, if you're looking at this equation now, right now, tell me everyone, we had a head, okay? What is head basically? Let's say if you're also new to translation, dear, what you will do, you will reiterate the statement once, twice, thrice, correct or not? So every time when you're iterating, this is what the head is. Okay, the iterations, the understanding. Okay, the number of times you go ahead and number of times you are like pushing your data. Correct? Everyone, please do let me know if you're now able to understand this using an example. Now, see, guys, in the context of transformer architecture, if I'm talking about a head, so head is a self-attention mechanism that operate on a specified subset of data. Okay, so let's take, if I say you, if we take an analogy to understand this head part, so the analogy will go something like this. Let's say, have you guys ever heard of this statement called as the quick brown fox jumps over the lazy dog? I think you guys might have heard about this particular statement, right? So what will happen is, okay, let's say if you're having this word, the quick brown fox jumps over the lazy dog. So for each and every word, let's say if I'm saying the quick brown fox dot dot. So for each and every word, as we discussed, we'll have a set of embedding. We are going to have a set of embeddings for each and every given word, right? So now what will happen is we will have three particular entities with us, okay, that we are going to create. The first is going to be the query. Query, so we are going to have query, we are going to have key, and we are going to have value. So let's say for the works fox, okay, for the word fox, we are going to have three things. So firstly, do let me know if you guys are clear with the concept of these three things: the query, the value, and the key. I think we have talked about it. So let's talk about once again. Okay, so imagine a library. Okay, and in a library we are having what we are having. We are having books, right? So each book is a piece of data, right? Similar to what we are having in a sentence, right? And then there's a whole book that contains the information about all the other books that are there in the library. So if you want to relate this thing to the query, key, and value part, so query, think of it like the search term or a specific question that you want to ask about the book, right? Maybe like what books you are in having in science fiction. So query is nothing, guys, just the question statement. Okay, if you're talking about the key, so key is like the index or the metadata associated with the book. So it contains the information that can be used to match it up with the query. Okay, it contains the information that can be used. Okay, in case of books, the key might be your book author, your genre. Okay, And then if I'm talking about value, so value is actually the actual context or data, okay, that is associated with the book. That is what value is. Okay, so it is what you get when you find the book, if it matches your query. So these are the three segregations that you're having. So if I take an example over here, very simple example for making you understand this thing. So the query is that you are trying to find a science. Okay, that is the queries. Or it is a science fiction basically. Let's say science fiction. Now the key over here will be you will try to find, or you are trying to find each book from this genre, right? Finding book in science fiction, okay? And then you have a value, right? So value is basically the context, the text of the book. So these are the queries basically, okay? So you firstly query, you take a key and you find a value, okay? Now using this whole thing that you might have seen right now, what we are going to do is we will take this particular thing, we'll take this query, we'll take this key and we'll take the value. The transformers tries to calculate the attention score between the query and the keys of all the words. So let's say if you're having a word over here, that is the, okay, so this is going to be a query, right? We are trying to find the word query, right? And then what we are going to do, we will try to check for the keys, the questions, the you can say the small hints, okay, and we'll try to correspond, we'll try to find the relationship between these two things, okay. We'll try to calculate a score that is called the attention score between the queries and keys of all the words. Now these particular attention scores that you will get will represent how relevant each of the word is in your query, okay. The higher the value of attention score is, the higher the importance the word is for us, okay. So is this part now clear to you all? We are having 4 LSTM cells over here, and these LSTM cells are handling a job of converting a statement that is called as turn off the lights, for example. So obviously when we convert this complete statement into hint, it will be light band karo, right? Have a look onto how exactly this transformer is going to work. So these are basically your outputs that we will be ignoring for the current time, okay, and this same output will be outputted to the next particular state, that is your decoder, okay. For easiness, I guess we have already studied that this is our hidden state. Moreover, we are going to pass this whole thing ahead, feed forward, right? I think this is general architecture of LSTM, and this is whole thing is your encoder sequence over here, okay. These whole thing is your encoder, okay. Now this same thing is going to be passed to a decoder, and see how exactly decoder understands this thing. So again, we are going to have how many outputs we are having? 1 2 3 4, right? So let's say that we are having 5 LSTM cells over here, okay, and these 5 are going to make up the decoder, okay. Now let's understand how exactly the sequence goes in. So once this whole hidden context, or you can say the context vectors, hit the particular part of decoder, what happens is there's a sequence that is passed. So in the very start, there's a start, okay, and then upon the same, if let's say if I'm going to pass any input, so this input will be the output for the, sorry, this output will be the input for the next step. Is my understanding correct? Like this, guys? Any particular output will be the input for the next particular given step, like this, right? And here we are basically going to end our LSTM cells. Or you can say the decoder. Here we are having start, here we are having end. Connections understood. Now have a look onto this, guys, okay? What we are going to do is at each and every given step, we are going to pass some of the inputs, basically your conversion inputs, right? So now let's understand this. In this given statement, okay, if I say turn off at any given particular moment of time, so this turn off word, right, it is basically here somewhere in this given sequences, okay. Turn off the light, so turn will be over here, off will be over here, I guess. The will be on the third sequence and the light will be at the fourth sequence, correct. Now let's say I want to convert this turn off, okay, and I want to give the attention to this particular two words turn off. So according to your understanding, for band karo, right, this is the correct appropriate conversion, yes or no, everyone? Right? If you want to if you want to generate this thing, so for this particular given word, this is the most appropriate meaning, turn off, right? Now how exactly our particular transformer, how exactly our decoder will understand that this is the most important sequence, or this is the most important sequence that we need, like this particular part of H1 and H2 are the most important time frame for it. That is what exactly we need to understand, and that is what exactly is attention mechanism is. Okay, so tell me, guys, if you guys have understood the first overview of attention mechanism, like what exactly attention mechanism is in actual. Now let's say, now let me give you an example, okay. Let's say, guys, that we are at this particular point, okay, we are onto this stage. Let me name this also, so that you guys can easily understand it. So let's say this is your sequence number 1. You go to sequence 2, sequence 3, sequence 4, and sequence 5, for example. Okay. And moreover, the words that we are going to pass over here, okay, from the down part, we'll say them as C1, C2, C3 for our attention. Okay. Like which particular input needs our attention. Okay. So let's say that all the words C1, C2, C3, C4, and C5, these are basically for your attention. Okay. Attention node, we can say. Okay. These are your sequence node. Okay. And these are your hidden nodes. Okay. In your encoder, basically. Now let's try to understand this thing. Let's say at this given time sequence 2. Okay, here what is the time frame, okay, at this particular given time sequence, what is the time frame at C2, okay, at time frame C2 in decoder. Okay, now at C2, basically let's have a look onto the statement that has been passed to us. So it was light band karo, right? So if you see this example, we started, so here we again the same thing will come. We are having light over here as a question. Okay, we are having light. Now tell me guys, if we are having light, according to your understanding, which are the words that are very, very important over here? Which is the word that is very, very, very important over here in this particular given example for C2? This word light, right? That means for any given, okay, for any given I equals to Z, what we need to find is, we need to find that particular time step, that is your yi, okay, with respect to that particular sequence, correct? That can help us grab the attention. But still, we have not passed which particular part of the data we need to give the attention on. So here, your SI is basically your sequence that you are seeing over here. These sequences, okay, these are your sequences. Okay, this particular part is basically the attention that your input requires. Correct. This is in your general autoencoder. If you guys have studied about autoencoder in your AI classes, so this is your normal autoencoder part. Okay, and this part of yours that you are seeing right now, this is the part of your encoder decoder with the attention mechanism. Okay, so if you notice it out, this is basically your hidden state, this is your previous sequence, and this is the attention sequence that you need. Okay, so over here this whole thing can be written something like this as well: yi, si, and ci. If you're not aware about ci, so ci is basically to tell decoder to translate ki band karo, decoder has to read both word turn off together. I'm right. So if we have wrote, if it's both the words read individually, translation may be different. Then I'm going to that point here. If we are going to have two words, what will be the condition? So for that, actually, I'm just going to draw a very simple encoder decoder architecture. This is your encoder, and on to over here we'll have a decoder. For instance, okay, this is 1, this is 2, this is 3, and this is 4. This is your encoder sequence, by the way. Okay, this is your encoder, and here let's say these are your decoder sequences. Okay, 1, 2, 3, 4, 5. Okay, let's say if I'm talking about this particular sequence that you are seeing in front of you, okay, any particular thing that you can understand from over here. Okay, so let's just say if I create this sequence, so obviously we know that this is going to be your H1 over here. This is going to output your H1. This is your H2. This is your H3, and this is your H4. Okay, very much clear to all. And from over here, your sequence goes into your decoder. Okay, onto over here, where this particular sequence is basically S0, S1, S2, S3, and S4. Okay, and this is basically your end of statements. Right now, thing is, guys, let's say everybody, okay, let's say if we are working on this particular time, okay, and we are doing basically all the generations before this has been done. So we have some set of text with us. Okay, so there is some set of text that has been already generated. Okay, generated text, and there's a few text that has to be generated very, 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 very clearly. If I'm talking about the generated text, and if I'm talking about a text that has to be generated now over here, now don't you think the previous word is also important? Yes, sir, guys, the previous timestamp is also important for us, correct, to understand the context, right? So for the previous context, or for understanding the previous nature of the data, right, can we write that this particular equation can go something like this, that yi minus 1, okay, with respect to whatsoever sequence we are going to calculate. Like let's say if I am talking about S2 over here, so I'll also look at the S1, that what was the previous situation, and then I'll also look at the attentions that we are having, that is ci, right, correct. But how exactly things work over here? So here I introduce you all the concept of alignment score, or in very simple words, you can say similarity, right? So how exactly your encoder decoder will understand, guys, that this word is very much similar to your current context or the previous context? For that, we need to have some similarity score. like how much similar these contexts are with respect to that particular situation, right? So let's say, for example, if you check it out over here, so for this current given time sequence, okay, I'm talking about this particular time sequence. If I talk about this time sequence with respect to this particular given time frame, so what we'll do is we will try to check for the similarity of this particular time sequence with each and every given particular time sequence in the encode, with this, with this, with this, and with this. And these all are basically your alphas. Okay, so let's say alpha 1, alpha 2, alpha 3, alpha 4. Okay, these are basically some of the weights that you can assign. We'll talk about the weights again on the just upcoming few minutes. Just trying to give you an overview. So now guys, tell me, if we are having 4 set of weights, and if we are having a particular time frame in which we have to judge at which particular given hidden state is important to us, can we check the weights, and depending upon the importance or the highest weights, we can say, okay, this particular given time frame will be most suitable for you. The approach of weighted approach, is it better or not? You can easily find out that, okay, this word can be the very best fit for the current particular situation using the weights equation, right? Now let's understand this, how exactly these weights are going to come into play. Okay, like how this thing came in. So this alignment, okay, this alignment score, okay, this is given by the encoded hidden state from your particular encoders. Okay, here you can see, okay, these are the states that give you this weights. Okay, so H0, H1, H2, H3, H4. Okay, so the alignment model takes the encoded hidden state. Okay, let me write it out for you. We take the encoded hidden state, that is HI, and the previous decoder output. Okay, that means, let's say if I'm talking about S2, so what is my previous decoder output, guys? If I'm talking about the current situation, I'm at S2. So what is our previous decoder output? It is SI minus T, correct? Previous decoder output, right? So basically, guys, this whole thing will be used to compute a score that is called as ET at the given situation I. Okay, this is what is called as alignment score. Okay, this indicates basically, okay, this indicates how well your input sequence, okay, how well the input or the elements, okay, the elements of the input sequence align to the current output. So it's very much obvious clear that you are taking the encoded vector from over here and the previous vector, and then you are trying to find the similarity between both of them. So that is what exactly is the concept of alignment score is. Okay, you try to find out the similarity between two of the given sequences. Okay, the alignment model over here, guys, is always, okay, the alignment model you are seeing over here, this is always represented by something called as A dot. Okay, that you can implement using the feed forward neural net. Okay, at any particular given time T and for any particular given sequence I, your particular attention will be something like this. This is your attention score. Okay, like how much similar that word or that particular input sequence is with respect to the given particular output sequence. Okay, so now tell me, guys, here's a question for you. Let's say that we are having around 4 input. Okay, we are having in total 4 input, and there is 4 outputs. Okay, so in total what I'm saying is you are having 4 inputs, okay, and there are 4 outputs. So how many input or how many attention scores you will get into this situation, guys? Everybody tell me. Let me give you one particular idea. So these red lines are basically your attention score. So tell me, guys, if you are having 4 input and 4 output sequences, how many attention scores you will have in total? Go ahead, guys. It's a pretty easy question. You guys have the diagram in front of you actually. Because see, guys, it's very easy to understand. See how exactly we came to this conclusion. Okay, let me define you. So if I'm talking about this particular given sequence, these are your output sequences, right? We need to check for each output sequence with respect to each input sequence, correct? So here in total, we are having how many outputs? 4 outputs. How many inputs? 4 inputs. So for each and every output, we are going to check corresponding with each and every input. So 4 at a time. In total 4. 4 multiplied by 4 is 16. Simple as that. Done, understood. Right? Why are you thinking about it so much? It's a very easy question, right? Now, we have got our attention, right? But this attention, we also need something more on this. Okay. So we need the concept of weights actually. Okay, because we have found that, okay, this particular thing is having this much relevancy with the output sequence. But what is the weight? What is the complete importance of it? Okay, so for the same, guys, let's say if we are having an encoder decoder sequence over here, okay, so what do is we assign some weights to the connections that we are having. Okay, So let's say for any particular given LSTM cells, you are going to have some particular like kind of, you can say, the connection or the attention with a particular given word. I am trying to draw right now. Okay, so have a check. Now what we'll do is we'll assign the weights to each one of them. So let's say 2 1, 2 2, 2 3 and 2 4. If let's say given your output sequence that 2, so what is the importance of the 1? Okay, that is your HI equals to 1 over here. And here we are having 2, here we are having 3, here we are having 4. And the sequence ST minus 1 is equals to. So if I follow this equation that I have written over here, so if I write alpha 2 1, that will be basically equal to A of, it will be S2 H1. So this will give you attention over here. But we still have not came across the weights part, so we'll assign the weights, okay, like how much based upon your attention. The same thing actually, based upon the attention, the weights will be assigned, okay, that how much say a particular relationship, or how much say this particular relationship is going to have in determining this particular output. Okay, that is what exactly the weights concept will do over here. Now I think mostly all of the part is done. We have got this idea. Now let me tell you one more thing, guys, that is very, very, very important for you all. You might be thinking, then you just told that attention mechanism, like attention score plus the weights, how exactly it works. So in order to assign the weights, or in order to assign the weights to this particular given relationship, do you know, guys, we will have to use a kind of a mathematical operation over here, right? Don't you think? We'll have to go ahead and we'll have to apply some mathematical operation over here, right? So what is the mathematical operation that we can use over here? So let's say for any particular given sequence, okay, let me tell you guys. For any particular given sequence, everybody, we need a function. Okay, let's see if I want to find out 2, 3. So I need a function that can help me find the attention between H3 and S1. For example, let's see. Okay, so now what is going to be this function, guys? Sorry, anyone? What is going to be this function? What is going to be this f? Which particular function will cover up? So have you guys heard about ANN, by the way, everybody? Have you guys ever heard of ANN? Artificial neural networks? Right? So if you guys might have heard about artificial neural network, this is also called as universal function approximation. Okay, so basically, guys, see what happened was when the research was going on to this field about transformers and all. So when this equation was introduced, so everyone was like, okay, let's try different equation and let's compare them statistically and empirically to find out which equation is very good. But the ones who were smart, what they have done is they told that, okay, we already have something called as ANN that itself is a feed forward network. Okay, it basically passes the data back and forth. Right. So why don't we use this function to solve this equation? And that is how this formula came into play. Now, due to this particular consideration, what happened was, when you try to assign some weights for any particular given sequence of out to any particular given sequence of inputs, okay, let's say what happens is, okay, there is a ANN that has to be set up over here. Okay, this ANN can have any particular number of hidden layers. There is no issue with that, and any particular kind of weights and bias. Now this ANN actually gives you the exact weights for this given relationships. Okay, and obviously if we are training the entire sequence of encoder or decoder, so automatically this sequence automatically gets trained, and this defines the weights, and based upon the weights, your particular input or output sequence decide which particular time frame has to be given the more importance and which one has to be given less importance. And this is in a gist about the attention mechanism. Like this is how the attention mechanism works actually.
Just a quick info, guys. Intellipaat offers generative AI and prompt engineering course, which will help you gain proficiency in creating generative AI chatbots and other GenAI tools, along with mastering the latest tools and techniques with hands-on projects and real-world case studies. And the best part, this course will be taught to you by IIT faculty and the top 1% industry experts. What's more, you'll be getting your generative AI and prompt engineering certification from Microsoft. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description down below. Without a doubt, this course can set your careers to new heights. So visit the course page link given down in the description below and take your first step towards your journey as a Gen AI engineer.
I'm going to discuss about Hugging Face. So this is the platform where you guys can work. Okay. So the Hugging Face, if you just search on the internet, okay. So if I search about Hugging Face, okay. So it's basically a American company that goes ahead and that works on the computational tool for building application using machine learnings. Okay, so there is a GitHub page also for Hugging Face, like what exactly they're doing and everything, and it's a public page by the way, and it's a verified account. Now let me tell you what exactly Hugging Face does by the way. So guys, you all are already aware that we can make transformers, but don't you think it's a very complicated process to go ahead and make a transformer by own self, right or not? Transformer requires a lot of procedures, right? We have to firstly pass on our data. The data would be encoded, then the decoded data goes into the part of your decoder, then positional embedding, weights, your particular importance, then keys, values, queries, and these all things. Then after softmax, then conversion. There's a lot of things that goes with the part of transformer. So don't you think if I go ahead and if I code up my own transform from scratch, it will take a lot of time, guys? Yes or no? Right? So Hugging Face is one of the most popular libraries for any of the machine learning tasks, mainly for NLP, computer vision. Okay, so it has basically revolutionized the field of AI, you can say, by providing a platform which anyone can access with the latest model, like in the domain of CV, NLP, and all that. Okay, so let me just show you the page once again so that you guys can have an idea about what we are talking about. So if I go to this Hugging Face part, okay, let me share this particular code with link with you all. If you look out to the particular interface over here, so you have a lot of things. Okay, so if you want to go ahead, you want to learn about transformer documentation, go ahead, open it up. See, you have your transformer documentation. Everything that that needs to be done in transformers is over here. Okay, then if I go ahead on the models hub that you can see over here, so there's a model hub basically in which you have around 8,58,583 models. So guys, have you learned about pre-trained model by any chance? I guess in your CNN classes, maybe before CNN classes, you guys might have gone through this top pre-trained models where you guys might have done transfer learning using like maybe Cypher 10 or VG16 or ResNet, right? So if you guys are aware about those pre-built models, so this is a hub where you have all your pre-built models, okay, for different tasks. So let's see if I'm talking about zero sort image classification. So you have 560 or such models. Okay, similarly, if I go ahead and if I say I want to do marks generation, so I have 139 such models. If I talk about image to video or text to image, you have around 31,000 models for the same. Okay, so basically these models that you are seeing in front of you, these are implemented on the basis of transformers, and you guys can directly use it using the Hugging Face. So earlier what used to happen was like companies like Microsoft, Google, and any of the big like X Labs, Meta, Mozilla, they used to make their own transformers on their own silos. Silos means individual data. So when a particular organization was going ahead and when it was trying to make its own transformers in on its own platform, so the issue was not everyone was getting the access to this particular high-end transformers. Because see, let's say if I'm a human being who wants to do some specific task, so for that actually I'll have to create my own transformer. Correct, everybody? I won't be able to access any of the transformer that has been pre-built. Like let's say over here, if you are seeing, so we have a model given by Microsoft. See, Microsoft 5 3.0 MOE instruct. Okay, now thing is, guys, see, if you look onto this model, let's say if you would not have this particular platform with us, that is your Hugging Face, we won't be able to access this model directly. For the same, we will have to go ahead, we'll have to take the subscription of Microsoft, we'll have to purchase it up, then we'll be able to use the model, okay, on their own Microsoft platform. But Hugging Face is a kind of like, you can say, a central repository where you can find most of the available models or most of the available techniques or the LLMs that are available, and you guys can directly use it like without any explicit permission. Even let's say if I open up any of the model over here, okay, have a check, guys. Let's say if I open up a model over here and if I want to use, see, I can use it using the transformers directly. No need to go ahead, no need to do anything. Okay, so even if you want, you can test the model. So let's say if I want a question, right? So I can say the world tallest building is, see guys, everybody, you guys can go ahead and literally you can ask the questions from this model. Like this is a BERT model basically. Okay, so you guys can go ahead and do anything out of it. So let me just put up the definition over here so that you guys can have a pretty much good idea about what we're talking about. So this definition is about Hugging Face. Firstly, introduction to transformers. We are doing Hugging Face. Hugging Face, the place of transformer or the repository. Okay, a repository of transformers. Okay, and moreover, I'll just copy paste a definition that I have taken somewhere. Here it is. Sorry, have a check. So basically, guys, Hugging Face is a platform, practical student decoder. Yeah, it's on the entire architecture of a transformer. Dear. Not only about a decoder, it's about the entire architecture of transformer, like everything that we are having. Now, moving forward with the same, everybody. Now I think that this part is already clear to you all, so I don't need to go ahead and explain this. So this is the Hugging Face part where you guys can go ahead and you guys can do like almost every task that is there in Transformer. So now, why it is one of the most important platform? I think we've already discussed about that part. So before Hugging Face, as I told you all, the research in the field of NLP or the computer vision was conducted in silos. Okay, silos basically means the individual platform. Okay, when it was very difficult for any of the community to directly access this research or the latest model. So basically, what Hugging Face is doing is it's kind of democratized the research that has been done by the users, different users, and gives you the state of the art, or you can say unique models. So obviously, like you guys can directly use any of the models, and that's a big leverage. Like you can just use the API of Hugging Face, and you can use any of the model of your choice, right? So basically, Hugging Face has made it very easier for each and every researcher that is out there, each and every developer that is out there to incorporate any of the models. Okay, not about only about NLP, about computer vision model, about object detection model, about any of the model to be directly implemented in their application. Like using this platform, you can easily download the model, you can easily fine tune the model, and even if you want, you can create a custom model of yours. So I'll just keep putting this thing as note points. I know these are not very much relevant, but though if you guys want it at any particular given scenario, it will be there for you as a help. Okay. And let me put this as a link, by the way, so that you guys can get a fair amount of idea. So over here, I'll put it as Hugging Face. Okay. So you have a link to Hugging Face over here. If you will just click it, you will have this redirection notice, and then you can click it over here. You'll be redirected to Hugging Face. Okay, moreover, what I'll do is I'll give you the link to the hub as well that we were seeing a bit earlier. So this is your hub link. Hub is basically the particular screen that you might have seen on my window. This is basically your hub, the model hub of Hugging Face, where each and every model is present, like for everything. So any particular kind of thing you want to do, you want to check out for the libraries. So we have PyTorch, TensorFlow, JAX, Transformer, Safe Tensor, TensorBoard, like all the particular given library that supports the transformers. Then we have datasets. If you want datasets, you have a lot of datasets with you. So Mozilla Common Voice, binarized, anything that you want. Okay. Then you have languages. You have different languages in which you can go ahead, and they're like around 5,000 languages in total. Then licenses and then other things. So everything is over here actually. Okay. So this is your Hugging Face and this is your hub. Now you might be thinking then, Dave, what is this notebook all about? Like what exactly you're trying to achieve by doing your task in this notebook. So here's the catch, guys. Okay, this notebook is all about describing you how exactly, okay, like how exactly you guys can go ahead and how exactly you guys can explore the functionality of the transformers using the Hugging Face, how you can build, how you can go ahead and how you can do your task of NLP using the Hugging Face and everything that is there. Okay. So what we are going to do is we have seen that mostly when we are using this part of transformer, when you're learning transformers, we have noticed that most of the time we guys have used the tasks of NLP itself to understand the process. Okay. The learning objective of ours is to create such thing that can help us. Okay. Or that will basically, we can say, that can let us understand the use case of transformer using the Hugging Face, right? But using the Hugging Face model and transformer together. Okay, so let's go ahead and let's try to understand the scenario, how exactly it works using the Hugging Face, and let's try to also uncover the functionalities of what exactly this whole thing about the transformer that we have learned till this point of time works. Okay, so here, like I'm trying to create a flow that you guys can just check it out once. Okay. So this is your learning objective and everything is mentioned over here. So if you guys want, okay. So you can see over here in this notebook, you will be exploring the different features and functionalities of Hugging Face library. You'll also look at the different pipelines and demonstrate them how to use them for NLP tasks like sentiment analysis and text generation and name recognition and name entity recognition. Moreover, you can also learn about how to load a pre-trained transformer for doing any particular NLP task, and how we will dissect the pipeline of the Hugging Face and customize the process for any need. So this is all the things that we are going to learn in this particular class. So it's a kind of like a hands-on transformers. So onto over here, we guys have mostly covered up the introductory part of, you can say, the Hugging Face. But what about the starting of the journey? So what we'll do is we'll divide task by task. Okay. So here's your task number one, or here's the task zero. Installing the transformers first. That's the very first task. Now here's the catch, guys, everybody. To use the Hugging Face, okay, in order to use the Hugging Face, you need to install transformer library, and obviously you can like do it using the pip command. Okay, so let me write it over here as well. So to use the Hugging Face, you need to install the transformers library. You can do it by running the following command in the Jupyter or Colab notebook. So I think in Colab you don't even need to run this command basically, because automatically in Colab we have the support of transformer. But still, if you want, you can run transformers over here. Okay. This will give you the access to the transformer library of the Hugging Face. Moreover, I think you guys are already aware that you need a TensorFlow and the Keras, so I think it's already there for you all. So in case you don't have transformer, please do run this command. So I already have transformers with me. So you can see it is saying requirement already satisfied. Okay. Now once this is done, okay, now we move ahead to task number one. Okay, the first task of the day, that is your pipeline. Now pipelines are one of the most beautiful innovation and one of the most interesting innovation done till this point of time. Okay, why? So let me tell you. So it's basically kind of like a high level API, okay, that hides most of the things from you. So let's just say, first let me show you the implementation, then we'll talk about what exactly this thing can do. Okay, so let's say, guys, that you want to do an LLP task, right? So for the same, there's a lot of libraries that you have to call. Like you will have to call the NLTK, then tokenizer, vectorizer, then again the bag of word corpus, this, that, right? What if I say that you just have to define one line that what you want to do and a job will be done? What do you think about like if you can do the same job in just one particular given sequence of like, wouldn't be amazing? So let's try to do this. Okay, let's try to understand what exactly firstly pipeline is. So what I'll do is I'll go over here and I'll change it to pipelines. Let's saying pipelines is not there. So huggingface.co slash, or we can simply say pipelines. Yeah, not this pipeline. Where is this pipeline wala part? I forgot what. Get this one. So pipelines, these are the great and the easiest way to use the model in inference. Okay, these pipelines are objects that abstract most of the complex code from the library. So I think this is the one of the most easiest definition that you can have about the pipelines. Okay, so directly from the documentation for you all, this is the definition from the documentation of Hugging Face. Pipelines are the great and the easy way to use any model inference. These pipelines are objects that abstract most of the complex code. Okay. Moreover, they also offer a very simple API for several tasks, like including name entity recognition, model language, sentiment analysis, feature extraction, question answering. Okay. So let me put that also over there in your particular books. Okay. So this is like the use cases of pipeline, everybody. Okay. Can be used. It offers, we can say it. Now, if you guys are not aware about the simple API or you can say a high level API, a simple high level API. So basically, guys, it is high level API is when a API doesn't provides you the entire depth information about anything. Basically, it just gives you the output that you are expecting. Okay, that is what exactly a high level API is. So as written over here, the pipelines are very great to use, but obviously you can go ahead and you can do a lot of tasks from it. So these are the some list of available pipelines, okay, that you guys are having in your Hugging Face, by the way. Okay, this is a list of the available pipelines that you guys can go ahead and that you guys can build in the sequence of the Hugging Face. Like all of them can be literally built in the Hugging Face. So whatsoever task I'm writing over here, they all are having their own pipelines with their own dedicated models to work upon. So if in case if you guys want, please do give it a try once at least. Okay, so this will be really beneficial for you all if you want to give it a try. Here, so yeah. So now what we're going to do is, I'm going to create a pipeline for you all. Okay, so pipeline, as I said you all, it's an object that encapsulates all the necessary details like processing, tokenization, model inferences, and give you the direct access to a model. So have a check on how do we create a pipeline. Okay, have a check, guys. How do we create a pipeline? Okay, so how do we create it? How exactly this pipeline part works? How exactly this whole operation of the pipeline is going to work? So have a check. So for the same, what I'm going to do is we'll firstly import few packages like warnings. And I'll say warnings.filter warnings. Sorry, filter warnings, and I'll just ignore them for now. Okay, so this is basically your warnings management. You can say this is your warnings management, where you're basically trying to manage all the warnings that may get arise during the session, okay, or during the code execution. Now, once done, here you'll be creating your pipeline. Okay, what I have done. Now have a check, guys. Let's say I'll take as a keyword like pipeline itself. So pipeline equals to uh, for that, firstly, we'll have to import it, or we can directly call it off as well. So I can say we have transformers. No, we have not imported transformers as well. So import transformers. Okay. And also along with the same, I'm also going to import the part of your TensorFlow, but not right now. We'll be importing that. So I can say from transformers, I want to import a library that is called as pipelines. Okay. That's all. It will take some time to run. It will configure it. So it's running right now. Let's wait for a few moments. Yeah, it's running right now. And now onto over here, I can mention that, okay, I want to have a pipeline that basically can do a job of, let's say, text classification. Okay, have a check, guys. Let's say this is your model. Okay, so in the model, we are trying to do a text classification. So if I run this code, see, you might notice it out over here, guys. No model was applied by default distilbert 2 base uncased fine tune assisted to assisted to English was taken. And you might notice that as soon as I run the code, there's a model that was downloaded. Have a check, guys. You can see model.save tensor. We are having a model that is 268 MB that is getting downloaded over here. Okay. And now once it is downloaded, let's check out what we can do with the model. So I'll say results equals to, we have model, and in the model now, we can pass our data. So give me any statement, guys. You also mentioned it's a part of Google. Generally, what happens is like TensorFlow, Transformers, Keras, they're already installed in Colab. But in case they are not, if you check it, if you find it off that it is not installed, then please go ahead and install it. Otherwise, if you guys are using the Jupyter notebook, over there is no such options as like you don't have Transformers or TensorFlow or anything installed like previously. You have to install it by yourself. So for that, actually, you guys have to like run the pip command every time. Okay. So let's say I'll take a statement from over here. So my statement is this restaurant is sweet. Okay, have a check, guys. So if I put it over here, if I run it, so I'll get some results. And if I output this results to you all, okay, so you might see you got a label. Okay. So let me just mention it out. I want to access 0th element, and in the 0th element, I want to access the label. So this says that this particular word, this particular statement that you have mentioned, it's positive. Moreover, if I go ahead and if I run the same command for the different thing, that is the score. Okay, so it's not saying a score, so you'll have to take a score only. So see, guys, it's positive, and we have got a score around 99%. Okay, it's 99% appropriate. This particular statement is positive. Now think of it in this way, guys. What does positive is? Positive means this statement is positive, dear. The sentiment of this state, the text classification. This text was classified as a positive statement. Okay, let's say if you write something like this, this restaurant is the worst one I have ever been. Have a check. See, can you see this statement? Read this out. This restaurant is the worst one I have been to. Right. So what you're doing over here, you're doing text classification, but think of it this way, guys. If I would have told you to do the same task, okay, using the normal AI or NLP or machine learning algorithms, how much time it would have taken for you? Around like 15, 20, 40 minutes so easily like right? There's no particular shortage that it will take like at least. Yeah, you mean as a human, yes. As a human, how much time will it take? Like in using a Google Colab and using some libraries like NLTK and everything. Not by just judging this statement. Like you have to use machine learning algorithms and all that to like go ahead and to classify this statement. So how much time it will take to say that okay, there's a negative statement? I think you'll have to code it up. right? Exactly. So using the Hugging Face, the same task can be done using seconds. So you might have noticed that I have just passed my statement. I have not coded any of the model. I have not I have not say that okay, which model I want to use. Automatically, I have just created a pipeline. I have mentioned the kind of task that I want to do. Okay, I want to do a text classification. I have mentioned text classification, and just as done, I have just passed my data directly to the model without worrying about what is inside the model and how exactly the model is working. So this is what exactly pipeline is. Okay, so you have a data, you know that what you have to do. You call a pipeline, you tell him that okay, this is my task, this is what I want to perform. When you go to write, you will take it to you will go ahead and you will you can directly pass your data and you can use it. So what is exactly GPTs are? So GPTs as written over here, these are the most initial language model introduced in 2018 by OpenAI to demonstrate the power of performing natural language processing using the transformer architect. So in the meantime, guys, while after 2018, there have been numerous number of changes that GPTs has been gone through. So we went from GPT 1 to 1.5, then to 2, then 2.4, GPT 3, then 3.5, 3.5 mini, and then we had GPT 4 coming up, GPT 4o, and then GPT 4o mini. So these are like the variants of GPT-3, GPT that we were having. Now, with the transformation that we have seen over the period of time, like from the starting from 2018, so at the very first initial phase, as I remember, I was going through a research paper. So for first GPT was trained on a very small corpus of data. But when it came to GPT-3 and GPT 3.5, the data increased tremendously on the amount of data that has been trained, that has been taken in order to train this particular models are enormous. Okay. So with the introduction of GPT-3 in 2020 marked a turning point because the model exhibits a remarkable performance for tasks like language translation, question answering, creative writing, right? And even further, GPT-2 provides two possibility to interact with OpenAI LLM. So user can visit to a browser, use a conversation style to perform the task, and alternatively, a developer can utilize the API provided by the OpenAI to integrate the GPT model into a LLM programmed models. Now, this is an important statement, guys. Okay, because ultimately, a lot of you might be having question, they why we are studying this LLM. It is none of our use. We already have GPT. We already have everything. So what is in the use case to it? So the use case comes here, guys. GPTs, LLMs, actually they work in a different way. So if you guys might have noticed, it's not actually GPT that is working, it is the LLM that is working in the backend. So if I'm talking about Gemini for an example, or maybe if I'm talking Perplexity, if I'm talking about Perplexity, for example, so the thing is, this over here is just an interface. You're basically interacting with the API. In the back end, the LLM is working. Okay. In the back end, a application is working. And that this particular phenomena, this particular technique through which you use the API of a particular LLM in order to utilize its functionality is what is called as a LLM powered application, or to understand that you can say it's a LangChain, it's a language chain in which you go ahead and you perform the if you develop an application that utilizes the capability of a LLM in order to do your tasks. So this is kind of an implementation to it. Okay. So here, this particular application that is the Gemini, okay, moreover, you can say. So basically, Gemini over here is using the API of the Google Gemini platform, or you can say the Palm, and using the same, it is giving you the answers. Okay. So you do have different like frameworks for, so LangChain is one of the framework. Then you have other frameworks are also available. Okay.
Just a quick info, guys. Intellipaat offers generative AI and prompt engineering course, which will help you gain proficiency in creating generative AI chatbots and other GenAI tools, along with mastering the latest tools and techniques with hands-on projects and real-world case studies. And the best part, this course will be taught to you by IIT faculty and the top 1% industry experts. What's more, you'll be getting your generative AI and prompt engineering certification from Microsoft. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description down below. Without a doubt, this course can set your careers to new heights. So visit the course page link given down in the description below and take your first step towards your journey as a Gen AI engineer.
We are going to move ahead and we are going to do some of the tasks using LLM so that you guys can get more hands-on clarity, and I'll give you some models also to work on basically. So again, we'll visit the model hub directly. Okay. In the model hub, let's say I'm going to go with a summarization task. Okay. And we'll take a model that we can use over here. So let's say I'll use this model. I'm not sure if it is paid or not, but let's just see this. So it's an inference model. This model doesn't have enough activity to be deployed to inference and surveillance in paid. Okay, fine. Okay, see, basically, whenever you're working with any kind of like text to text part, or maybe like a kind of model where we have text as an input, so transformer, they have this tendency to like capture the context really great, right? So that is what exactly your transformer based models are. Generally, what happens is like the very first kind of model that was built on transformer was BERT actually. Okay, your bidirectional. I guess there's some particular full form that I'm forgetting. Let me search. I guess to bidirectional. The BERT is actually text to text model. Okay, so it's basically bidirectional encoder representation from transformer. That is the full form of BERT actually. That was the first kind of model that was used for like kind of going ahead and to kind of doing a self-supervised learning task to represent your text-to-text sequences. Now, once BERT it came into play, after that there are a lot of models that start coming to model based upon BERT. Okay, so like for text generation, for text summarization, text classification. Okay, so whenever we talk about this text part, so automatically transformer comes into play because base of all of these models are based upon transformers. Okay, because they have the self-attention mechanism working side by side, they have their every context working side by side. So ultimately, these all things are only possible with transformer architecture. That is why this is called as a transformer based models. There are a few classifications that I can tell you, like whenever we are talking about, so understand it like priorly that it is all going to be text. Okay. But here's a kind of model that is never going to deal with any image or any sound data. It's only going to go there, it's only going to be in the part of text. Okay. Now, if I talk about Meta or Llama or maybe any particular that kind of model, that are basically the generation models. Okay, text generation. Again, they are also text models, but they are specifically for generation of text. Okay, the long, huge contextual text like your Perplexity, your Claude, and all that. Then, if talking about the diffusions, okay, wherever you see the word diffusion, it is basically image generation model. Okay. So the first is data challenge actually. Data challenge basically means that your model needs to understand that what kind of data it is working on. Okay. So let me clarify that part, like what I mean to say over here. Okay. What exactly is my understanding to these all things is. Okay. So the very first part that I've written over here is data bias. Okay. So when the training data is used to develop a LM models, okay, the training data can be biased, guys, and I guess you all will agree on the same that any data that we are going ahead and any data that we are passing to large language model that can be biased and can be imbalanced as well. So the model can learn and pre-compute those bias also in its output. Okay. So example, let's say if a model is trained on a data set that is having only the example of let's say people that are having gender as male, the majority of the population is having gender as a male, right? So maybe if we use that data to generate any medical output, right? So it might not give us the consistent output, guys. Is my understanding correct? Because the body, that a male and a female body, if I compare, so both are having different different kind of adaptiveness, right? So male body is maybe less adapted to something than female bodies that are less adapted to something. So let's say if you have trained a large language model majorly on the male patient data. So don't you think, guys, when you will ask that model something, the model will generate the output. It will be good, but it won't be very specific to to a particular patient who can be female. So that is the very first part actually that needs to be understand that the data should be not biased. Okay, whenever you are training a machine learning or a large language model, the data needs to be checked thoroughly before moving ahead and giving it to the model. The second thing that might you notice over here is limited world knowledge and hallucination. So let me talk about. So LLMs may lack the comprehensive understanding of the real world event, guys, or the information or the knowledge about a specific domain. Now, this particular thing, okay, when you lack in the understanding of real world events or the information or the specific domain, that can lead to generation of the incorrect, misleading, and nonsensical responses is called as hallucination. Okay. Now, for example, a LLM might confidently state a fact about a historical event or may provide incorrect information about the scientific concept event. And I guess you might have been through this particular phase, guys. If you might have used ChatGPT, so just try any question over there in ChatGPT, okay, and try that. I think I'm not sure that if this answer is correct or not. You might see that chat GPT will send you another response for the same, saying that, okay, I might have missed this thing. This might not be the correct output. Please have a check on the other part of the solution. Have you guys ever given a try to it that you guys have analyzed it? Okay, chat GPT or maybe any particular large language model might have given you the wrong responses. And I guess it happens a lot of time if I'm not wrong, right? So basically, that's the thing that you need to also understand, that the large language models that are there, right? They don't have, like, they need to have the proper idea about the real world scenarios and everything. So this particular phenomena can undermine the reliability and the usefulness of any large language model that are preparing, especially when the application of these particular application are crucial, like a medical diagnosis or the legal advice or like the business industry. Then the dependency on the training quality, the data training quality is also very crucial, because the performance of a large language model is heavily influenced by the quality and the representativeness of the training data. So model that is trained upon a small and a biased data might struggle to generate the accurate information and the responses. Okay, and this will narrow down the scope of your research or maybe anything that you're trying to do with that large language model. Now, if you do so, the impact will be that the low quality or the insufficient data can limit the capability of the model, making it very much vulnerable to any error or the biases that you are going to have. Okay, and your model will be really like exposed to everything. Okay, you won't be able to get good output. You won't be able to understand everything perfectly. Your model won't be able to understand this very thing, like everything very clearly. Okay, and that is the worst part of any large language model. Okay, then we do have technical challenges that, again, like I guess everyone is already aware about these challenges. So these particular models, all of them are very computationally expensive. You need to have substantial computational power to train these kind of model. Like you should have GPUs or TPUs. And by the way, we also have something new in the market called as NPUs now. So have you guys ever heard of this? I guess GPU everyone has heard of. Have you guys ever heard of TPU and NPU, guys? I think NPU is very new nowadays. I think it came around like back 3-4 months back, if I'm not wrong. I'm not sure if you guys have heard about TPU, but I guess I'm very confident that you guys all have learned, like all have already heard about GPU. So let me tell you guys what is a TPU and a NPU is, by the way. Okay, so NPU is basically a neural processing unit, and TPU is tensor processing unit. Okay, and these particular kind of hardware is specialized in hardware acceleration to efficiently manage the computational demands of machine learning, particularly about the large language and deep learning models. Okay, so if you talk about TPU, so TPU was generated by Google, by the way. Okay, and NPU is generated, like it was developed by Huawei. So I guess you guys might have noted, might have like heard this name somewhere before. So Huawei is actually the company or the organization that has produced the NPU, the neural processing unit. So TPU is very much famous nowadays because obviously of the silicon architecture. I guess the ones who are too into the mobile industry or too into the tech, they are already aware of what exactly silicon chips are. And the NPUs, they work on the like the architecture of neural networks. Okay, so if you talk about the strengths, so the TPUs are very much good with the TensorFlow models. Okay, they are very much reliable. They are very much energy efficient. If I talk about the NPUs, they have a very strong configuration with the part of AI frameworks. Okay, so both of them are having their own particular, like you can say, pros and own particular cons. For the research, you can have a look onto the internet. There are a lot of things available on that. Okay, going ahead, going forward, the next particular issue that we have over here is on to the part of evaluation. Okay, so if you want to access the performance of a LLM across different tasks or domain, that could be a complex challenge because there's no such standardized evaluation metrics. Because if you might have noticed in the regression or in the classification, you had a lot of matrices onto which you can identify the model and you can say if the model is good or bad. Similarly, in the AI as well, you had a lot of matrices to configure and to evaluate the performance of a model. But here we don't have such kind of matrices, so it is very difficult to evaluate a freely generated content. You don't know that if this content generated is good or bad. Similarly, the fine tuning is also a challenge if I talk about the large language model, because the very first thing is that already a model that is pre-trained, okay, to a specific task, okay, or to a very general task. Now you need to narrow it down to a specific domain. That's a very big issue because the model is already trained on a general purpose data, and now you're going to train it on again on the part of a domain specific data. Okay, so maybe a fine tuning, if you take an example, so if you're trying to fine tune a general purpose large language model for answering medical questions, so it might require careful consideration of some specific words, terminology, or the context in the medical domain. If your model is not able to understand those, that will be a very big problem for you, because the fine tuning task or the fine tuning challenge that we're trying to achieve over here will be incomplete. And the fourth thing that I have mentioned over here is contextual understanding, and that is very much relevant, because the main issue that always the large language models and any particular generation model face is that they need to remember, or they need to maintain the coherent context over the long passage or the conversation. Okay, so if I go ahead and if I share, maybe let's say this particular screen with you, allow me to share it out. Where is this? Yeah, this one. See, guys, I've opened Gemini. Okay, now see, if you remember, this was the question that we were doing earlier yesterday, right? Now see, if I talk about what was the first question that I asked. Now see, if this particular model is able to recall that, that will be perfectly fine. Now see over here. Unfortunately, as an AI model, I don't have access to your personal history or the records of our previous conversation. See, check this out very clearly. I asked this question in the very starting, and it is just two conversation about, right? So I guess now you guys are very much clear with what exactly the fourth particular point suggests. Because AI models, they very much struggle with this thing of remembering what has been asked previously. I guess this was the same thing that I told you earlier about the LLM, that they don't have their own memories to store something, right? I guess I have also shown you why exactly I have mentioned these points. So these are from my expertise, what I have like what I have observed for the long period of time. Okay. Types of LLM, and this is a very important concept, by the way, guys. So the very first part in the large language model is on what basis we are going to categorize the large language models, and that is very, very, very much important for you to understand, like how exactly and on what basis we segregate the large language models. Okay, so let me tell you guys a very interesting history about it. So I guess when we guys were working on the concept of transformers, right? So you guys might have noticed that when I was working with transformer, I was directly using the Hugging Face, and we were able to go ahead. We were able to use the concept of transformers, right? So basically, guys, that kind of transformers or that kind of learning models that you don't need to go ahead and you don't need to train explicitly on a given piece of data, they are known or they are considered in the part of zero shot learning. Okay, so zero shot learning is a practice where you don't need to train, you don't need to go ahead and you don't need to train the particular machine every time. Automatically, what will happen is that once the machine is trained on the corpus of data, it will remember the thing. Okay, it will remember automatically what exactly are these whole things. Okay, so zero shot learning is a technique in which you don't need to go ahead and you don't need to keep on you can say training the machine. You don't need to tell the machine, okay, this is what you have to do, this is what you have to do. Automatically, once the machine has been trained, right, it will be able to understand, it will be able to know that, okay, what exactly are the things over here. So traditionally, the machine learning models required examples for each and every class to recognize everything, right? In zero shot learning, model learns to recognize the objects or the concept they have never seen. Hence this is called a zero shot. That means you train the model once. Let's say there is a model of CNN, for example, that is trained on dogs and cats data set. Now once the model has been trained upon a dogs and cats data set, and even if it has not seen a picture till yet of any particular given animal, let's say, for example, it can also go ahead how it can, like if you have shown a picture of a lion, let's say, what is zero shot learning aims to is it will try to find out the gap between these two things, because it has already learned the images of dogs and cats. Now based upon the understanding of dogs and cats, it will try to identify under which class or under which particular given data part this particular image will come. So you are not going to train the machine explicitly on the same. Okay, so the core concept of the zero shot learning is to connect what model has seen to what is it isn't has seen till this point of time. Through this particular thing, it will try to understand on the previous data, like whatsoever it has learned till this point of time, based upon the same, it will try to predict. Now here you might think, Dave, how exactly this whole procedure might go on, like how exactly this whole thing that you're saying, it might work in the backend. So there are three things that are actually associated with it. The first thing is, the first very important thing over here is the semantic embedding space. So let me write it down for you all. Okay, give me a second. Let me create a copy of this notebook, because I don't want to disturb the original one. Okay, so on to over here, guys, in the zero shot learning model, if I write about it, so on to over here. These are the three things that are really important in the terms of zero shot learning. Okay, so the very first thing is semantic embeddings. Okay, the second thing is your model training, how exactly you're training the model, and the third thing is the inference. Okay, so semantic embedding basically represents the both seen and the unseen classes in the common space. Okay, you can always use the word vectors or the semantic description about the same. So basically, it's just to understand what exactly that picture is. So what exactly semantic means. So let me tell you guys about the semantic embedding space. So let's imagine you guys are in a library, right? So each book represents a concept or a word, you can say. The location of a book on a bookshelf signifies the relationship of that book with the other books. Correct or not, guys? Everybody, tell me. If there's a book that is that is there on a shelf written as non-fiction, so that means that book is related to the non-fiction part. Or for instance, if a book is about animals, it might be grouped with the books that are related to animals only. Correct. Now replace the books with words and the bookshelf with the multidimensional space, everybody. Now think of it in this way. Okay, think of it, guys. Just replace the books with the words, okay, and the bookshelf with the multidimensional space. You'll find yourself in a place that is called a semantic embedding space. So basically, the position of the word in this space reflects the meaning and the relationship of this word with the other words. That is what exactly semantic embedding space is. So if you just consider the example of a library, a book that is kept somewhere, anywhere in the library, has some relationship with its surrounding, that where it is kept, which along with what books is had been kept, right? Because obviously if you go to library, you see that there is a different categorization of the same. What I meant to say is the same happens in the semantic embedding space as well. So when you put a word in this space, it basically tries to find the relationship with all of the words that are there in that particular surrounding. Okay, so that is the very first thing using which the zero shot learning works actually. So you just need to put the data. If you take the example of dogs and cats that we have just taken right now, so in the same example, what happens is if your machine has already seen the dogs and cats data set, so imagine that your machine is already trained on dogs and cats data set. Now, if I put a picture of lion into over there in that particular space, now what will happen? That machine will try framing up the relationships with that particular image, and based upon the same, a categorization will be formed, and that is what exactly zero shot model does, everyone. I hope I have tried to clarify you to give you an understanding on zero shot learning. Now, moving forward, the second particular thing is multi-shot learning models. Okay, so multi-shot is basically where you just need to provide the context and you need to work on it. Okay, so zero shot and multi-shot are very much similar to each other. There is no there's a very small difference that I'll tell you in the implementation part directly. But the main concept that I would like to tell over here is about the fine-tuned or domain-specific model. These are the one that are very much important. The reason behind is, say guys, that if you are using ChatGPT or if you're using Gemini for example, okay, so these are very generalized, or these are very generalized machine learning, or you can say generative AI models. But the thing is, if you look on with the business perspective, right, do you think these are very good with the business perspective? Business perspective, what is your understanding to it? Is it a good model with respect to a specific business? Let's talk about medical industry for example. So do you think ChatGPT or maybe Gemini or maybe Claude or maybe any particular given GPT model, is it very specifically designed for a particular domain? No, right? That is where the fine-tuned or domain-specific models comes into play. So these particular models can be either a model that is already existing, that means maybe your ChatGPT itself. It can be like this, that either your ChatGPT model can be, after its own training of GPT, can be retrained for a specific task, or you can create a specific GPT model, or you can create a perfect LLM model for a specific domain. So if you guys might not have heard, let me give you an example of it. Have you guys ever heard of this particular thing, guys? Bloomberg GPT. Has anyone heard about Bloomberg GPT, by the way? No. So Bloomberg
We
GPT,
haven't.
guys, is actually, this is a financial GPT model, and it only works with the finance part. Okay, if you ask it any general question, it won't be answering that. If you see this paper, this is a official research paper for Bloomberg GPT, and you can see over here the use of NLP in the realm of financial technology is broad and complex, and this particular Bloomberg GPT is one of the implementation and one of the best implementation of a domain specific LLM. So if I show you the actual website where this Bloomberg GPT works is, I guess you might have heard about this company called as Bloomberg already. They are basically a company that works with the stocks and all. So see guys, this is the Bloomberg channel by the way. So if you open it up, this is a complete website that entirely works upon financial domain. There is no other specific things on which the Bloomberg works. And this Bloomberg GPT is one of the implementation where actually the fine-tuned GPT or the domain-specific GPTs are getting worked on. See, this is the Bloomberg GPT everywhere. And this is like a, if you open Medium, right, you will get a lot of things about it. See, what exactly Bloomberg GPT is. So see, Bloomberg GPT is a high-performance LLM for financial NLP achieved by mixing domain-specified and general-purpose data during the training. So I guess now the very first part about the fine-tuned, not about the fine-tuned specifically, I will talk about the domain-specific part is clear to all everybody, right? Because see what exactly this model can do. This language model can suggest news headlines, making it useful for the news application and assisting journalists in constructing newsletter. It takes the paragraph as an input and suggests the relevant title for the same. Okay, and why finance industry needs AI and all that, everything is written over here. So this was like first kind of like a kind of a model that was specified with a domain, and there are a lot of like this guys. So if you go ahead and if you open Hugging Face once and if you search on the same, so let's say if you want to work on the medical domain, right, and if you run it, okay, not medical, I just want to run about the medical domain. So see over here everybody, you have around 1362 models on the part of just on the medical field, and these are the models that are specific regarding a domain. Some of the models present over here can be fine-tuned. That means basically, let's say if I'm talking about Chat GPT, for example, over here. Okay, so you guys have already been using Chat GPT. So let's say you're having Chat GPT. Now, Chat GPT is a general purpose AI, right? Everybody, it's a general purpose generative AI, correct? Yes or no? Now you use this as a base model and then you tune it or you tweak it for a specific task. Okay, maybe for your financial task, maybe for your medical task, or for any task. So this process where you take a pre-trained model, okay, where you take a pre-trained large language model and you tune it according to your preferences to get a desired result is called as fine tuning, by the way. Okay, and this right now that we have seen the examples like Bloomberg GPT, the Claude and all that, that are the examples of domain specific models. Okay, so if you might notice our definition also that I have written is the fine tuning or a domain specific model represents a category where the model undergo additional training tailored to a specific task or domain after initial pre-training on a general data set. The task-specific optimization involves the training of a model on a dataset specific to the intended application. Some of the models, like biomedical field, are fine-tuned and are specialized in a specific domain, tailoring their knowledge and the nuisance to this particular context. So if you go ahead and Hugging Face, so obviously you can see there are a lot of things over here. Now, if I just open up any model over here, let's say if I talk about this medical AI, clerical birth. Okay, so see over here, guys, what exactly this particular model is. So this model card describes the clinical birth model, which was trained on large multicenter data of the corpus of 1.2 billion words. Okay, and that's a lot, guys, to be really honest. We then utilized a large scale corpus of EHR of the 3 million patient record. Okay, so that means basically this particular language model has been trained upon the corpus of like around 1.2 billion word with along with having a data of 3 million patients. Okay, so that means if I go ahead and if I see what is the job of this particular model is, so here you guys can use it directly from over here actually. So this is a kind of model that will help us for doing masking. Okay, masking basically filling the gaps. Similarly, if you go to the Falcon's AI, this model is for generating the summarization. Have a check, guys. Okay, so if you see, this is a complete report that a person has embedded over here. See, a complete report of a person. Now, if I click on compute, okay, see, the model is loading. Okay, and this is a very domain specific model. Okay, so if you might notice, this model is made up on T5 transformer model. Okay, so again, this is a fine-tuned model. You might see over here, see, fine-tuned for tasks like summarization of medical text. Okay, and see over here, guys, everybody, this is a summarization of it, right? So this is actually the fine-tuned model, how exactly the fine-tuned model looks like. So I guess now the difference between the domain specific and the fine-tuned model is pretty much clear to everybody. Okay, So the very first and most important thing over here is you need to understand the libraries. Okay, that what kind of libraries we are going to use. Okay, so there is only two libraries as of now that we are going to use. They are basically let me tell you in the prompt engineering part itself, side by side. So I'm going to install the transformers, okay, and the pipeline function. Okay, the pipeline function, or you can say the gradue. Okay, now this is the prompt that I have written for doing so. If I go ahead, you have your command for it. If I run it, you will have both the libraries installed and up and running in your system. So this is the first prompt that we have used, guys, over here. Okay, now once you are done with this, we will just quickly check up for the versions. Okay, for versions of both of them actually. So version check for transformers and gradue. Okay, so I'll write check the version of transformer as well as gradue over here. So this is how you do the prompt engineering, guys. Okay, you just need to be very clear with what kind of prompt you're using. Okay, so here it is running right now. We have imported transformer and gradue side by side, and this will give us the the versions, that what versions we are on. So we are on 4.42 or 0.4 for transformers and for 4.42.0 for gradient. Now what we are going to do is we will utilize the transformers, and I guess so what I'm going to use is I'm going to use the pipeline. Okay, now using the pipeline we are going to call a function or a call a model basically. Okay, so here I'm not going to mention any model as such. The main agenda is to show you how exactly we can use a LLM over here. Okay, so let's set up the particular pipeline firstly. Okay, setting up the pipeline for LLM. Okay, so here what we'll do is I'm going to create a translate pipeline that will help you in translation task. Okay, so kind of an NLP task. So I'll say pipeline, and you might see it's already mentioned over there what I want to do. Okay, so saying I want to do translation, the model is this. Okay, I'm not very sure if this model is going to work or not, but let's give it a try. Okay, see, it's loading up the data, it's loading up the model. Okay, have a check. This is a model that is of 506 MBs, by the way, and it is saying that your Hugging Face token doesn't exist in collab secrets and all that. So if you want, we can have our Hugging Face token, but for now I'm not considering that. So, and then what I can do is I can create a variable called as results, or way I can say that create a variable results that will store the result for us, that will store the result when we pass a statement, when we pass a statement from user input. Have a check, guys. So see, now what it is doing, it's just giving me a simple code saying that this is your result. And now if I print the results, you'll find out what is the result for it. See, मैं फुटबॉल खेलने के लिए प्यार. Okay, so obviously this model is not very much fine tuned, so you are getting this particular output. But I hope you all have got an idea that what exactly I was talking about. Okay, so a similar way, if you want to use a better, you can say a better kind of output, what you can do is I'll tell you this also. So setting up this pipeline number 2, setting up pipeline 2 actually. So in this case, what I'm going to do is I'm going to use a translate pipeline that will do English to France translation, but I'm not going to mention any model as such. Okay, so this is your pipeline number 2. Okay, so you might see it is working on a Google model. See, Google T5 base. Okay, see, and now if I go ahead and if I search this model on Hugging Face Model Hub, okay, this is a free model based upon Google. Okay, and the number of parameters that has this model has taken to be trained was 223 million. Okay, a lot of models actually. And this model is specifically for a task of translation from English to French. Okay, so if I go ahead and if I pass a statement over here, let's say in the translate pipeline, if I go ahead and if I pass a statement that is LSTM and deep LSTM is the base for generative AI. If I go ahead and pass this up, so this is your results, by the way, for the same. Okay, it will take time to run. Obviously, it's a bigger model, it's having more data, and then it is doing the conversion. So this is a task. I see LSTM, deep LSTM, ISLA based, they जो भी है, like whatsoever this output is, I'm not able to read French. Okay, so this is how we are invoking the LLM into our code. Okay, now the thing is, as you all know, that we need this outputs to be shown to the user. So for the same, we have Gradue as the platform. Okay, have a check. We have Gradue for the same. Okay, so firstly, we'll need to set up the Gradue for the same, like how exactly we need to do everything. So we will use a functional approach over here. We will create a function for implementation of Gradue. Okay, so this function will be something like this, or I can use a prompt engineering technique over here. Create a function to utilize is the conversion. Utilize the previous code. Let's see if it can do that. See, it can do that from over here. Okay, and this will return us a result. Okay, so we have got a function, and now what we can do is we can set up the Gradio interface. Okay, this is our Gradio interface setup. Okay, so in the Gradio interface setup, it's quite easy. If you want, set up the Gradio for the translate function. Now see, the issue over here is it is not able to figure out that what kind of function I'm talking about. Okay, so that means my prompt that I'm using is not very much appropriate. Okay, so what I can do is I can change the prompt, create a code to set up the Gradio interface for the given function translate. Now see, again it is not able to configure it, right? That means over here, what's the issue? Over here, if you see, it is not able to understand what we are doing, right? So for it, what we'll do, we can go ahead and we can create it by ourselves, because again, the radio is very new and maybe the LM might not be aware about it. So we can go ahead and create it. So for it, actually the procedure will be, we have about Gradio, right? So you can say Gradio dot interface. Now see, now it is able to understand it. See, okay. So it is taking a translate function over here. Have a check. This fn parameter is for function. What is the input that it has to take? Okay. And what is the output that it has to take? So for the better or easy understanding, what I'm doing is I'm going to put it simply as text. Okay. So that everyone could be on the same page. So my input is also going to be text. My output is also going to be a text. Okay. And this is my gradient interface now ready and built. Now just the last thing that we are needed to be done over here is we need to launch the interface. See, we need to launch the interface. Okay, so in order to launch it, it's pretty much easy. You just have to say launch Gradio interface. That's all you have to do. That's it. Okay, if I like launch and I'll say debug equals to true over here, in case if there's any error, so it will automatically debug that. If I run this, now see guys, it will take time, okay? And now see this output coming up. Okay, and this is actually a public URL. So here, if I write, hey, this is Dave on this end. Hope you all are doing it. Now, if I submit this one, the Gradio is running. It's saying connection error time dot. Why, sir? Why so? Because it's processing. It's taking time. Now, see, guys, you have got the output. So it's running. It's coming up now. It will take some time to come up. It will give you the loading page. So this is onto my second browser, by the way, everybody. Okay. See, it's running on my end.
Just a quick info guys, Intellipaat offers generative AI and prompt engineering course which will help you gain proficiency in creating generative AI chatbots and other GenAI tools, along with mastering the latest tools and techniques with hands-on projects and real-world case studies. And the best part, this course will be taught to you by IIT faculty and the top 1% industry experts. What's more, you'll be getting your generative AI and prompt engineering certification from Microsoft. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description down below. Without a doubt, this course can set your careers to new heights. So visit the course page link given down in the description below and take your first step towards your journey as a Gen AI engineer.
RAG, Retrieval Augmented Generation. Okay. So let me give you guys a very good idea before starting to this topic. Have you ever went to chat GPT and you ever have noticed that if you ask GPT the real time information, okay, it won't be able to give you the real time information. Have you guys noticed this phenomenon? Or maybe if you go ahead and if you ask the pricing of Apple as of Apple stock, it won't be able to give you that. Why? Because if I talk about GPT 3.5, let's say it was trained on a data till 2023. Okay, only till 2023 by the way. Okay, so now if you ask the question that let's say what was the current stock price of Apple as of today, it won't be able to give you that answer. Why? That is what exactly is the issue with the LLM. So retrieval augmented generation is an AI framework that enhances the quality of your response by incorporating the output to date. Everybody, this is the very important one. This technology, it adds the up to date and contextually relevant information from external sources during the generation process. So let me tell you this, everyone. Go to Gemini, open this up and search for what is LLM. Okay, now check this out, guys. This particular generation that you might see, this is just a contextual generation. Okay, see, this is just a contextual generation, nothing else. Okay, now if you open this links up, you might see from where it has taken up this documentation, from where this text is coming. This is what exactly the RAG does, or might be. Have you guys ever heard of perplexity? This is one of the best platform that I have seen that uses the part of AI. Okay, or the RAGs. So let's say if I talk about a normal question, a very normal question that you might think of to ask. No, I'm right now I'm not talking about real life. Like I'm just trying to talk about related to RAG. So that I can show you the implementation of RAG, then I'll show you in the real life context as well. So let's say if I talk about what is the let me just give you a question over here. So what is LLM? I'll ask just over here. Okay. So now see guys over here, you might notice it is giving you some sources over here, and then it has generated an answer. So what exactly are the sources over here? So if you might notice, this is what RAG is doing. You might notice over here, whatsoever output has been generated, what it has done in backend is it went over internet, it found out all the relevant details that is required in order to generate this output. And now based upon whatsoever things that has been generated for internet, it is trying to evaluate and is giving you the results. So you might notice that these are the sources from where these results are generated, and that is what exactly the RAG does. It tries to go ahead, it tries to give you all the context or frame where the particular text or from where the relevant information can be framed. The output that you're getting should be contextually correct and should be updated. Okay, so now if I go ahead and if I ask what is the stock price, so see over here, as of 28th August, the stock price of Apple as NSI index is approximately these $20. And you see from where this is picking the information. Check it out. This is taking the information from end money and investing. So this is what exactly RAG does, everybody. Okay. Is this understanding clear to everyone what exactly RAG is, by the way? So if you might notice also right now, if you go ahead, you can I guess in perplexity there are a lot of things that you need to explore. There's one more thing that I would like to show you. I'm not very sure where I think I see absolutely, but I guess I'm not able to find it right now where it was. I think I might have forgotten that. Okay, I'll tell you. There's one more very interesting thing that I was willing to show you all. And by the way, can you please tell me, is perplexity a fine-tuned or a pre-trained model? Tell me, guys. If I ask you this question, what is your understanding? Is it a fine-tuned or is it a pre-trained model? Anybody? Whatsoever your understanding, you can let me know. Like, what do you think? Is it a pre-trained model or is it a fine-tuned model? Fine-tuned, perfect. Exactly, Atul. This is a fine-tuned model, guys. By the way, guys. Okay. Now, there's one more specific thing that I would like to tell you about over here. That is when to use what. Okay. So it's not like there's no leverage that I'm talking about. Okay. This particular thing is better than this one. It entirely depends upon the use case that you're trying to go ahead with. Okay. So if let's say if you are using the model on a specific domain, the domain specific pre-training will be good. If you want to fine tune a model for different specific tasks and you want to keep it also the generalized model, then you can use the domain specific fine tune. If you're going ahead with RAG, so there whenever there's a use case where your freshness of the data matters, okay, that means your data should be real time updated and everything should be perfectly fine. That is where you can use the RAG, okay, and where the cost effectiveness is very much a proficient part for you. So that is where these three things can come into play. We are going to work more on the implementation part where will be using certain LLMs to leverage the task that we do generally in NLP by some library as a putting some few lines of code. Okay, perfect. Are you guys aware about API there, anyone? Like what exactly a API is, why exactly do we use API, and what is the like the core functionality working behind API? So guys, APIs, if I talk about, they are basically the interface that takes up the request from you and passes it to the server. Okay. So if I show you a general diagram or a diagrammatic representation of what exactly APIs are, so please have a look onto over here. Okay. So it's basically like this, everybody. Okay, this is basically an API. So you take a request, like let's say if I'm browsing through this website, so whenever you search something, right, what happens is a request is generated. Like let's say right now, if I search over here Flipkart, right, so basically this API, this is a request that I'm trying to give to my server, and in order to carry this request to the server, we have APIs. Okay, so it's basically like the waiter in the restaurant. Okay, so if you want to order food, you don't go ahead and you don't talk to the chef directly regarding adding it, you have the waiters for them. So you look on the menu, you request whatever you want, and then the waiters takes that request to the particular cook or particular chef. And then when the chef has prepared the food, the same response, that is your food, is returned to you via the API. Okay, so that is a very basic and a very like a common understanding of what exactly API is. So guys, as I discussed earlier, LLM is an open source framework available in Python and JavaScript to facilitate the integration of LLMs to develop the LLM powered application. Okay, it links your LLM to the external data sources and services. So basically, guys, if you're using a LLM, or if you want to use LLM to leverage your task, you guys can create an application that will be more or less powered by this LLM, and then the same can be used further on to enhance the productivity. Okay. Now, obviously, as I discussed over here, so I think when we were talking about these all things, about how exactly the LangChain and everything work, so I told you all that never ever it happens that you guys are directly going and you guys are using the LLMs directly. Okay, so if I talk about perplexity, for example, okay, so what perplexity does is you are not actually using any particular LLM directly over here. Okay, this is basically a LLM powered application, you can say. Okay, this is particularly a GPT powered or an LLM powered application onto which here whatsoever you write, that is basically going inside the LLM as an API. Okay, as a request. So if I write over here NVIDIA beats Q2 expectation, let's say for example the same thing, right? So basically what you have done, you see the API changes over here. Have a look, guys. If I go back, this is the Perplexity API homepage. Okay, now this is your first API. Okay, I'll mention the chat box. This is your first API. Okay, now once you search something, let's say what is semantic healing. Okay, now see how exactly your API has changed over here. See, check it out. This is your second API here. Now, if you notice in the API, you have a particular search key going on. See, let me zoom it a bit. Not this one. I want to zoom this. Fine, no issues. So if you see this, you have a search API going on, and it is asking you what is semantic healing with some particular additional data. So that is what exactly LLM also does. What they do is they take your data. Okay, they take this data, and this data is now transferred as an API. Okay, to the LLM. Now this API has a job to carry this payload to your LLM. Okay, and that is where the LangChain concept comes into play, because LangChain, as I said, it's a framework that will help you to develop these kind of libraries. Okay, these kind of applications by them. Okay, because obviously, guys, thing is that we don't want to build everything from scratch. Okay, if I go ahead and if I want to build any LLM from scratch, or if I want to build an application that is like solely and wholly is acting like a LLM powered application, that will take a long time to go ahead and to train the model, and then we need to feed the model the data that it requires, and then we need to pre-tune it or fine tune it depending upon the domain. So that whole procedure will take a lot of time. It will take a lot of training. It will take a lot of what you can say computational resources to get trained and to then get onto the platform. So in order to remove, or you can say in order to deplete that timing, or to like reduce the timing of this whole complexity, we can directly use the LangChain in order to go ahead and in order to facilitate a better application that works on the LLM to give you a better response. Moreover, if I talk about the LLM, so it is also kind of a toolkit that is very familiarized with the prompt engineering process. So by any chance, guys, are you guys aware what prompt engineering? Prompt engineering is basically a kind of technique that will help you to generate codes using the prompt. Okay, so as written over here, prompts consist of a set of instruction given by the user to guide the model in generating the desired response. It can be a question, a command, or any specific input prompt, or a meaningful or a contextually relevant output from the model. Now, the precision and the clarity of prompts plays a crucial role in influencing the output generated by LLM. Because, see, guys, I think you guys might have noticed in the Google Colab itself. Let me show you something. If I go ahead over here, I have a code block saying that start coding or generate with AI. So if I write a prompt over here, have a look. If I write import NumPy, pandas, and matplotlib, see, everything has been generated now. Okay. Now at the same time, but if I write something like this, okay, let's just say, for example, train a model using the data, okay, and evaluate the model, right? Now, thing is, guys, this particular prompt has no sense because you don't have a model over here, right? And there is no data as such. Correct. So this is what exactly the prompt means. So for input and output for both the condition, it doesn't goes only with one. For input and output for both of them, you need to understand that both of the things should be consistent. Both of the prompt should be consistent enough to understand like how exactly things are going ahead. Okay. So that is where the prompts plays very crucial role. And LangChain provides you predefined templates of prompt for common operation like summarization, question answering, so that you can streamline your task and you can like work upon it directly. Okay, so as written over here, the interaction of LangChain is centered around the concept of chains provide a mechanism to execute the sequence of calls of LLM and tools through the prompt template. So basically guys, let's say if I'm talking about a particular question, so generally what happens is, let's say you ask a question, like let's say, hey, I want to go to this particular thing, or maybe I want to know about this particular X thing, right? So you get a response out of it. And obviously it's a human nature that after getting a response, you again have the same question. So basically guys, in the Lang chain, the name changes that you have a chaining system. Okay. So basically the output of one particular answer is the input for the next question. Similarly, from over here, we can go ahead and we can frame other chain, and similarly from over here, we can go ahead and we can frame other chain. So let me tell you this chaining concept if I'm talking about. So the very first thing is that when we are having only one chain structure, only one question to answer structure, that is called a simple sequential chain. Simple chain, not sequential chain. That is called a simple chain. If I'm going ahead and if I'm talking about the chain to chain branching, that is called as simple sequential chain, where your sequence is going on of a chain. Okay, so that is like two parts of chains that you need to understand for now. And moreover, I think we'll be doing practical also on the same, so you guys will get more clarity on it. So I'm loading my key file over here. Okay, it is having my key actually. And what I'm going to do next thereafter is we will try to load up this key into the environment that we are having. Okay, so let's begin with that firstly. So I'll just put up some of the things for you all so that you guys can have a quick idea that what are the things that we are going to do. So LangChain and all that application, the basic parts that we have just discussed till this point of time, it's over here present. I'm going to install some of the requirements that we are going to need, by the way. So we will be installing, I guess, we need the LangChain module. Okay, so we'll use that. And moreover, as the LangChain, we also need LangChain community package. Okay, so any particular new thing that comes, it comes in the LangChain community. So we need both of them. So it's getting installed now. You can check. Okay. After installing the requirements, the next thing is we need the token. Okay, the OpenAI token basically that we are talking about. Okay, so let's work on that. So here is our token, by the way. Okay, this is your token part. This is your requirements part basically. So let's let you mark this as well. Okay. So LangChain, your token and everything. So in token, basically, I have my file over here, that is key file. So I'll quickly import my key file. Okay. I should get a green tick. It's saying key file is not there. Okay. It should be in PY, or it should, I guess, be in different file. Let me change the format and let me check. Redeem, I guess I will have to do PY. Yeah. Let me download it. SK is not defined. Okay, just give me a second. I guess I might have made a mistake. SK, because I would not have put it into braces. So it is now considering it. Yeah, perfect. Okay, so let me show you in the notepad. You can define it in any case. So the way I'd use it, it's basically I write as a secret key. Okay, or maybe you can write just key, or maybe any particular variable you can take. So for instance, I'm taking secret key, for example, and here on you can pass your whatsoever key you are having. Okay, directly save it in .py format so that you can directly access it in your Google Colab. Okay, now let me show you how you exactly you access it over here. So I have my key file imported. Okay, using which or in which my variable or my particular token is there. Now what we can do is we can also use the OS module over here, by the way. That will help you to extract the information that is there inside this file. And else in OS, do use the libraries, that is warnings, because you are going to get a lot of warnings while generation. So use the filter warnings also so that you can filter out the extraneous details that are there. So there's a token part. Now how exactly you're going to load token? So you just have to say os dot environment. Okay, because we are working on an environment right now. And in this one, you have to initialize a particular key actually in this particular way, guys. So you'll say OpenAI key. Okay, OpenAI API key. This is the way your key should be there. Okay, that means in this file, the key should be named as the OpenAI API key. Okay, and then you can get your file Okay, and then using this file, you can access what's a variable you have fixed over here. So in my case, the variable is secret key. So I'll just get that key and I'll just paste it over here. See, dot secret key. That's it. So in this way, you are basically initializing your OpenAI key into the environment. Okay. So this should be there anyway. Okay. Your OpenAI key has to be there in any way. If I run this code, I've got a green tick. That means my OpenAI key is now ready to go ahead in my environment. That means my OpenAI key is now onto the environment. We can directly use it. And then after this particular procedure, you can initialize your OpenAI. So you have a check how. So you can simply say from LangChains dot LLMs import OpenAI. See, we have initialized the OpenAI part now. Okay, that means OpenAI is now there. If OpenAI is not there, okay. So what you can do is you can install it as obviously. So for the same you have pip install. I guess for all the users you can say -u and you can say LangChain dash OpenAI. This will work. This will basically be the application. You can say the interface. It will help you provide the access to all the things in OpenAI. Okay, the module for providing all the access to OpenAI. Okay, moreover, if you do want this information, guys, just simply go to OpenAI, okay, and open the documentation of it. There's a documentation. I think we are onto the documentation now. So you can how you are going to make requests and everything, like introduction. So you can see it's saying OpenAI, then how exactly you can get the OpenAI key, like other things as well. So from OpenAI, import OpenAI, then your organization ID, your project ID. So how you can create a project inside the OpenAI and how you can make a request. So this is how the request goes ahead, guys. See. Now, if you might have noticed, obviously it is not feasible for us to write everything over here, right? So this is a request query, by the way. And this is done in GPT-4o Mini. Okay. So this is how the request has to be sent in the chat GPT. But the thing is, you can't send this request in this way. Okay. You need a better way or you need an easier way to send a particular request. So for the same, we have wrappers that you have seen, guys. So see, this is how you're sending a request. You're sending a stream saying that, okay, this is GPT-4 Mini. Your message is a user and content is say this is a test. That's it. Now, using this particular thing, you will get an idea of how exactly you're going to get the responses and request. Okay. Now, have a check on it. How exactly we are going to do it. So this is the documentation, by the way. You have a lot of things. So you can go over here in the documentation part, and you can check how exactly you can build a assistant or a use case or you can fine tune your machine basically. And even you have different things over here present also, like how exactly you can optimize the accuracy, prompt engineering, how you can do prompt engineering and everything. Okay. So the tactics is written over here, how you need to go with tactics and everything. Perfect. So coming back to our code, what we are going to do, we already have the OpenAI installed now. So let's work with it and let's try to create an application over here. So let's start working with the OpenAI part. Okay. Start working with OpenAI. Okay, have a check. So firstly, we need to import. So from LangChain dot OpenAI import OpenAI. Okay, we have imported the OpenAI. It's saying LangChain OpenAI. Okay, it should be underscore, not this one. See, now it's going to take time because loading all the things that is in the OpenAI part. And here onward, we are going to create the model for OpenAI. Have a check, guys. So I can say model equals to OpenAI, and now I'm going to set some temperature. So do you know about temperature by any chance, guys? Like in general words, I'm talking in very general words. Do you know about temperature? How hot or how cold a the particular day is. So similarly, in models or the LMs also, we have the concept of temperatures. Okay, so basically, temperature concept is to tell how creative your model has. Okay, like how creative the responses has to be. But one thing to notice that if you keep it too high, might be there's a lot of chances that you will get a lot of errors because your model will then neglect a lot of information. Because obviously it has to be creative, right? So in creativity, everything will come. So it's better if you keep it neutral, like into 0, or maybe like you can tweak it a bit up and down. Okay, so here I'm just keeping it 0.6 so that the model can be a bit creative on our end. Okay, it can be a little bit creative. So using this, I'm initializing a model, an OpenAI model over here. Okay. Now, once this whole thing is done, what we can do is we can work with our prompts now. So it's a very easy implementation right now that I'm showing you. So very easy implementation. We are not using as any chain concept or something. So the most easiest implementation is, let's say if I say model, let's pass a prompt over here. I want to open a restaurant, let's say. Okay, that is for Chinese dishes. Okay, Chinese dishes. Chinese cuisine, let's say. That will be a better word. Cuisine. Please suggest a name and a menu for the same. Now, if I run this code, see guys, it's running right now. And now if I print the name variable, see everyone, check this out. Dragon's place, name, what is the appetizer is, what is the entry is, rice noodles, vegetarian option, and everything. Okay, have a check. So we are actually interacting with the chat GPT right now, but not using the chat GPT application, using a LangChain application. Okay, so we are trying to interact using the APIs directly. So the chat GPT won't come in picture over here. Have a check. Okay. Now let's try to improvise this. Okay, because obviously we are going to go ahead and we are going to change it. So we can now change the taste. Change in the taste. Okay, so let's just say that I am going to use the prompt templates concept now. We are going to use or we are going to pass the data using the prompts now. Okay, temperature basically means that how creative your model should be. Okay, like let's just say here that if you're going ahead, okay, and if you have seen the large language model, they are mostly neutral, right? Now let's say that if you want your model to be a bit creative, okay, or if you want your model to be a bit random, okay, that is where temperature concept will come into play. So it's basically a parameter that will influence the randomness of the model outputs. Okay, so if I have kept it to 0, it will produce most deterministic output, like most probable next word or most like suitable answer for the given question. If you set it to 0.6 or maybe a bit higher, so this setting will yield some creative responses. Okay, that means your responses will be real, but it will try to be more creative for it. Okay, you can say that it will try to put some innovation in the answer. Okay, it will try to go beyond the limits of it. If you set it to 1, okay, it will be more imaginary responses. Okay, like you won't see some real responses as such. And the responses that you will get will be more imaginary. It will be like, okay, something out of the world, something made up, something like that. Okay, so I think I might have mentioned you this word called as hallucination in my theoretical class, if I'm not wrong. Have I mentioned this word to you all, hallucination? Right, so the higher temperature will lead to a very impractical output, by the way, guys. So let me show you that example as well, so that you guys can have a clear bit of idea about it. See, I don't know if you guys know about it. There's a Google Maker suite, by the way, where you can test these things. See, so let's say I'm right now working on Gemini 1.5 Pro experimental. Okay, and right now the model temperature is set to 0. Okay, I'm asking what is the, let's use the same question actually. Let's copy it, let's paste it, and let's run it. See, guys, everybody. So it's a very, very like you can say, it's a very proper name, elegant and suggestions basically. So all the names, modern, catchy, sample menu, and everything we have got. Okay. See, very realistic and very normal kind of thing, right? But now let's do the same thing with a better or with a higher temperature. Let's set to 1. Okay. And now let's generate the output. Okay. See, have a check, guys. Now you might see earlier it didn't give us any particular description about the name. See, guys, everybody, have you noticed it? Earlier there were no particular descriptions given, right? Now if you see, there's a description given to everybody. See, evoke a sense of luxury and traditional Chinese architecture. I didn't ask about it. I didn't wanted it, right? But see, with each and every given name, there's a tagline. And now let's increase it to 2. Okay. And let's now do the same procedure. Now, if you will notice all the names that are there, okay, you won't have listened this name, or these names are basically made up. You know, if you might notice, see, salt and pepper, calamari, and everything. Okay, so this is how the temperature affects the things. Okay, so it's basically like the particular model is trying to improvise and will give you less create like less realistic responses. So maybe if you want to ask a question, you can ask it over here that okay, how exactly this has to go, and you can set the temperature to check out the results as well. So this actually is Google AI Studio, guys, in which you can use this thing. Do I have a pro version of it? You guys can also check. I guess in the starting they also give some free tokens, so you can just have a check on the same. Okay, where you can go ahead and you can play with different things. Now yeah, let's go back to the agenda. So here's the result that we are seeing. And now we are going to work with the templates, okay, as such, like what exactly and how exactly we can process one output to different input. Okay, so have a check over here. Change the taste, or you can say using prompt templates. So the very first thing that we have to notice out over here is we are basically trying to import basically firstly. So importing is very important. You need to import the correct library. So importing that prompt template, import the library basically. Now the next thing is you need to define the order. Okay, you need to define the procedure, how exactly your data has to go with the whole thing. Okay, like how exactly your data has to be framed. Okay, so in this particular scenario, the very first thing is that we have to design a prompt. So let's design a prompt over here really quick. So I guess we can take the reference from the PDF earlier that we are working on. So the prompt over here will go something like this, guys. Let's have a look. So I can say prompt template equals to, let me zoom it a bit. So you can call the prompt template library, by the way, put the brace in the same order. I can say my input over here is the input that I need actually, it will be in this order. I need the cuisine basically, or you can say the nature or the reason on which I want the restaurant name. Okay, and then this is a template, by the way, everybody. So I will say I want to open a reason restaurant. Okay, okay. Suggest a name, everybody. I will suggest a name and the 10 top dishes that we should keep. 10 top dishes that we should have. Okay, a very easy example that I'm taking right now. So I want to open a dash restaurant, that means Indian restaurant, Chinese restaurant, Japanese restaurant, or whatsoever kind of restaurant you want. Okay, so I'm creating a template for it. If I run it, got a green tick right now, and now let's go ahead and let's try to initialize this prompt. Okay, so prompt template dot format. I'll say here we have reason, right? So reason equals to Indian. Okay. Now have a check, guys, how exactly this the LLM is going to respond to this. See, I want to open an Indian restaurant, so just a name and top 10 dishes that we should have. Correct. We have our prompt ready to pass to a model. Correct. Now let's have a check on how exactly the model will accept it. Okay, and what will the responses and how exactly it will be generated. Okay. So see, now if I go, I need to just define the chain structure. Okay, I need to define the structure of chains. That's all. Okay. So have a check on how exactly I'm going to define it. So I will say from a LangChain dot chains, we will import the LLM chain. Okay, this is a library that I need. I'll say chain equals to LM chain. Okay. Here I need three things. So you might see over here chain to run queries against the LM, and you can also see the example. I guess it won't be having examples as such, but still fine, no issues. So I'll tell the parameters. It needs the LM that you're using. So in this way case, our LM is actually our model we have created over here. See, here we are having the model. And second thing that it needs is the prompt. So the prompt that we are passing over here, I think we have not saved the prompt. Nope, we have not saved the prompt. We can directly pass a prompt template over here. Okay, done, understood. Now this is actually our chain. Okay, this is a chain that we are going to use. Chain that is going to be used. Okay. Now if I run this, you have a chain ready. It is saying to validation error, LM field type error, type missing. Okay. LM chain. What is the issue in this case? Let me have a quick check. Model template prompt. Everything seems fine. What is the issue over here, dear? Uh, it seems to be everything seems fine. I'm not very sure why it is giving us error. So it is saying over here that our object should be in the part of dictionary and all that. Okay. So no issues. We will have a quick check on our prompts. So prompt over here, it seems fine by me. What is the issue? Okay, we have not put this or what? Let's have a check. To validation LLM chain requires type error missing, extra field permitted, type value error, and where this is having the error. The very first line itself in the chains. Okay, let me have a quick check, guys. That what is the issue over here? Like why it is giving us error? It shouldn't give us the error by the way, but let's still let me quickly have a check. Okay. So if I remove this, will it work? Yeah, got it. So guys, if you might have noticed earlier we were having LLMs. Okay, it's not LLMs actually. It is just LM. Okay, so that is what the issue was. Troubleshooted. Now we are having our chain ready. Okay, so the only thing that is left now is the thing that we have to run the chain. Okay, so I'll say a equals to chain dot run, and maybe we can pass Indian directly. Okay, if I run it, will take time. Calling the open API, I'll sprint A over here. See guys, name is Spice Junction, top 10 dishes, have a check on it. Everybody. Clear everyone how exactly a LangChain application is made now. So we have just created a chain, we have passed our prompt, and now we are having one of the aspect to it. Okay, moreover guys, if you want, you can pass this particular input, this particular output as the input for a different particular function. Okay, so in case if you want to do that, you can also do that. See, in order to perform that, we'll have to go ahead with a different approach, but let's have a check. So maybe we can create a sequential chain in which we can mention the things. So the concept of sequential chain, let me tell you also that. So this is basically using a single chain. Okay, let me mention it. Using prompt templates for single chain. Okay, this is for single chain. Okay, now if you want, dear, you can also go ahead and you can also like make multiple chains or simple sequential chain. So working with simple sequential chain. Simple sequential chain. Okay. So in this case, the defining process will be a bit different since we have multiple chains. So on to over here in this case, guys, the input of one, like input is one, you have one input, one output. And the thing is that the output, as I mentioned over here, the output of another chain is the input of another chain. See, so basically the input of one chain is basically the output of another chain. So let's work with that. So over here, we'll define the first chain of command. Okay. So over here, we'll say prompt template really quick, or maybe we can use the previous one itself. So let me copy paste it directly. We have our prompt. Let's copy paste it. So it's the first chain, by the way, guys. Okay, right? Now what we're going to do is once we are done with it, so let's initialize this prompt. Okay, initialize this prompt with LLM. Okay, so see, automatically our prompt engineering also working side by side. So we have our template and we have our chain generated, everyone. Okay, now whatsoever input we'll get from over here, we'll generate the second chain from there. Okay, so over here, what we are going to do is I'll again generate a prompt template. Okay, here we have our prompt template and the same query actually. So see over here, I have said that the input variable is going to be the restaurant name that is going to be passed from over here, and maybe we can also change the specifics if you want. So that is entirely upon you. So if you want, suggest some items for the restaurant name this, and maybe instead of this we can say, or maybe let's keep it a restaurant name itself. Okay, so the whatsoever restaurant name is generated, we'll remove this part. Okay, so it's a name for the same. Okay, so whatsoever name we will be generating from over here, it will be passed to the next second chain, and the second chain will generate some menu items for it. This is how the sequence has to be went. Okay, also sequence has to have gone through. And then now let's initialize this prompt with LLM. Okay, so again the same thing. We can say specific chain equals to LLM chain model prompt template, everything done and dusted. So see the input over here, the first input is reason. It will generate the restaurant name, will pass to the second chain will generate the item and will return it to us. Okay, running it, completely done. Now let's import the LangChain dot chains import sequential chain. Okay, it is saying LangChain dot chains and all that part. Okay, what is the issue now? Acha, LangChain apps. It should be LangChain. Perfect. LangChain is done. Now let's run the chain command, or we can simply use run the chain. Okay, let's say the prompt to do it. So see now, what I'm doing is we are initializing a simple sequential chain where we are passing the chain in a sequence. So we have firstly the chain over here, the first chain and the second chain. Verbose equals to true, that means we need the output basically, right? Let me run this, let me initialize the chain. Chain is initialized, and now let's capture the responses. So I'll say restaurant chain dot run I'm going to pass as Indian. See, it will now take time entering. See, everybody have a check. Entering new simple chain, spice junction, and this is the output. Have a check, guys, and finish the chain. Have a look onto it and do let me know if you guys are now clear with the concept of how exactly the LangChain application can be created. See, this is how the chain is getting structured. This how exactly the things are going to be made over here, like how exactly we are going to build a LangChain application, right? And obviously, you can also print the responses for a better clarity if you want. So if you print it, you won't have all the things. See, okay, perfect.
Just a quick info, guys. Intellipaat offers generative AI and prompt engineering course, which will help you gain proficiency in creating generative AI chatbots and other GenAI tools, along with mastering the latest tools and techniques with hands-on projects and real-world case studies. And the best part, this course will be taught to you by IIT faculty and the top 1% industry experts. What's more, you'll be getting your generative AI and prompt engineering certification from Microsoft. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description down below. Without a doubt, this course can set your careers to new heights. So visit the course page link given down in the description below and take your first step towards your journey as a Gen AI engineer.
So when you look at any of these LLMs, right? So there are two inputs that you would typically pass. One is the prompt, or rather, before I ask the prompt, I'm just going to call this the question. And then you pass the context. And then you ask it to, and of course, it generates a response. What do I mean by a question? What do I mean by context? And what is the response? For example, when you ask it for, hey, who is the president of, when you ask a question like, who is the president of the United States, right? So who is the president of the United States, right? So you ask a question like this. And then the context here, context is simply nothing but where do you want it to respond this particular question from, right? There are two ways you could do it. You can either provide an explicit context. What do I mean by an explicit context? Meaning you can provide it a list of Wikipedia articles and you say, you know what, try and find the answer from these list of Wikipedia articles, right? You can either say, you know, try and find the answer from this Wikipedia articles, or you can simply choose not to provide this information. You can say, you know what, I don't care. I'm not going to provide any of this information. Like, I'm simply just going to ask this question and I'm going to expect it to answer this particular question. So this nuance is very important, because when you ask a question like this, when you say, who is the president of the United States? And you're simply asking this question without the context. If you're asking this question to the LLM without the context, the LLM will try to answer, will come up with a response. But how will it respond back to this particular question? The LLM will respond back basis whatever it knows, whatever the LLM knows, whatever the LLM has been exposed to. Okay, what do I mean by that? Consider the LLM as a young kid, as a baby, as a child, right? Consider the LLM as a child, right? And this kid has been exposed, let's say, to data all the way up until, let's say, 2022 September. I think the OpenAI, the GPT 3.5 model was only exposed until September 2022 or something. So now this model has seen all internet data until September 2022, almost all of the internet data until September 2022. So when you ask a question, this LLM is not database, but it has seen all of the information until that point in time. So this LLM will try to respond back basis whatever it has learned or whatever it has seen until the September 2022. Now, what does that mean? If the president of the United States had changed after September 2022, it will not be able to answer that question. It will probably make up something, right? If you are asking a question that has information that is not there in September, that is not there up until September 2022, this will still create a response. This will still come up with a response, but it'll just make up some random stuff. It'll come up with some random information because it can. That's a large language model. It's not returning a response basis reality. It is just making up a response. That is referred to as, that making up a response is referred to as, any idea? A word that starts with an H. You must have heard about this. Hallucination. Hallucination. So it's going to hallucinate. Hallucination means it is going to come up with a response that has no factual basis. It'll just come up with a response just because it can. Right? Just because it can. And it is able to come up with, it is able to generate information, but is not grounded in any kind of reality. So the problem is, and this is what I want to, ground here. The key takeaway here is, when you're asking a large language model to respond to questions, bases everything that it has been trained on, then because you and I don't know exactly what is all of the information that it has been trained on, there is a greater chance that your response could be a hallucinated response. This output, there is a larger chance that it could respond back from hallucination or respond through hallucination. It might just come up with a response. It might look very, very realistic, but it might just hallucinate. It is generative completely. There is no deterministic responses at all. Everything is generative. How does it remember if the information is not stored? See, it is not remembering. You are aware of how. So my point is, it is not consciously trying to create a correct response. It just, of its innate nature of learning, it just comes up with the right words one after the other, thereby coming up with the best response or the most realistic response that it has been trained on in the past. I am not saying that it will not hallucinate otherwise. See, I want to make something very, very clear, everyone. If you ask any question before September 2022, will it always come up with a response that is 100% grounded in reality? No, not always. There is no guarantee to that. Nobody is saying that if you ask a question before September 2022, it will always come up with a response that is grounded in it. It could hallucinate then as well, but the likelihood of it hallucinating is much lower in that scenario because it has been exposed to that information. So it's more likely that it will come up with a response that is more realistic and more factual than otherwise. So, as I said, when you ask a question to the large language models, if it has been exposed to some of that data, it can respond back. Even then, there's no guarantee that it will always respond back with the right responses. There's a larger chance that it will come up with a better response. However, if I ask it any question that is not a part of its trained data, then there is absolutely sure, then we are absolutely sure that it will just make up some random response, which may or may not be true. What do you do then? So in that case, you need to sort of control it. The best way to do this is by making it very clear to the LLM that, look, you don't use your historical knowledge, you just use your ability of understanding language, but use this new context that I'm going to provide here, right? Don't try to over engineer this. I'm going to provide you like some documents over here, a list of 10-15 documents. So whenever you are trying to answer this question, only look at the content in these documents and then come up with a response. Now, when you do that, what happens is you are then forcibly grounding it. You're forcibly grounding it to only answer it from this piece of information that it has access to. If it doesn't know, if it doesn't see the response of that particular question in these documents, then it will either say, I don't know, or you can either, like what Vipul is saying, you can either get it to say that it doesn't know, or you can also maybe make it, you can also maybe get it to guess basis, a certain kind of understanding that it has on these documents. Solving a passage, it's like reading comprehension now. So you're getting it to do reading comprehension. So you have a kid that is extremely good at English. You're saying you don't use your historical knowledge. Here's a passage. Here's a question. You answer this question from this passage. That's it. Right. So don't use your memory. Just use your ability to understand English Look at this passage, look at this question, try and answer this question from this particular passage. Reading comprehension. That's what you're asking it to do now. But at scale, imagine Wikipedia scale, imagine the common crawl scale, right? So the complete internet sort of scale. At that scale, you're getting it to do stuff like this. That is what we mean by context, right? So providing the relevant context. So when people keep referring to the word context and context in the case of large language models, this is essentially what they're saying. So a question plus the context put together is referred to as a, both of these put together is referred to as, what's the word? What is it called as? The question and the context put together is referred to as prompt. That's the prompt. A question and the context put together is referred to as prompt. Now, most of our time and effort that we will be putting in is to engineer how this prompt should sort of look like. How should the question look like? How should this context look like? What should be the relevant context for a given question? How do you know how much context? And also, right, remember, these large language models cannot have massive prompts. There are certain restrictions on how much this prompt could be. So you need to come up with some techniques to dynamically create these prompts, dynamically find the relevant context to answer a particular question. Because this context size cannot be massive. It cannot simply be like a few gigabytes of data. There are certain limitations on how big that context size could be, because the LLMs have only been trained to deal with a certain context size. So in that case, how do you handle such large context sizes? Right? That is where we will be introduced to something called as, that is where you will have to find a way to automatically curate the relevant context for a given question. So if somebody is asking about President of the United States, I need to create this context in such a way that there is approximately the response to this question in somewhere in those documents, right? So some kind of relevant document should be present over there, right? It doesn't make sense for me to put the President of the United States. I cannot assume that this will be able to answer who the President of the United States is from a document that has to do with carpentry or pottery, for that matter. It makes no sense for me to pass documents like those. I can probably pass documents like maybe about United States. I can probably pass documents about maybe Donald Trump, Joe Biden. Maybe I can pass some relevant documents like that and thereby try and answer that question. So how do I dynamically curate the context is where we will introduce ourselves to something called as RAG, Retrieval Augmented Generation. The question that you ask for, the response to the question that you ask for is probably going to only be present in a few documents of all the corpus that you have. You might have, let's say, a few terabytes of data, so few gigabytes of data. You cannot pass all of that data as context, because the LLMs have certain limitations on how much context they can carry. You cannot simply say, I will pass all the data to it. For example, in the example that we did, where did that go? Yeah. For example, to be able to answer a question like this, analyze the personal loan column, we pass this whole thing as context. But man, I cannot pass the whole thing as context at all times. Or to be able to answer a question like who is the President of the United States, I cannot pass the complete Wikipedia corpus as context. So in that case, I need to be able to retrieve the right documents from the complete Wikipedia corpus that I can handpick and pass, so that my LLM will be able to effectively summarize information in it and generate a response. So that process of finding the relevant context for any given question in such a way that it finds the best response, or it generates the best response, is what is referred to as retrieval augmented generation. It's not just retrieving the right document, you're retrieving the documents and you're through that retrieval, you're able to generate the right kind of response. Exactly. You're trying to find the not very specific, but approximate sort of context is what you're trying. Okay. Is to find out that is correct. So let's go. Let's look at some of these examples. Okay. We'll start there and then we can build on top of it. So I'm going to do 2 examples, but we'll try to get there. Prompt is not a query. Prompt is not only a query, it's a query plus the context put together is a prompt. Okay. So what are we going to do here? Let's go back here. So I'm going to be using the GPT 3.5 turbo model. So I'm using the GPT 3.5 turbo model, and I have the same ENV. You all should also be able to access it. I'm then just opening up the client, the OpenAI. I'm using the OpenAI library to start with. So let's ask a simple question. Okay. So let's start with a super simple question. Control plus. Let's start with a very simple question. Which athlete won the gold medal in the high jump at 2020 Summer Olympics? See, I'm asking it a question. I haven't trained anything. I am just using the GPT 3.5 Turbo as is. Okay. I ask it a question. How do you ask that question? You remember this, the chat completions, chat completions.create. You provide the model, you provide the messages, and you simply execute that line of code. That's all that I'm doing here. System, here you answer questions about Olympics and the saying, and then role, and I'm passing this particular query, whatever the query is over here. And I'm using the 3.5 turbo model. This GPT 3.5 turbo model is what I'm using here. So now you ask it to generate the response. And yeah, there you go. Sorry, let's go here. This is the query. And perfect. Generate the response. Mutaza Sabarsim of Qatar and Gianmarco Tamberi of Italy both won the gold medal. I don't know if you have actually watched this high jump finals in 2020 Summer Olympics, the Tokyo Olympics. It was actually very fun. This was amazing. Where actually 2 athletes had won the gold medal. They just kept going on and on and on. And then finally, this guy, Mutaza Sabarsim of Qatar, he decided, let's just share it. And the other guy from Italy also agreed to it. Actually, the other way around. I think this guy proposed that they share it, and he agreed to it, and then just simply shared the gold medal. It was an amazing sportsmanship spirit that was kind of shown at that time. But anyway, the point is, do you see the answer? Mutaz Sabarsim of Qatar and Gianmarco Tamberi. So it has actually come back with a response. They decided to share the gold medal after both clearing the same height and agreeing not to participate in the jump off. So perfect. So if you actually go back and take a look at this, at the actual result, response of this. So this is from the Athletics 2020 Summer Olympics men's high jump. If you actually see it, Mutaz Sabarsim emerges as a joint winner of the event following a tie between both of them as they clear the 2.37 meters. Both Tamberi and Barsim agreed to share the gold medal. So it's like a fun thing. So it kind of happened on August 1st and 30th July. But anyway, the point is, so here I asked the question. I did not provide any context. Right? I did not provide any context. I just simply asked it a question. And because the 3.5 turbo model was trained on something, it was actually able to go back and generate the response for it. Right? Which athletes won the gold medal in curling in the 2022 Winter Olympics? How many of you all are aware of the game curling? Are you aware of curling? Yeah, a game of giant marbles on ice. That's exactly what it is. Actually, if you look at curling, it's this sport. It's this. So they've got this hot case kind of thing, and then they just kind of run it, and then it needs to land in this place. But anyway, point is, doesn't matter. That's not the point. The point is, we're looking at curling at 2022 Winter Olympics. So I asked it a question, like which athletes won the gold medal in curling at 2022 Winter Olympics. Same question, same piece of code. I asked it to generate the response. The gold medal in curling in 2022 Winter Olympics was won by Swedish men's team and the South Korean women's team, is what it's saying. Okay, sounds pretty accurate. Okay, let's actually go and check. So Swedish men's team and South Korean women's team is what it's saying. Men's curling, Swedish men's team, which is true. But the women's curling was not the South Korean women's team. It was actually won by Great Britain. It was actually won by Great Britain. But it says the South Korean women's team had won it. So it kind of messed up, of course, clearly, as you can imagine. Right? Sweden did win the men's World Cup. Actually, the reason why Sweden won is because Sweden is actually a champion in that sport. Sweden has been actually winning this for the last few years, for the last few occurrences as well. But it was not even the South Korean team, let alone South Korean. South Korean actually did not even participate in this sport. So it kind of made up this answer. Does that make sense, everyone? Do you understand where we are headed to now? Now, this is the dangerous territory. This is the place where, yeah, a lot of confidence, right? So it kind of came up with the answer with a lot of confidence, seems absolutely accurate. So the reality is, why did it even answer when it has the data? So it doesn't have the data. It doesn't have the information. So that's the nature of large language models. You're asking it to generate text. It is generating text. Why are you holding it responsible for it? You asked it to generate something. It ended up generating something. Why are you holding it against it? So it did what it did. But the problem is that it, of course, hallucinated in this case. Right? So it just made up the answer. Just like how you and I would make up an answer in an examination when you don't know the answer to a question, you just make up because you know how to make up answers. It just made up an answer. So it just made up an answer here in this case, right? Now, but the thing is, you can now specifically ask it to control and not make up, stuff like that. So one simple thing you can do is you just ask it not to do it. You just ask it nicely. You say, or explicitly, to be more precise. You simply say, answer the question as truthfully as possible. And if you're unsure of the answer, say, sorry, I don't know. Right? So you're asking this as a blanket thing. Actually, if you ask me, you can actually put this in the you can sort of actually put this in this thing. In the system prompts, right? So and that should be, so you can actually just add it here. So you you answer the questions about 2022 Winter Olympics, answer the questions as truthfully as possible. And if you're unsure of the answer, say, sorry, I don't know. And now you ask it to answer the same question. Now this time, when you ask it to do this, what does it say? Sorry, I don't know. The same question, but this time with a more controlled and the right kind of prompt. It actually came back and said, I don't know. What does that tell you? What does that tell you? It tells you that you need to ask the question a right way. You need to know what to ask to get the right kind of responses. Yeah, it doesn't default to hallucination. See, you need to understand that large language models, it's in their nature to come up with sentences and words and create sentences that are human readable. That's what they've been trained to do. Large language models were never trained to come up with right answers. You need to understand that very clearly, everyone, right? So large language models are not trained to answer right questions. They are not trained as, to be to participate in quizzes. They are trained to speak the language the right way. That's what they've been trained to do. Thereby, if you get it to specifically but they've also been trained to reply to instructions, right? They've also been trained to understand the instructions and operate by these instructions. They've been trained to do two things. One is they've been trained to speak language well. Two, they've been trained to obey instructions. These are two things that they've been trained to do. Thereby, when you provide the right kind of instructions, they will operate the way you want them to. If you don't give them the right instructions, they will go all over the place. But how does it know that it doesn't know the answer? Yeah, because see, how would you know? Okay, so here's the thing. When you're speaking something, do you know you don't know the answer? When you're making up an answer, do you know that you don't know the answer? Of course you know. Right? In the case of a model, the way it knows that it doesn't know the answer is when it's generating words, right? There's a probabilistic estimate that you have, right? There is a probability of the next word. So it decides if that probability is appropriate or not, is beyond a certain threshold or not. If it thinks that the probability is not good enough, then it simply returns back saying that this is inaccurate. This response is inaccurate. What's the next step? So now, so imagine we were able to answer this particular question, and as you can imagine, the fundamental reason for that, why the GPT 3.5 Turbo could not answer this question, is because of this reason. This only has access to data up until September 2021. These models, or rather, these models have only been exposed to training data sets up until September 2021. So you ask them to answer anything after that, it doesn't have context. So it will never be able to answer that response. So what do you do then? So in that case, if you were to get it to answer those questions, how do you get it to answer this particular question? So that is where, so you know that this model is good with language, but this model does not have the right context to answer. So you're able to answer, it has the right ability to frame responses, but this question doesn't have the right context. So how do you provide the right kind of context? Right? So that is what we're going to be doing right now. So we're going to be providing it custom data sets. Right? To help the model answer the question, we can provide relevant custom data as a part of the prompt itself. And this extra information will help answer it better. That will act as context and it will start answering this response much better. So that's what we're going to do. So what I'm going to do is this curling article that I spoke about. What is that? So this curling article that I spoke about, I'm basically going to just copy this. Right? I'm just going to simply copy this article and I'm going to put it here. That's it. Right? I just copied it. So I only selected up until the medals section. I think until here. Yeah, up until here, the medal summary. I copied everything up until here and I simply put it back there. That's it. So that information is now available here as a part of the prompt. So this is now the article itself. Plain text, as you can see. And all of this is here. And then let's keep going. This is the article. So now I'm going to say use the below article on 2022 Winter Olympics to answer a subsequent question. Answer a question as truthfully as possible. Answer the question as truthfully as possible. And if you're unsure of the answer, say sorry, I don't know. Right. So now here you're getting it to ask something very, very specific. You're asking something very, very specific, and you're saying, and look, here's the query, here's the question, and then you get it to answer that particular query. So if you look at the query, this is the query, blah blah blah. Actually, I don't need this because it's already there in the system prompt. Let me see if it's there in the system prompt. Okay, I didn't add it in the system prompt. I can add it in the system prompt. Let's go here. Okay, cool. So this is a system prompt. Answer as truthfully as possible. And if you don't know, just simply say, I'm sorry. And the query, by the way, is just this whole article now. Right? Now I ask the same question. Right? And the question here is, which teams won the gold medal in curling and at the 2022 Winter Olympics? So when I ask this question right now, it generates the response. The men that won the gold medal at curling in 2020 Olympics were men's curling Sweden, women's curling Great Britain, mixed doubles curling Italy. If you actually fact check that, let's go back here. Men's curling Sweden, women's curling Great Britain, and mixed doubles curling Italy. So what does that tell you? If you provide the right kind of context, and if you tell it explicitly what to do, these models will kick ass. They'll do a good job of this. They'll do a fantastic job. However, question is somewhat related to this problem where the model is being taught the new context. Please read my question. Can you repost your question? Okay. How can we make ChatGPT learn a certain context and what we can trust the accuracy of the questions based on the context? So you are not okay. Here's the thing. Here's the thing that I want you to understand. That look, you are not training the model here. I need you to understand that. You are not teaching the model, you are not training the model. You are just saying, look at this and answer. That's it. So the model is not learning anything. By just because you passed this additional piece of information, the model did not learn about 2022 Winter Olympics curling. The model did not learn anything there. The model's learning is what it was trained on before. You have just tapped into its ability to do reading comprehension, and you simply said, look at this article and answer this question. All it did is just that much. It did not become intelligent. It did not. Now, when you ask that model, no, you're not fine tuning. You're not doing anything, sir. Right now, you're not doing any fine tuning. If you want to do that, if you want to really get it to train, if you really wanted to train it on new pieces of data, that's where you will have to do something called as fine tuning, like what Devashish was saying. Here, I'm not doing anything. Here, it is just simply inferencing, not referencing, inferencing. That's the right word. If he asks the same question without this context, will it still say yes? Absolutely yes. You ask the same question again without this context, it will say I don't know. The response over here is strictly because of the context that you provided it, not because of the not because the model has learned something. If you take out that context and if you re-ask that question again, it will simply say I don't know. Now, what is the word limit for this context? Can I just add as many as I want? Well, no. So the context window for a GPT 3.5 model is 16,000 tokens. Now, the way to infer a token for a GPT 3.5 model is 16,000 tokens. The token is, you all must have learned about tokens. You all must have learned about tokenization when you learned your PyTorch or Hugging Face models. What is tokenization? Now, tokenization is not embedding. Tokenization is just the phase where a particular word is broken down into subparts. Right? So these models, they infer language very differently. So if you take the complete sentence, they basically break that sentence down into individual words. Right? In certain cases, right? Like for example, if you take the word higher, the word higher can be broken down into two parts, like high and the suffix er, right? The word high and the word er. So a good way to kind of assume this is, right? If you take, for example, 10 tokens or 100 tokens is around 75 words. 100 tokens is approximately around 75 words. 3/4. One token is sort of 3/4 of a word. Okay, that's essentially what your token really is. So when you talk about 16,385 tokens, you're approximately talking about around 12,000 words of sorts. That's like a good estimate. You can think of that as 12,000 words, 10,000 to 12,000 words. So that's the max that you can have as far as GPT 3.5 is concerned. However, the GPT-4 family of models, especially the GPT-4 Turbo and even the GPT-4o Turbo 4o models, they all can have much larger number of words, 128,000 tokens, right? So they can have much larger context size, right? But even otherwise, right? And as you can see, they had the training data that they have. But the point that I want you to know is that GPT 3.0 4.0 models are can carry a much larger token size. That's one thing you need to understand. So that's the maximum amount of context that you can shove into it. So if you just look at you can actually, when you make a call here, there is a way for us to actually look at the number of tokens. Dot. Uh, there is a way to get the token size. Let me just find it. Yeah, that's what they say. So approximately one token is like 4 characters, 3/4 of the word. Just trying to see if there's a way to compute the number of tokens. So now let's go one step further. Now let's ask a slightly more complex question here. Like for example, here I'm going to use the same Wikipedia article, use the below article on the 2022 Winter Olympics to answer the subsequent question. Same thing again. Did any athlete win multiple medals? So if you actually look here, right in this, so there is actually this guy who's actually won multiple articles, right? This guy Oscar Erickson, he's actually won like multiple medals here. In this particular thing, right? He's also won like a team medal and that as well. So you can say as he won more than one medal, everything else remains the same. You ask the same question, right? So this guy has actually won like multiple medals at curling. He won a gold medal in the men's event and a bronze medal in the mixed doubles event. So if you look here, the mixed doubles event, this guy has actually won like a bronze medal. You can probably find it actually here itself. Yeah. So if you see here, the mixed double event, this guy's actually won a bronze medal and also like a gold medal here. Again, point is that once you have the right context, it'll do a good job, right? So if you actually, so interestingly, if you actually just Google this question, you will not get the response for this. Somebody had asked me, right? Like, did any athlete win multiple medals? So you actually go ahead and Google this. Interestingly enough, you will not find it. You don't have it. It'll just point you to this and ask you to come back with a response, but actually will never be able to get you the right response here. But on the other hand, if you're able to provide the right kind of context, you can build agents that can specifically answer questions for you. So this is all great. But what you need to understand is here, this particular model has a bit of a privilege. What is it? It's able to answer this particular question well because I provided this complete article to it. But then how do I know which article to provide? If I were to really build like a scalable agent, an assistant, then how do I know which article to provide? Should it, from where will I know that? If I just manually try to provide this article every time I ask a question, then what's the whole point of having an assistant? Right? If this were to be truly capable, then what I would ideally expect is for this to be able to automatically find the right kind of article and on any given, at any given point in time. So how do I automatically enrich a prompt with the data that I've passed right now? Basically the context. How do I dynamically provide that additional context? Right? That's exactly what we're saying. We're saying manually adding extra information to the prompt obviously is not scalable. So we will now show how to automatically enrich this. And that is exactly where we are going to spend the next few minutes. Right? How will we do this? So here's where things are going to be a little interesting. So as I said, the prompt for every, so first thing to note is you just cannot add all the custom data as a part of the prompt. We spoke about it. You need to find relevant chunks, relevant portions of the custom data or of your data set as a part of the prompt. Why? Because there is a limit on the tokens on the context window. In the case of GPT 3.5 model, it's 16,000. In the case of GPT 4, it is much, much bigger. It's almost like 10 times that. Even otherwise, even if it is 10 times that, it's still not large enough. It's large, but it's still not large enough, right? So, as I said, if you take, for example, the average size of a book, right? So the average words in a book, right? So a book on an average has around, an adult fiction books on an average has around 70,000 to 100,000 words, right? A book on an average has around 70,000 to 100,000 words. That's one book that I'm talking about. So This 128K is like one adult fiction book, is one fiction book that we're talking about. That's nothing in the context of the internet. That's literally nothing. Right? So my point again, point that I'm trying to come up with is, if you're trying to summarize information, just summarizing or trying to find a response to a particular question from like one book is very limiting. So how can you like tap into much larger portions of data, right? That's where we're going to be talking about this this idea of retrieval augmented generation. How does retrieval augmented generation work? Here's the thing. This is like a good representation of it. Let me zoom out. So here's a good view of how the retrieval augmented generation high level works. So how does it work? So first things first, what's going to happen is you take a document or a corpus, right? I'm using the word document here very loosely, but you can think of this as a corpus. The term document, remember, is this can be a corpus of, as I said, it can be Wikipedia, it can be 10,000 PDF documents, it can be one PDF document, it can be anything, doesn't matter. So what you would do is you would take this particular document and you would break that document into chunks. What do you mean by a chunk? This chunk generally is a sort of, you can think of this chunk as typically something that has around 1,000 tokens or something, right? It's like a couple of paragraphs. Think of it like a couple of paragraphs, right? So that's a chunk typically. I mean, that size changes, but typically you take that complete document, you break that document into chunks. So this is one chunk, this is one chunk, this is one chunk, this is another chunk. So you basically chunk it down into different portions. You break it down into different chunks. Then what you do is you convert that piece of chunk into embeddings. Do you remember sentence embeddings? Long, long ago, so long ago, once upon a time, we learned about embeddings and sentence embeddings. Yeah. So you convert those into sentence embeddings. Now, how do you convert them into embeddings? What models can you use to convert them into embeddings? How do you convert them into embeddings? Spot on. You can use the encoder model. You can use the encoder models. You can use any of the encoder models. You can use BERT. You can use Word2Vec. You can use whatever encoder model. So GPT also has their own encoder model. Right? The GPT-4 has an encoder model called as the text embedding model. So if you actually go to the the GPT-4 model suite, which is here, if you actually look at embeddings, if you look at this, these are the embedding models that they have. Embeddings are numeric representations. So you can actually use these embedding models, right? And they can create, so there are three versions of these models. This is the most capable model for English and non-English tasks. Most capable second generation embedding model, replacing 16 first generation models. There was like a model actually before this was kicked out. This is like an improvement on top of this. So for all good reasons, generally what you would observe is most people would be using this model. This model is pretty decent. So we will also probably be using a version of this. Actually walk you through an example, you'll see that we'll be using this particular model. Point is, that is the model that we're going to be using. But the point is that we will be creating those chunks from these models. So you take a document, you break the document into smaller parts, and each part is essentially created as an embedding. Now, these embeddings are stored in a vector DB, vector database. We can come to the concept of a vector database later on. And the reason why we use something like a vector database is because you need faster retrievals, faster comparisons, and stuff like that. But I'll come to the concept of vector database in the next example. But broadly speaking, this is like a small array or a collection of all of these embeddings. So what this vector database will have is it will have the chunk ID, right? It'll have the embedding and the actual data itself. So chunk ID 1 whatever is the actual data, all of that data will be available here. And the embedding, so the embedding array will be present over here. Similarly, chunk ID 2, data, and the embedding. Chunk ID 3, data, and the embedding. So it's essentially going to have all of that information nicely stored in here. So this is sort of the first task that you perform. You take all of your custom data and then you create this embedding space. Now what? Now once you do this, every time a new question is asked, now it's very simple. Every time a new question is asked. So we take all the data. How do we make chunks? Chunks is simply breaking it down. Take 2 paragraphs, take the complete data set and break it down by 2 paragraphs. That's it. A chunk is as simple as that. Just take a piece of text and break it down into equal parts. How does ChatGPT still work if we pass it embeddings with different dimensions? Embeddings are never with different dimensions. Embeddings are always with the same number of dimensions. The whole point of an embedding is to make sure that the output is always of the same standard dimensions. How does an embedding look like? How does an embedding look like? A number. Now, once you have that, now every time a new question is asked, here's the thing. So every time a particular question is asked. So let's say somebody says, who is the president of the United States? Now the question is asked. What do? You take this question and you create an embedding out of this particular question. You use the same model that you've used to create the embeddings here. Whatever model was used, the embedding model, the same encoder you use, and then you create an embedding of the question. This is the query embedding, right? Now you take the query embedding and in the vector database. So the vector database, as I said, has 3 columns, the chunk ID, the data, and the embedding, right? So now in the vector database, look for all those chunks which are similar to your query embedding, which are similar to the query embedding. How do you find similarity between any 2 embeddings? How do you find similarity between any 2 embeddings? Cosine similarity, not attention and all. Simple. Cosine similarity. Attention is already done. Attention is done, hence the embedding has been created. Now that you have 2 vectors, how do you know if these 2 vectors are similar or not? Just look at cosine similarity. So once you compute cosine similarity, you will know the top 10 embeddings, right? Top 10 or top K embeddings. So you might know, okay, this embedding, and this embedding are the closest. So then what do you do? So now what you do is you take the data from these 3 embeddings. So now you know the top 10 or top K embeddings. From those top K embeddings, you extract the data from there. That data, you append them together. You append that data together. So this is chunk 1. This is chunk 200. This is chunk 350. So you get, let's say, the top 3 chunks. You get the raw data. You append them together. And then what do? You pass that as an input, as context into your model now, rather into your prompt. This becomes your new context. This becomes your new context. So this context plus the original question will be sent to the model, and then you will be able to generate the response. So what is the rationale here? What is the rationale here? The rationale here is when you are trying to find the best set of embeddings over here that are closest to the question, you are assuming that these questions, you're assuming that, or these chunks could possibly have the answer to this question somewhere in them. They could possibly have the answer to it somewhere in them. Then what do? You pick the top 10 or the top K, extract the raw data from it, combine all of them together. That becomes your new context. That context plus the original question, you pass it as a part of the prompt into the LLM, and that LLM will generate the response for you. Where will it generate the response from? It will only generate the response from the context that you provided. It is not just going to it is not going to make up anything. So The point is, here we were able to automatically come up with this piece of information. This piece of information that you're seeing over here, we were able to automatically come up with it by finding the nearest chunks or that are related to this particular question, and thereby we were able to generate the response. Why chunk embedding represented as vector than as a subspace? Yeah, embedding is a vector only, no? Embedding is essentially a vector in a high dimensional space. As I said, the chunk sizes is a bit of a parameter that you will have to tune given your problem. In generally in certain cases it's like a in generally in certain cases it's like two paragraphs or one paragraph length. Um, so there is you can sort of decide how big a chunk you want. As you can imagine, larger the chunks, greater the chances of finding better responses, right? If the chunk size is big, then you'll find better responses. But if the chunk size is big, you might also overshoot the prompt limitations at times. So you just have to be careful about that. We learned in LSTM a limitation that large sequence context vectors are inaccurate. Absolutely, yes. That's because they're LSTMs. LSTMs struggle with large context sizes. LSTMs struggle with large sequences. But these are attention based models. And that's the whole reason why these do phenomenally well, even if they're large context size. So LSTMs struggle with large context sizes, but attention models do very, very well. Transformers do very, very well with large context size. They don't struggle with it. Actually, the Gemini model, the latest Gemini model, has a context size of 1.5 million tokens. So, and that's what's happening. That's what they've been trained on right now. You can pack an entire book in a single context vector. Yes. That's what I'm saying, right? So if you have a context width of 128K, 128K is as big as a book. Is one book. So you can kind of put the entire book in a context window. This is sending partial data. Can we send full data for fine tuning? So the whole reason that we've gone down this path is because you cannot fit the complete data in a prompt. Remember, the prompt has a limiting constraint of only being able to put like 128K tokens in it. The whole reason why you have a framework like this is to find relevant pieces of your data which can which can help you answer the question better. Thereby, you're only identifying parts of the data which are relevant and then combining that and passing it into the query. But if your data is very small, then you don't need this framework at all. If your data is just small, simply shove it into this shove it into this prompt and then just send it, ask it to generate the response. If your data is small, if your data is very large, you have a lot of documents, if you have hundreds and hundreds of documents, then you need something like this. Components onto this, like for example, examples for vector databases are your popular models like your popular frameworks like Redis, or you also have Postgre Vector DB, you have Azure Vector DB, and so on and so forth. There are like multiple vector databases that are available out there for people to use, and there are also some open source vector databases that are available as well. I'll talk about some of these components when we actually discuss vector databases. For our example right now, what I'm going to do is something fun. So what I'm going to do is I'm going to actually take, for the same example, we are going to create chunks, right? Or for this example, I'm going to like try and quickly show you how the complete architecture looks like. And then I'm going to use I'm not going to be using a vector database for this example. For the next one, which is slightly more sophisticated, I'll use the vector database. For this, I'll just use a pandas data frame. I'll just use a simple pandas DB data frame for now. Okay. All right, let's go. So the first thing is, of course, the data set itself. Okay. So the first thing is, I'm of course going to try and like use a. So the good thing is for this particular data set, OpenAI has actually already created some of these embeddings and provided it to us. But I'm still going to show you how you can create these embeddings. This is the same Winter Olympics data set that I was talking about. It's almost like a 200 MB large data set. So we can actually download it, and we can access that particular Winter Olympics dataset. Let me just show it to you once it downloads. But anyways, let me go back here. So they've hosted this dataset already, but I'll still show you how you can create it yourself. I'll show it to you. So this is the data frame, and let me show you how the data frame looks like. So here's the data frame. So you see the text. This is the text, and this is the embedding. So remember, this is the same page, the Winter Olympics page that I was referring to. Same exact page. OpenAI has already kind of provided those embeddings for us. But anyway, I'm just going to like, and this is, as you can see, this is the raw HTML. So you don't really have to do any pre-processing to the raw text. This is, if you see, this is the HTML. You see HTML tags and everything over here. So the beauty of this is that you really don't have to do any kind of pre-processing. You just keep the text as raw as possible. You just take it, and then you simply create this embedding out of this. How do you create the embedding? Let me actually show you how you can create the embedding. So there is this simple function. So I'm going to be using the text embedding ADA002 model. As I said, it's the same model that was published in actually 2022. So we are going to be using the same model over here. So what you can do is when you pass a piece of text into the embedding model, it will simply generate a piece of numbers, text as vectors over here. How do you do it? You simply say OpenAI.embedding of create, pass the text, pass the model, and it will simply generate the output for you. As simple as that. So that's exactly what I'm doing. OpenAI.embeddings.create or client.embeddings.create, embedding model, and the piece of text. And it will simply generate the response embedding for me. I don't need to do literally anything else. So if I'm going to say, I'm going to get a vector, I'm simply going to say GenAI is amazing, right? That's like a vector for me. If you look at the vector itself, here's the vector. How long do you expect this particular vector to be? How long do you expect this particular vector to be? Let's look at the embeddings. Text embedding ADA002. The output size should be 1536. Right? You remember something from the glove embeddings that we used in the sentiment analysis session that we did? How big was that? We loaded the model from GenSim, if you remember. How big were the embeddings for that? How big were the embeddings on that? 300. It was 300 dimensions long. The output dimensions was 300 on that. And this is 1536. So you can imagine how much more complex the model is. But anyways, 1536. And then you can sort of come back here and let's go back to the, yeah. So if you look at this, this is the vector E. Now I'm going to get the embedding for generative AI is incredible. So I have two sentences here. Gen AI is amazing, and the other is generative AI is incredible. I got the embedding for this as well. So, in your opinion, what do you think? By the way, you can check the length of this. Length of F, comma length of E. Both of them are 1536 long. So, in your opinion, if I look for the similarity between both of these sentences, generative AI is incredible and Gen AI is amazing, what do you think the similarity score should be between both of these? Should be high, close to. So I'm going to use the cosine similarity. Look at this, 0.91. Pretty high, right? Generative AI is incredible. Generative AI is amazing. Gen AI is amazing. I was able to get a score that is almost as high as 0.91. So do you agree that the embedding models here work? Like they can kind of come up with like some numeric representations of these sentences? Narendra Modi is addressing the media, and if you remember, there was one more sentence which was the prime minister is speaking to the press or something. Right? So two sentences. The prime minister is speaking to the press. Narendra Modi is addressing the media. Both sort of mean the same, but they have nothing in common. But if you look at the similarity, look at that. See the similarity here? That is the beauty of these models, right? So that is amazing as far as I think the quality of these models is concerned. So now you have the embedding model. So you know, given a particular sentence, how to extract the embeddings. Now tell me something. Can I just simply pass this piece of text and can I extract embeddings? Can I just pass this piece of text? And do you think I can extract embeddings? Yes, perfect. So all that is all that I need to do. So compute document embedding. All that I have to do is I just need to get embedding of that piece of text for individual ID in here. I just have to iterate across rows and I just have to get the embedding. So I'm not going to run this right now because the beauty of this, if I want, I can. I'm not running it for the moment because the beauty is it's going to take some time for it to get executed. The beauty is somebody has already done it for us. They have already created these embeddings for us. So I don't need to worry about creating it myself. So these guys have already comfortably created it for us and made it available. So we can just use these embeddings as is. So you know how to create the embeddings. I'm not creating it right now, just in the interest of time. But if you want, you can actually create it yourself as well. It's going to take it some time. So now that we have the embeddings, what's the next? So each time we receive a question, what do we need to do? We calculate the embedding vector for the question with the get embedding function. So we have the get embedding function. So we're going to compute the embeddings for the get embedding for every question. We create the embedding. For each chunk in our custom dataset, we calculate the cosine similarity between the chunks embedding vector, these vectors, and the questions embedding vector. We compute the similarity. We rank the sections from the most cosine similar to the question to the least cosine similar. So you then rank them. That's it. So I'm just going to run this function for the moment. And so, for example, if you take this string curling gold medal, right? I'm passing the data frame and I'm saying get me the top five, get me the top five strings associated with this. And I'm going to simply print this just to see how it looks like. So if I run this, it's going to find the embedding of this particular question and it's going to return. So 87.9 is the similarity score. Curling at the 2025 Winter Olympics medal summary is providing the chunk with the medal summary. Here, curling at the result summary. Again, result summary. Women's tournament. This is mixed doubles tournament. Medalists. So if you see, if I say curling gold medal, it found like stuff that is associated with medalists, mixed doubles tournament, women's tournament, and stuff like that. So it's giving me something that's related to the question that I've asked with the top four chunks or top five chunks is what it has returned. Now what do I do? Now what I'm going to do is I'm going to combine these chunks, right? And I'm going to pass them into the model. I'm going to try and shove them into the context window of the model and then I'm going to pass it, right? So that's it. So I'm going to say use the below articles to answer the subsequent question, answer the question as truthfully as possible. And if you're unsure of the answer, say, sorry, I don't know. I'm still going to stick with this. And since I don't want it to exceed the context window, we're using this package called tick token. And it is simply going to help me count the number of tokens. It is going to help me count the number of tokens. Number of tokens, string, model, GPT model, and it'll help me count the number of tokens, tick token dot encoding for model, and it'll help me compute the size. Like for example, I can simply say this model curling gold medal and model is the GPT model. Sorry, num tokens. So it will tell me how many tokens it will take to how many of these tokens will get basically created over here. It says so curling gold medal has essentially 5 tokens. See, because I cannot exceed the 16,000 token limit, right? Because if it again exceeds the 16,000 token limit, it's not going to be using it. So that's it. So that's all that I'm going to do. I'm going to say so relatedness. I'm going to find the strings here that are related to the question that I'm going to ask. So I'm basically reusing that function here. And that's it. And I'm simply going to, for string and strings, for whatever strings I'm going to get, I'm just going to like append all of that Wikipedia article section, and I'm going to like chunk all of it, and I'm going to like simply merge all of them, basically adding everything together. That's what this is simply going to do. I'm just appending them. You see here, if the number of tokens is greater than the token budget, the token budget is 16,000, or here it is 3,700, but honestly it's like 16,000 or something. If it is greater than the token budget, then it will break. Else, it will append the next article. Right? So that's it. And then the message and the question are going to be merged together, and it will simply return that. You can of course go through the code, guys. You can go into the detail of the code, but I want you to understand what's exactly happening here. So this, we are tokenizing our document as context and passing it. We are not tokenizing the document. We are essentially just see. Okay. So here's the line of codes. So here, what's going to happen is this piece of code is going to return all of the strings that we saw here. The raw text, how many ever we ask for, top 5 or how many ever we ask for, it will simply return that over here. Okay. Once that is done, in this for loop, all that I'm going to do in this for loop is I'm going to go string by string. This is a piece of string, by the way. I'm going to go string by string, and all that I'm going to do is if the number of tokens in the message so far, message is an empty message, by the way, right? If the message plus the next article plus the question, whatever question that I have, if it is greater than 3,500 or 3,700, I think that's the limit that they put up, but 16,000 to be honest. If it is greater than 16,000, then if it is greater than 16,000, then I simply break. I don't append the next one. If it is less than 16,000, then I actually go ahead and append this one as well to it, thereby creating a larger prompt. This is all prompt creation. Nothing else is happening here. The simple for loop. There's no tokenization or anything that's happening yet. I'm just counting the number of tokens so that I stay within the total limit of the number of tokens that are required. So in a sense, what's happening here is just this prompt creation is happening. Let's go back here. Let's go. Yes, this prompt creation is all that's happening here. That's it. This prompt creation is happening, nothing else. Exactly. That's it. That's all that's happening there. And nothing beyond that. Clear? That's it. So now, once this is executed, so then I'm going to pass. Which athletes won the gold medal at curling in 2022 Winter Olympics? And I'm going to make this, yeah, fine. That's okay. Doesn't matter. I'm going to execute. Which athletes won the gold medal? What happened? Header is not defined. Header. This is the header. Okay. Cute. So now it's actually going to, perfect. There you go. So this is the article, or this is the prompt now. Use the below articles. If you don't know, simply say, sorry, I don't know. Wikipedia article selection. This is everything to do with curling. First one. So it's actually, so if you look at this, this is the next article section. Where did it go? So it basically separated by this part called Wikipedia article section. So this is the first one. Okay. Second chunk. Third chunk. Fourth chunk. Fifth chunk. Sixth. Seventh. Eighth. I think 8 chunks here. I don't know what was the limit that was passed as the total number of chunks, but yeah, I think it found 8 chunks, and then it found the response to the question. Which athletes won the gold medal at curling? That was the question, and of course we have the prompt now, which is fully prepared. So now I have the prompt. What do I do once I have the prompt? What's the next thing that I need to do? Ask the question once I have the prompt. Right. So now fire. So you see, there's something called as ask. So pass it to the LLM. So answer the query using GPT-4, whatever. This is the role. This is the message. The message is simply nothing but the message that I have here, and simply fire it. So once you fire, so print ask, and that's going to fire the question. But see, this is going to basically do everything. This is going to do the retrieval. This is going to combine everything. This is going to pass it to the LLM and generate the response. And the answer to that is the athletes who won the gold medal in curling in 2022 Winter Olympics were Stefania Constantini, Amos Mossener, and in Italy in mixed doubles tournament, the team consisting of Bruce Mouth and whatever. So these folks in men's tournament and mixed doubles, and I think somewhere women was also there. Yeah, whatever. So as you see, which athletes won the gold medal, that is all present here. Mixed doubles, it has given you mixed doubles. And this is men's tournament. I don't know why it didn't give the women's tournament. We can also ask for the women's tournament as well. But you get the idea, right? So you get how kind of clubbed everything together. Let's ask a question for an Olympics event that never happened. So 2016 Winter Olympics. Honestly, 2016 there was no Winter Olympics, technically speaking. So it says 2016 had no Winter Olympics. So it says sorry, I don't know, right? And then if you want it to lie, all that you have to do is just change the header, right? If you just change this part, instead of saying answer the questions as truthfully as possible, instead of that, if you just remove that, look what happens. I just remove it and then I ask it for this question. Now it bloody makes up any random thing on the planet. See, the athletes who won the gold medal in curling in 2022 are these. So I asked it for 2016, but it's making up an answer for 2022, first of all, and it gave some names over here from men's tournament and women's tournament. But I asked it for 2016, so it's kind of making up some stuff here right now. So you get the point, right? It's answering an irrelevant question, and it's kind of, yeah, exactly. That's the annoying part. That's the part where you need to be very, very clear. So again, the important thing that you need to understand is you need to be very, very clear, very explicit about what you want it to do. They are super sensitive to these guardrails. So if you don't provide the right kind of guardrail, LLMs can go all over the place. So you have to be very clear about what you want them to do. Else they can go all over the place. First question, say I ask for 128k context tokens. Second question is ask for 128k. Does ChatGPT now remember that the entire tool? No, it's stateless. Each question is only for, so the context size is only for that question, for that call. So when I'm making a call here, there is one call that's one call that's happening here, and thereby it's only for that particular part. So it doesn't care about the next one or the previous one for that matter. As truthfully as possible is not, it's normal language, normal human understandable language. You can say, instead of saying as truthfully as possible, you can simply say be as truthful as you can, or try not lying, or try not making up answers. You can come up with other things. So in this case, it did not find any 2016 Olympics in the top context chunks. Yeah, which is why it did not answer for 2016. 2016 in the previous case, there was nothing. So it did not create anything. But here, it did not find anything, but it still made up an answer basis what it saw in 2022. That's the annoying part. Okay. Gabani's point is, and I think she's only posted 2 hosts and panelists, so I don't think everybody else can see it. So she's saying, I'm guessing that there are some better techniques of chunk retrieval, or is it going to be this simple always? Is vector similarity check part of the vector DB? I'll answer the first question. Yes, chunking is a bit of art than science. There are some interesting ways to handle it. So, for example, if you go back here, this is just one article, but generally, what you do with chunking, there are 2 parameters with chunking. So, when you talk about chunking, there are 2 parameters generally. There is something called as chunk size and chunk overlap. What do you mean by chunk size and chunk overlap? So imagine you have a document. You create one chunk and then you create another chunk. So the question is, should these 2 chunks completely be mutually exclusive? What has been found is having them mutually exclusive is counterproductive. Why? It's important that these chunks kind of have some shared context. Else, what happens is the piece of information that is available here and the piece of information that is available here, they might be loss of continuity. Like there might be some sentence over here that is probably talking about some kind of a behavior. And here, if you just abruptly start from another place, there is loss of continuity between the two. So it's always good to have some kind of an overlap. So you can define how many tokens overlap do you want between the 2 chunks. And chunk size, as I said, is generally around 1 paragraph or 2 paragraphs. But that's also a bit of an art because it depends on the type of document you are operating with. So yeah, chunk size and chunk overlaps are generally a little tricky, to find. They significantly determine the quality of the responses. The second one to your question, which is vector similarity. So yes, the vector similarity part is generally the responsibility of the vector databases. We manually computed the vector similarities, right? But as you can imagine, this can be very expensive. Meaning, when I say expensive, meaning in terms of time. See, imagine you have 20,000 or 100,000 entities. Every question is asked. You cannot compute the similarity for 10, 20,000, vectors. It's very, computationally intensive. So there are some nearest neighbor algorithms. There are some techniques that can help you compute similarity of one particular vector with the other vectors in a fastest fashion. There are algorithms that help you do that. That is where vector DBs are very good at. Vector DBs have some specific inbuilt algorithms that will help you perform this similarity check very fast. That is why instead of doing the vector similarity within your system, it is often preferred to kind of go to these vector databases. Like what we just did here is we simply ran like a for loop, right? To find the similarity, what did we do here? We basically executed a for loop here. Where did that go? Yeah, this one. For strings ranked by relatedness. So if you look at this function, all that we did was basically ran a for loop across each row and we computed the similarity, which is very, I mean, this is not very sophisticated. So you would ideally want to do something that's a little more robust, and that is less computationally intensive. That's where vector databases come in. What vector databases do is all that you have to do is just pass them a query and pass them a similarity threshold. You say this is the query embedding and this is the I want to find all the vectors that are 0.85 or below. So this everything that's happening inside this function basically happens in there. Basically everything that happens, yes, everything that happens in that function basically happens in this function. Sorry, everything that happens in this function basically happens as a part of vector DB, basically happens as a part of the vector databases itself. So I will show you a vector database. We will try a Chroma DB or something, an inbuilt Chroma DB or something. Exactly. So spot on, right? We jinxed it. So yes, I'll be showing you a Chroma DB in the next example that I walk you through with LangChain, and that will help.
Just a quick info, guys. Intellipaat offers generative AI and prompt engineering course, which will help you gain proficiency in creating generative AI chatbots and other GenAI tools, along with mastering the latest tools and techniques with hands-on projects and real-world case studies. And the best part, this course will be taught to you by IIT faculty and the top 1% industry experts. What's more, you'll be getting your generative AI and prompt engineering certification from Microsoft. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description down below. Without a doubt, this course can set your careers to new heights. So visit the course page link given down in the description below and take your first step towards your journey as a Gen AI engineer.
We went down the route of retrieval augmented generation, right? So retrieval augmented generation, as you can imagine, has two aspects with it. One is the retrieval part and the other is generation. The retrieval part is more about trying to extract the relevant context from the massive corpus that you have given and given a particular question. Now, retrieving this context, of course, has to be dynamic, and for that to be dynamic, you require some kind of a very smart logic that only retrieves the relevant piece of information. And then once that is done, then what you're trying to do is you're essentially taking all of those relevant pieces of information and the question that you have and put that together to be able to generate a response and thereby summarize that particular response as well. So retrieval augmented generation is essentially that. Is in what kind of a scenario, right? Do you think, right? I'll repeat the question. What kind of a scenario do you think retrieval augmented generation will not be required? What I mean by that is, to be able to do question answering, do you always believe that retrieval augmented generation is needed? Or is there a scenario where RAG is probably not going to be useful or not required, so to say? That's a question for all of you. Basically, small corpus, okay? For general purpose question answering, RAG is not required. Fair point, okay? What else? My question is, in what scenarios do you think retrieval augmented generation is not needed? Where I don't know the context, okay? When the context is not available, sure. Something we know the model is already trained on. Answering recent questions. If we have an understanding of the topic where details are not required. Model is not trained. Yeah, I think you all are there to some extent. The small data set part is absolutely true. Because if the data set is small, then you don't need basically you don't need RAG. You can just stuff that complete data set into or information into your prompt itself, right? So that's straightforward. Yeah, great point. For a creative task, you don't need RAG. Absolutely agreed. Where the learning is minimalistic, Salap says where the learning is minimalistic. Sure, okay. For tasks with low risk, yeah, I think we're there and thereabouts, everyone. Some of your answers are right. Some of your answers are, I think, there. I think there's still that last mile understanding that is still missing. I'll spend a couple of minutes on that because I want to really cement this understanding in your head before we move on. Right. So the reason why you would want to do RAG, right, is if and only if, right? So you would do RAG if and only if your data set is large. Right. See, the best way to do question answering, the best way to do question answering. So the best way to do question answering is through putting the content, the regular question answering, the question into the prompt itself. Or so as I said, a prompt is simply nothing but a combination of a question or a query plus context. Now, when I refer to context, Context here basically means data or simply corpus, right? Regular documents. That's what we mean by context here. A question plus context is what we refer to as a prompt. Now, if the prompt is not necessarily large, if this particular prompt is not necessarily large, meaning now the definition of large also changes from model to model. So if you are using the GPT 3.5 class of models, then you are talking about if this combination does not go more than 16,000 tokens, right? 16,000 tokens is approximately how many words? 16,000 tokens is how many words? Very good. 12,000 words approximately. Approximately 12,000 words, right? So approximately around 12,000 words. If both of these put together is less than or equal to less than 12,000 words, then you don't need RAG. Then you just send it directly to the LLM. Then you don't need a RAG. However, in certain cases, what may happen is this question may have to be answered from a piece of corpus that is very, very, very large, right? Like, for example, I may be building a bot, right? I might be building a bot which tries to do question answering on top of, let's say, the whole of Wikipedia. Now, I cannot put the complete Wikipedia over here as context. Ideally, if I can, I would have loved to do it, right? If I am able to put the complete Wikipedia here, I would love to do it. But what restricts me from putting the complete Wikipedia in this particular prompt? What is the limiting constraint here? What is the limiting constraint from putting the complete Wikipedia in this? The number of tokens. Fantastic. It's the size of the model. So you can then decide, you know what? Let me do one thing. Let me start using the GPT-4 category of models, right? Or I might choose to say I might use Gemini in this case, because Gemini might allow for like almost 2 million tokens. GPT-4 would allow 128,000 tokens. Even this, my friend, is not very large. Even this is not very large, right? This is probably as big as one book, right? 128K is as big as one book. 2 million tokens probably is yeah, as you can imagine, it can just be probably 5 books or something. My point being, even in that case, to do question answering, this is not going to be enough. Hence, if, by the way, in a scenario where you're able to stuff the complete corpus into the prompt itself, then you don't need RAG again. Then you can simply just switch the model from a 3.5 sort of a model to a GPT-4 or a Gemini sort of a model and then parse it to the LLM and do question answering. However, if you don't think that is possible, that is where the alternative is RAG. If you are unable to stuff it into the corpus, stuff it into the prompt, then you go for RAG. So simply, if I were to put a condition, if the if the number of tokens of your prompt, if it is less than the number of allowed tokens by a model, by an LLM, then you don't need RAG. You just combine the two of them, directly send it to the LLM. Otherwise, you're going to go for a RAG, because then you have a context length which is much, much larger. Then in that case, you go for RAG. Now let's talk about slightly more modern day retrieval augmented generation architectures. Okay. So I'm going to talk about a little more advanced RAG. I wouldn't say advanced RAG, but basically different architectures use of RAG. Now, what are the architectures of RAG? How do you set up RAG? Now, there are so many different ways to set up RAG. Let me just go back here. There are so many different ways to set up RAG. One of the most simplest ways was discussed here, right? So, okay. Now, one of the most, as I said, this is one of the most simplest RAG frameworks. However, now here's where the complexity starts coming in, everyone, right? So, how do you now build on top of this kind of an architecture? What kind of components would you require? Because when you're building an enterprise grade component, right? When you're building an um, enterprise grade retrieval augmented generation framework, that is where you will you will require more and more components, cloud components, right? So that will help you build something like this. What do I mean by this? Let me show you something. Give me a second. I'm just trying to pull up an architecture diagram. I don't want it to be too complex either to start with. Let's go back here. So imagine for a moment that you are actually building an enterprise grade retrieval augmented generation bot, right? Imagine for a moment that you are actually building an enterprise grade retrieval augmented generation bot. Now, what do I mean by that? So this is a bot that you're trying to build, a sort of a chat bot, right? Which can essentially answer questions from structured and unstructured data, maybe unstructured data to start with. Let's forget about structured data. Structured data will require a different architecture. We'll talk about that. So imagine you have, let's say, a lot of marketing, right, content in your organization, or you have a lot of information about suppliers, or you have a lot of information about your competitors, right? And all of that information is, let's say, stored in the form of PDF documents. It's stored in the form of, let's say, um, PowerPoint presentations, PPTs. It's stored in the form of, let's say, Word documents, right? It can also be, in certain cases, maybe some form of SharePoint sites, and so on and so forth, right? Any form of unstructured content, right? That we are referring to, right? All of that information is sort of available for us right now. Now, the question is, and mind you, right? So this is a lot of websites, a lot of content that we are referring to here. In such a scenario, your ask, or somebody from, let's say, your marketing team has asked you, hey, if I were to access all of this information, all that I have is I have it, let's say, on a SharePoint site or a Teams site, or I probably have it on a Google Drive. And my folks are having to actually just go into one of those files and they're actually having to search across those. It's super inefficient, as you can imagine, right? If I were to simply say, if I were to simply ask a question like, what has, so let's say, imagine you are Airtel, and you would want to understand more about Vodafone, or let's say you're more interested in learning about Geo. So you may ask, what are the key investments made by Geo in 2023? So you ask a question like this, or specifically on improving network coverage. So let's say you were to ask a question like this, or for somebody in your organization to be able to answer a question like this, he or she would have to go through all of these PDF documents, your PPTs. These PDF documents could sort of be earnings reports. These could be investor, IR, or broker reports. They could be transcripts. They could also be some kind of information that's available on the internet. People would have to specifically go through all of this. Now the point is, and for you to be able to extract all of that information and to be able to answer, that's going to be very, very complex. And just to let you know, right, there are teams that do competitor intel. There are teams in your strategy organizations that do competitor intelligence at scale, right? For example, my company, My company makes beer, right? So I work for a company um, that makes Budweiser, Corona, Stella Artois, Hoegaarden. These are all our brands, right? So we've got a lot of brands. Now, our direct competitor is Heineken. Our direct competitor is um, our direct competitor is Heineken. Our direct competitor is, we also consider Coca-Cola as our competitor, PepsiCo as our competitor as well. Any CPG is our competitor. Now, one of the things that we actively look for is our folks, our folks in our strategy team, um, who report into the chief strategy officer. They spend a lot of time doing competitor intel. Their job is just about comp intel. And competitor intelligence is about understanding how their financials have improved since last year or since last quarter. The quarter over quarter, how has their EBITDA improved? How has their earnings per share improved? How has their organic profitability? How has it improved? And so on and so. They look at all the different line items on a P&L statement, and they summarize this information, create massive decks, and they send it out to the C-suite, right? They send it out to the CEO, they send it out to the CTO, the CFO, and they spend a lot of time then discussing how should they respond back to all of this. This is very, very common. A lot of companies do this. The point is that this is, as you can imagine, a very, very time-taking aspect, very time-taking task, and this happens in every company, right? So any kind of CPG industry, any kind of industry for that matter, this is a very common affair. In such a case, how can technology help, right? How can you contribute to this? So one way that people have tried in the past is by trying to create chat interfaces. But the problem is these chat interfaces have been extremely suboptimal, right? These chat interfaces were not great. Thanks to large language models, now these chat interfaces have significantly become better, right? You can actually chat with them. You can actually ask questions. So how do you build something like this? How do you build a capability like this within your ecosystem, specifically on your own data, right? That is essentially where an architecture like this would probably come up. Now, I'm giving you an example on Azure, right? So this is Azure components, but you could sort of extend this for any cloud component. Any cloud component, you can sort of extend it. So I'm going to actually show you the same thing, but more from like a, I'll abstract this out, not necessarily using the Azure components, but I'll abstract this out for all of you to adapt this to any kind of a cloud framework. It could be for AWS, it could be for Azure, it could be for anything. You could just basically, the structure of the architecture more or less remains the same. The components can change. Right? What are the key investments made by Jio in 2023, specifically on improving network coverage? Now, how do you answer a question like this? As I said, the first thing is you would want to have access to all of this information. So that's what you have here, right? So the first piece here is some kind of a storage container, which is basically like, think of it like a drive, right? So think of it like a Google Drive or a OneDrive sort of a thing. Basically a file storage, right? It can be your C drive or your D drive on your local machine as well. It can be a hard disk as well on your own personal machine. But basically, you have a file system where all of your files are available. Now, these are all the different documents that are available here, right? All of these documents are available here for you. Now, what do you do when somebody asks a question? So remember, if you remember, what did we do first? In the case of the curling example, we took the Wikipedia document. What did we do? We converted that document we broke that document down into smaller chunks, and we converted that into embeddings. Remember? Yes or no, everyone? Remember that? We converted that into embeddings, right? Now, that converting that into embeddings part is what happens here, right? This is, forget about cognitive search and everything, but basically just a small, piece of component that helps you break that particular document down into embeddings. And those embeddings are, just to let you know also, to be able to do this, there is a small error here in this picture. You will also need access to this. This is the embedding creation. This is the embedding creation. So to create the embeddings, you first create the embeddings here by accessing the OpenAI service. And then after that, you store them. Remember in our example, what did we do? We put it in a pandas data frame. But the problem is pandas data frame is probably not always the best choice, right? So you would have to put it in like some kind of a database, which is very, very easy for us to access. So that is essentially your index, search index over here, or very popularly known as a vector DB, a vector database. Right? There are many, many types of vector databases that are available. This is a very commonly used vector database. This is Azure's vector database, but technically there are many vector databases that are available out there. Some on-prem, some in-memory, some on cloud. There are a lot of options. But those vector DBs are something that you could use to store this information. I'll actually walk you through an example. We will be using something like a Chroma DB. We'll solve a problem, and I'll actually show you how you can store that, vector DB. There is absolutely no logical way to read this vector, to read the vector. But can you access a vector DB? Yes, of course. Just like any other database, you will connect to it and you will read information from it. It's basically like any other database that you will be accessing this information from. That is a one-time background activity that you will have to perform. That's the background activity. Then, now there is a user. Now there is a user. And this user wants to answer questions. This user that you have here wants to answer questions. So this user is now asking a particular question. This user is asking a particular question. Now that question is whatever question that you have over here. So this user is asking this particular question. How will the user ask the question? The user will of course require a web application, right? Through the browser, through your Chrome browser or through your Edge browser, you need a web application. When I say web application, basically the chat interface. This is not a data scientist's responsibility. In most cases, a data scientist doesn't have to worry about this part. Right? This is something that an engineer or a front-end engineer, a back-end engineer, a software engineer in your team will be able to help you with. Even for example, all of this components. Simply put, this is essentially building the chat app, right? The chat application. That front end is sort of built by someone. Once that question is asked on the front end of the or on the app, that question is sent into that particular question. So all of this piece that you see, this piece is now going to be present as a part of your core backend application. So this part, once you ask a question, what's going to happen is that question is going to get converted into that particular question is essentially going to be passed into the vector database. The vector database will return a set of 3 or 4 nearest neighbors, right? Remember, when you ask a question, that question is converted into an embedding, right? And then we try to extract the three or four nearest neighbors. Those 3 or 4 nearest neighbors, along with the question, we pass it into the OpenAI service, and that generates the response and it returns back into the web application. So that is the whole flow, as you can imagine here. Now, if I were to sort of abstract it from here and sort of create a very, very simple diagram for all of you, let's actually create a very simple architecture diagram right now. We'll simply create a simple architecture diagram for architecture or a data flow diagram. I would use the word data flow, but with some architectural components using PowerPoint just to quickly land the idea here. And then I'll actually walk you through some of these examples, right? So we build on top of it. Now, so this is essentially your database. Sorry, this is essentially your Think of this as your OpenAI service, right? So this OpenAI service is essentially going to be available here for you to access. Then somewhere you have a web application, like a chat application. I am just putting this as a chat application here. You don't have to worry about how that chat application is being built. As a data scientist, you don't need to worry about it. That is something for generally your developers to figure, like your engineering teams to figure. But a chat application would typically have components like a web app, right? So they will have to build a web app. And this web app is typically built in a React or a again, if it is a mobile application, then it would probably be like a cloud, a platform native development, basically like a actual out and out web application or a mobile application that they will have to build. A React based front end. I'm just giving you React as an example. It can be built in Node or any of the other technologies as well. And then this chat application would also have sort of a backend, right? So what's going to happen is a user is going to interact, right? A user here in this particular case is simply going to interact through the web application, right? So a user in this particular case is going to interact through the web application. That is essentially what you had seen in the previous case, right? And that becomes extremely important because the web application will then act as like a entry point for this particular user. Now, it's important for me to call out a couple of things here that do not expect the user to be, in most cases, do not expect the user to always access this through a chat interface. It could also be outside of a chat interface as well, right? So we can talk about that as well. Now, I'm taking OpenAI as an example here, the OpenAI service. When I say OpenAI service, I'm essentially referring to the OpenAI API that you and I are accessing. This is sort of generally something that sits outside of your complete ecosystem, right? Which is why I'm going to put it somewhere out here. Now, when a person asks a question, right? So when a user asks a question, so now that question, Control C, I'm just going to put Q as a question. This particular user is asking a question. And now this question typically should go and hit a backend service over here. What does that do? This backend service is sort of think of it like a Python engine, right? This is a Python. It could be Python, it could be anything. I'm just taking this as an example, Python as an example, right? So this is a Python, sort of a backend service. What does this backend do? This backend has 2 or 3 responsibilities. The first responsibility is to convert, I'm talking about key functionalities here, convert query to embeddings, right? So what this is going to do is this backend service is going to fire a query from here to the OpenAI service. This will fire a query to the OpenAI service. And what it will get back as a return is essentially a set of embeddings. So it's going to send the query typically, and it'll get back an embedding. I'm going to put an E over here. Right? It's going to get back an embedding. It's going to send a query as an input. It's going to get back an embedding as an output. And typically, what kind of a model will be used over here? Anyone? What model is being accessed to be able to generate this response? An embedding model. Remember what was the model that we had used in the example? Not a word to it, guys. It's an LLM, but you remember there was a model called ADA. The OpenAI had a model called exactly an encoder model, some kind of an encoder model or an embedding model. In this case, something like a it OpenAI has a model called ADA, which is essentially the embedding model. If you remember from where did that go? Let me show this to you. If you go to docs, you go to models, and under the models you can see embeddings. If you see the embeddings, this is the model. You remember text embedding ADA 002. This is generally the model that we would be using for generating any kind of an embedding. This is also the same model that we had used in this example. Let me show you that. See, look at this. This is the embedding model. Text embedding ADA 002. We use the same model over here to be able to generate that particular response. And you would have, in the case of some of the other examples, you would have a bunch of other models that are available like this as well. Let me just okay, cool, awesome. So now the backend has been created. This backend has Python backend has been created, and it has converted the question into embeddings. Then what is the second task of the backend? The backend is also responsible for sending request to the or extracting context from vector DB. That is what this is also going to do. So once a function is completed to convert the embeddings, the second is it is going to run another function where it is going to extract context from the vector DB. So how will it do that? So for that, firstly, you would require a vector DB to be available, right? So this is your Python backend, right? And this is your chat application. This is your vector DB. Now this vector DB, you might remember, is essentially just a collection of multiple vectors, of your context. So this vector DB would have already should have already been populated with a lot of this information that we see here. This vector DB should have already have been populated with all the information that you have here. From where? So this vector DB has to be very close here. And this vector DB has access to unstructured data, whatever this unstructured data is that we're referring to, right? So it could be PDF files, it could be whatever, right? So PDF, Word documents, text files, images, whatever, right? So call it, you name it, and so on and so forth. Now, this vector DB has access to all of this information, and what would have happened and what should have happened rather is all of this information should have ideally been already ingested into this vector DB through a batch process, right? So this is not a live process. This is a batch process. So all the embeddings, right? So, E1, E2, all the way up until En, they should have all been ingested into this vector DB. Now, how will this happen? It's not going to just automatically happen. I cannot simply point a vector DB to unstructured data and say, you know what, go ahead and put everything in the vector DB. That's not how it works. So what I would need is I would need some kind of a Python job or again, I'm considering Python as, loosely here. So there should be some kind of a Python um, job that converts data to embeddings to E1, E2, E3, all the way up until En, right? This is super, super critical. This is a batch job, remember. This is not a real-time activity. This is a batch job, which is why I'm referring to that as a batch activity. Now, why am I saying that this is batch? Because, see, this data is probably never going to be always the same. This data might continuously keep increasing. So in that scenario, what do you need to do? You need to continuously update this vector DB. But how frequently will you have to convert that? How frequently will you have to keep updating it? Not very frequently. Whenever the data gets updated. So whenever and that this job can be triggered through a some kind of a trigger, right? Like for example, if the data here changes, then you trigger this job. Else you don't run it. So this is sort of a batch activity. This doesn't have to happen regularly. This can happen once in a while. But this can be triggered only when there is some kind of a change in your original data itself. Otherwise, you don't need to do it. Only incremental will have to be done here. So now let's ask the question. So now there is a question that has come. There's a question that was raised, right? That question went into this Python backend. This Python job has converted the question into embeddings. There is and it has also sort of extracted, it has also nicely extracted the embedding, and it has also extracted the content from the vector DB. But for that to extract the content from the vector DB, it of course will have to fire a request to the vector DB, isn't it? So here is where there is a request made to the vector DB. What will have to be passed to the vector DB and what will be generated out of this particular vector DB? I'm seeing questions here. Perfect. The input has to be the embeddings and the output will not necessarily be chunks. You're right in a way, right? So it's sort of a combination of both. So it's a two-way query that's essentially going to get fired here. And the input is going to be, as you all rightly said, the input's going to be the query, and the output here is going to be the relevant embeddings or the nearest embedding. So actually, it's going to be two things that are going to come out of this. It's not just the embeddings. It's going to return multiple things for you. So it's going to return embedding 1, the embedding itself, and it will also return the chunk 1, right? So which is essentially going to be a string. Similarly, and this will essentially be the first output. This will be the first one. Similarly, it would return another one like this, another one, and another one. And this is probably going to be chunk 5, the embedding 5. You probably actually don't need the embedding if you think of it. It just needs the similarity score if you actually think about it. The embedding value itself doesn't make sense, right? So the similarity score is all that matters here, and the chunk. Do you all agree with that? Right, something like 0.95, right? 0.95, 0.93, and so on and so forth. So this is similarity 1, similarity of the 5th, similarity of 100th, and similarity of maybe nth. That's essentially what's going to come back. So this is what's going to go in, and this is what's going to come out. We'll talk about images in some time. Right, this architecture will change depending upon scenario to scenario. This architecture will change. But now that this is going to come out, then the next question is, now that you have the response is coming out, the next step is this Python backend will then have to fire one more query. What does it have to do? So that you've got the top 5 as a return, right? So it has returned, let's say, the top 5 or top K embeddings. Top K have been returned. Then what do? Exactly. So you will have to fire one more to then summarize, right? So for you to then summarize, so you'll have to make the second call here, which is going to be again a query that goes from here all the way up until your OpenAI service. You'll make another call over here. What's going to be the input and what's going to be the output? So the input is going to be this piece. It's going to go as an input to this, and then it'll return back the final summary response. I'm going to put it as R. I'm going to call it as R over here, or rather response, I would say raw. Sort of a raw response is what you're going to get. And this raw response can be further fine-tuned to get your final response, which will then sort of be sent back through this. But broadly, do you all agree that this is essentially how it's going to work? This whole thing? Exactly. It'll compare not the score, not the embedding values, but the chunks. The OpenAI service will essentially take the chunks. Actually, it doesn't care about the similarity scores, honestly. All that it cares about is the chunks. So you pass the chunks, not just the chunks. You will also pass the question here. Remember, along with this, you will also be passing the question. So actually, it's not going to look as simple as this. Actually, that's a good point. So you're essentially going to pass one string here. So you're going to pass the question plus, right? C1 plus C2 and so on as one large string. You're essentially going to pass this as one large string over here. That's going to go in here as an input, right? And then you will come up with a response as the output here in this case. The backend service should make 2 calls. Yes, 2 calls. Yes, one to the vector DB to fetch the right information, and then one. If you think of it, it has to make. Technically speaking, if you consider this backend as a service, as a microservice, I'll talk about all the different interactions. But I think I made a small mistake here. This has to be a two-way query. It's a post query. Yeah. So if you think of it, there is one API call that's being made to the Python backend. And this Python backend first step calls the OpenAI service. That's the first call. Then it calls the vector DB. That's the second call. Then it takes both of these, and then it makes a call to the OpenAI service. It takes both of these and then makes a call to the OpenAI, which is the third call, and then sends a call back to your chat application. So that's the fourth call. So your backend application actually has 4 interactions. So this is essentially sort of the most important part of your for all good purposes, this is sort of your most important part of your this is sort of the heart of your complete application, the Python job that you see here, Python application that you see here. Python backend gets embeddings from, yeah. So if you were to sort of put the, okay, let me put the sequence over here of how this works. This is step 1. This is your step 1. This is your step 2, right? This call is your step 2. Then this is your step 3. This is your step 4. This is your step 5. And this part is batch. This is a batch operation. So this piece that you're seeing here is a batch operation. So you could sort of forget about that in some sense. That is not a part of your querying process. This can sort of sit out of the whole thing. Batch, that's a very good point. Yes, the batch will also use the OpenAI service, which is an absolute reality, and I have completely missed that. So I'm going to just make it simpler. Then in that case, just change these interactions. Perfect. Cool. That's it. So this is essentially the. I hope this does justice in some sense. So yes. So you're essentially passing this into this. This will essentially get the this will essentially get the whole thing from OpenAI. That's another call, and then that'll pass it to the vector DB, and this vector DB will then help you generate the results as expected. What saves in vector DB is all embeddings of the corpus, right? What is the difference between vector DB and the regular DB? Is vector DB a kind of tables, or what sort of data is stored in a vector DB? I'll show that to you in an actual example. But the short answer to that question is yes. A vector DB is simply nothing but, let me just, a vector DB, in all honesty, is just a regular table, nothing else. The only difference is also sort of a collection, regular collection of data. The only difference is it doesn't store data. I mean, it is a structured representation only. So you would have indexes, right? And then you have chunk one, or rather some kind of an ID identifier. You would have the raw, text. Generally, the raw text is not stored. You store it in some form of an encrypted fashion. You just binarize it and store it as a binary string. And then you have the embedding. Now, embedding is generally a vector, an array of numbers over here. That's essentially what you have. And this is indexable. This embedding that you see over here. Now, the beauty of this is that, and you would have one more array, and so on and so forth. So when you have the question array that's coming in, right? So this is essentially your embedding E. So when you have a question coming in, ideally, that's where things are generally very tricky, because what you would have to do is you will need to find the similarity of that question with this embedding, find the similarity with this embedding, find the similarity with this embedding, and so on and so forth. If you have 1 million embeddings, you'll have to find the similarity. Now, as you can imagine, this is going to be a very, very time-taking task. So what these vector DBs have is, instead of you going sequentially from top to bottom, they have an extremely fast way of retrieving the best neighbors of this particular question. So they have something called as approximate nearest neighbors algorithm built into them. What do they do? So what they do is, their responsibility is they look at all of the embeddings and the given question embedding, right? So when I say question, this is essentially the question embedding, remember. It takes the question embedding and then it tries to find the similarity across everything. But the problem is, if you were to do it normally, it would take you very, very long, because you will have to essentially write, like, I mean, if you think of it writing in Python, you'll have to write it like a for loop. It's very expensive. For loop is essentially an order of n magnitude. And if databases take an order of n time, then the problem is that they're very, very expensive, very, very slow. On the other hand, you could use some of these approximate nearest neighbors algorithms. Some examples of these algorithms are HNSW. There is something called as locality sensitive hashing, LSH. Then you have NMS lib. There are algorithms like Annoy and stuff like that. There are a lot of algorithms which find, given any array, they can compute cosine similarity of that particular array with a list of bunch of other arrays in a very, very quick fashion. But these are essentially those algorithms. That is, these algorithms that make, and by the way, these algorithms that make these vector indexes or vector DBs very, very good. It's what separates these vector DBs from your regular SQL sort of a DB. In a regular SQL database, you will just have data sitting over there. You can write an SQL query and you can retrieve the data. Here, you don't retrieve it like that. Here, the way you retrieve it is you ask a query. Once you ask a question, through an embedding, you can pass a vector as an input, and then it will try to find the nearest set of vectors against that particular vector in the shortest possible fashion. That's how these vector DBs have become very, very popular. Does that make sense? And the way they do it is because of some of these algorithms, and these algorithms are baked into these vector DBs. That's what makes these vector DBs very fast. The retrieval is extremely fast. Now let me quickly show you. I wanted to pull up the right architecture diagram, but anyways, doesn't matter. Let me show you this. Right. So I'm going to walk you through like a very simple example, but using LangChain, of course, in this case. Quickly show you how you could use LangChain to do some of these quick examples. So let me just execute this. Do we create vector tables manually or is it automatic? We'll have to create it ourselves. You and I will have to create it ourselves. Okay. So I'm gonna import like a couple of things here. I have the OpenAI key available with me, which is the one that we just used a while earlier. So the task that I'm going to be using is very simple. So I'm going to be taking like some kind of a GitHub page. So this is like an LLM-powered autonomous agent. There's like a GitHub page on agents on LLMs itself, like some kind of a architecture page that is available. So I'm going to like try and build something on top of it, right? So first step, what that I'm doing is I'm using this library called Beautiful Soup. I don't know if you're aware. Beautiful Soup is essentially like a library um, for scraping. It's for web scraping. So you could kind of scrape any page that you wish to. So as I'm showing you here, you could just use this to scrape it. You can also pick any Wikipedia article you're interested in, right? Any article you wish to. I don't know. I extracted it about Galena. Let's maybe look for, I don't know, the 2024 Olympics or something. You can take anything you want. Where's the Wikipedia page? There you go. 2024 Summer Olympics page. Now I'm just doing one page, but you could technically pass any set of pages you want or how many ever pages you want. I'm just going to extract this. That's going to simply load it. So if you actually look at the docs, there you go. So the complete page is here for us. Right, it's a complete page with the whole thing. Let me show the prints here. I can also print the content. So if you see, there is like total 85,000 lines of content. This is not complete Wikipedia. This is just one page in Wikipedia. One article in Wikipedia that I'm currently loaded, not the complete Wikipedia. So if I look at the top 5,000 lines, here's how it is. Text editor. So here's how it looks like. This is the complete first 5,000 lines of content. And I'm sure there must be some, yeah, there you go. There's some lines over here that are available. What links are related? Blah, blah, blah. Yeah, there you go. This article summarizes sporting event. A lot of information that's available. This is the raw content that's available, by the way. Okay, cool. So anyways, so now going in. So now what I'm going to do is the first step, right? If you go back here, let's go to our architecture diagram. The first step. So I have, let's say, one of the PDF. So in this particular case, it's like a HTML file. It doesn't matter. You don't need to do any cleansing. Aniruddha, you can just use it as it is. Any website you want can be scraped. You just have to be a little careful about the structure of some of these pages. At times, some pages can be a little tricky, but you can scrape any page you want. Just letting you know, scraping is not always legal. So just be careful. So I'm essentially using a simple text splitter over here. There's a functionality that's available on LangChain that can help you basically chunk your data set into chunks of 500 words. with an overlap of 100 words, right? And I'm simply going to chunk them. So if you look at now, there are a total of 239 chunks that have been created out of my complete data set. 239 chunks have sort of been created right now. Now, what can I do? Right. By the way, you can take any of the splits and you can look at the page content. Actually, so look at this. If you just look at the first split, and if you look at the size of the content, 481 words are there. Of course, it will not create exactly the same number of chunks. It will approximately try and break like that. Right. So 481 pieces of information is available over here. And then if you keep going, now what I'm doing is I'm essentially loading a vector database called as Chroma. Now, see, what I want you to understand is these vector DBs, there are many, many vector databases that are available. What are all the different types of vector DBs? Let's go here. Let's quickly spend a little bit of time on this. So when you talk about vector DBs, they are broadly in memory and cloud, or rather in memory and SaaS managed instances. Let's go that way. What do you mean by in memory? And a good example of in memory are something called Chroma. Chroma also has a, I think that Chroma also has a managed instance, but I'm just giving you some examples. So here Chroma DB is a good example. You have something called as Space, which is also an in-memory vector DB, which basically what do you mean by in-memory? In-memory mean by in-memory as in this is a vector database that is created inside your machine, right? It's not a separate database. Are you aware of SQLite, SQLite? Have any of you all worked with SQLite? This is like SQLite, right? SQLite is not necessarily a separate database. It's an in-memory DB that is created in your machine temporarily for you to work with, right? It's not like a database that's created elsewhere for all of us to access. It's essentially a database that is created in your database in your machine for now, for the moment, temporarily. But there are very similar managed instances that are also available. What examples are? So Redis is a good example. Pinecone has managed instances. Postgre, has something like this. Azure Search has a search vector DB. Similarly, you have AWS has something very similar, and so on and so forth. So you have like a bunch of such managed instances that are available that you can sort of access. Now I am creating something in memory in this case, right? So I'm using the Chroma DB. And all that I'm saying is that I'm going to be using the OpenAI embeddings, which essentially uses the text ADA text embedding ADA model by default. I can pass the model as well over here. So the model equal to, and I can pass the model as well. But the default model is anyways the text embedding ADA 002. So what I'm doing here is I'm saying, hey, look, I'm creating a Chroma DB, but how do I create a Chroma DB? Chroma from documents. I'm passing the data as well over here. As you see, I'm essentially passing the data also over here, and I'm asking it to simply create this. Right, so when I execute this, this will now create a Chroma database, Chroma vector DB in my system right now. So it's essentially storing all of this into a vector DB as we speak. So now my vector store has been created. My vector DB has been created. So if you look at vector DB, that is a in-memory vector DB, the memory location that's been created. So now I can simply say web page broken down into 481 chunks. I'm also defining a retriever here. I'm saying, hey, look, vector store, and I'm creating a retriever. Search type is similarity, and I'm saying, hey, retrieve the top 5 documents. Whenever I call this retriever, retrieve the top 5. And I can ask, where is the Summer Olympics 2024 happening. I mean, you can pick any, as many as you want. I picked top 5 here, just as an example. Chroma is not a cloud vector store. It is an in-memory vector store. In-memory as in inside my personal machine right now. It's running in my memory. Yeah. So retrieved. So now I have extracted. So if you actually look at the retrieved information, see, look at this. I've asked for this question, where is the Summer Olympics 2024 happening? It has says Paris 2024, 2024 Olympics and Paris Olympics redirected here. So it's essentially pulling out all of the information for the 0th one, similarly for the first one, similarly for the second one, third chunk, fourth chunk, and if I type fifth, it's going to return an error, of course, because there are only 4 totally. I mean 0 to 4, which is essentially like the 5 thing. So it has retrieved all the necessary information. Now I'm going to use the generation part of it. So retrieval is done. Right? I stored the vectors. I retrieved it from the vector DB. Now I'm essentially going to generate it, do the generation. So, and I'm going to say, hey, chat OpenAI models. Same thing. I can use the same piece of code that we had done earlier as well. Take whatever you want. And I'm going to say, use the following pieces of context to answer the question. If you don't know the answer, just say you don't know. Don't try to make up an answer. Use 3 sentences maximum to keep the answer as concise as possible. Always say thanks for asking at the end of the answer. Context and the question. So now, this is the template that I've created. The error. Let's execute this. And okay. So if you look at this, my prompt has been created. All that I'm going to do is I'm going to say, yeah, it doesn't matter. I'm just going to delete this. That's it. Now all that I'm going to do is I'm just going to ask that particular question. Against that particular template, I'm going to say, where is the Paris Olympics? Where is the Olympics happening in 2024? Now it's going to start generating. The Summer Olympics in 2024 are happening in France, with Paris as the host city, and the events are held in 16 additional cities across metropolitan France, and 1 substitute in Tahiti, French Polynesia. Thanks for asking. And what are the top? Sure, let's search 2022. Where did Olympics happen in 2022? It made up. Should have been Tokyo. So I should, we should probably 2020 Olympics. It should say Tokyo, hopefully. Did not happen in 2020 due to the COVID pandemic. The Summer Games were postponed to 2021. Thanks for asking. Yeah, we'll have to force it to be as true as possible and not make up anything. Ensure that you are extremely truthful. Let's force it. Let's try again. Perfect. There you go. And yeah, see, if you ask this one question, who is the Prime Minister of India? Of course, as I don't know. Yeah, of course, you can force it to give you a wrong answer as well. You can definitely do that. You can say, if you don't know the answer, and we can say, come up with an answer that is extremely, that sounds super realistic. Provide some evidences to make it sound real. Okay. Now there you go. Let's go. Let's try. I don't know. It knew the answer, so it made up. So let's ask this question. Probably will have to change the prompt a little more. I don't know if I removed anything here. Looks like it did not retrieve anything at all from the who is the I don't know. Yeah, looks like it couldn't find anything. By the way, also just to let you know, right here, that reminded me of something. So what might be happening in this case is probably not fetching anything from the content itself. The reason is that when you're looking for, vector store retriever, right? The keyword arguments that we're passing here, you can actually get it to get it to fetch information from you can pass like a you can sort of pass like a threshold. So you see here like a score threshold as well. Instead of just passing the top 5, you could also pass a score threshold. You can say, hey, look for at least something that is 50% similar. So what may also be happening? So either you could do this or you could do that too. So that is totally your choice. So if you want to go like a slightly different, you could try something like that. So you could do something like this. And so it couldn't find actually anything that's similar with score threshold. Yeah, with that score threshold, it couldn't find anything. Kind of bad. So let's go back to this one. Yeah, but that's like another option that you have. See, the point is the only difference that we've done here from the previous case is we've introduced this vector DB, right? We've introduced the vector DB. And the other thing that I also want you to understand is look how simple the code is right now, right? Look at how simple. I mean, forget about all. Actually, this is all not even code. Right? So I could just forget about this. This is super simple now. The code is extremely lean. Storing into a vector DB is like one line code, right? I know it's in memory, which is why it's one line. But otherwise, splitting is just a couple of lines of code, right? And storing it is like one line code. Retrieval is 2 lines of code. And then last but not the least, generation is a couple of lines of code again. Generation, we have done it in the past as well using LangChain. So that's what LangChain does. LangChain abstracts the whole damn thing. So remember in the previous case, if we were to do that, we had to write like functions over functions over functions over functions. Now all of that is abstracted. So you remember this function, the search function to find the similarity. We don't need any of this anymore because we are using LangChain and LangChain takes care of all of this for you to retrieve the right. ChromaDB takes care of some of this for you. So especially this part is taken care of by ChromaDB. LangChain takes care of ensuring that all of the splitting and creating embeddings and everything is taken care of. LangChain takes care of all of this. So that's the beauty of using something like a LangChain, using some of these components on top of your existing solution. And once you have something like this, once you are able to build a setup like this, of course you can very comfortably build like an API layer where then you can start chatting, right? So where you can start asking questions back and forth. So my point is you will have to start leveraging some of these components. Only then you will be able to build a scalable capability. Else what's going to happen is we'll end up writing code that might not scale. So for that reason, it's very, very important that we need to do this. So in order to make an enterprise level application, the core piece is very, very simple. It is not going to be very complex. The core AI part is very simple. It's the engineering around it which is going to make it very complex, right? So you will have to exactly like somebody saying. So you'll have to host. You can host it on Streamlit. So if you're hosting it on Streamlit, right, Anil, what's going to happen is you will not have two separate services. This web application and the Python backend will essentially be the same app then in that case. Then you will just have multiple endpoints within the same service, and then you're essentially going to go back and forth, which is again not enterprise grade. Streamlit, nobody uses Streamlit as an enterprise grade solution. It's a good thing to do demos. Streamlit is useless otherwise. It's great for demos. It's useless otherwise. Should we always use LangChain? Yeah. So you will have to build build a proper web app, right? Build a proper web application, a native React application, or a or a JS. Use JavaScript, any of the scripting languages, and then build a front end app, and then a proper back end using either Node or Python or whatever. The good part is all of these interactions are just API calls. So you could have a nice backend over here that's taking care of all of it. Generally, what happens in our in our architecture, right? What we have done is we have one more backend over here, and then the actual core engine. The other backend will then take care of doing all the Active Directory authentications, role-based access control, all of that then comes in. So you will have like one more layer over here that is managing all of that before the application. So you'll sort of have two layers between before it actually hits the core engine itself. So all of that will come in. Is LangChain is what we will use for embedding, since it's an orchestrator layer on. You could use LangChain. There are other alternatives as well. You could use either LangChain. You could also use something called as Llama Index, right? So you could also use something called as Llama Index. This is also a very, very similar one. I'll just show you a simple example. Yeah, you see the documentation. I'll give you something very interesting, okay? So this is LangChain, right? LangChain actually has their own chat application where you can actually query on top of their own document. So it's like, give me the code for running a simple RAG application using PDF documents in, I don't know, Google Drive. Let's go. And perfect, there you go. So it's given me the whole thing here. So it has answered the RAG application. So it has given me few things. One is it has of course given me a Google Drive here that I can use to search. And on top of this, I can say, give me the rest of the RAG code. Perfect. This is the remaining of it. Done. That's it. So they've built it on top of their own solution here. They've built this on top of their own. This is using RAG to retrieve the result. Yes. This is built on top of their own documentation. They have provided all of their documentation to this. Make sense? And by the way, if you look at it, this is exactly the piece of code that we've used. Exactly the same piece of code that we've used. Retriever, rag.run, and you could do the same in Llama Index as well. Llama Index also has their own. It's not loading. Yeah, there you go. You could do the same here as well. You could query the same here as well.
Just a quick info, guys. Intellipaat offers generative AI and prompt engineering course, which will help you gain proficiency in creating generative AI chatbots and other GenAI tools, along with mastering the latest tools and techniques with hands-on projects and real-world case studies. And the best part, this course will be taught to you by IIT faculty and the top 1% industry experts. What's more, you'll be getting your generative AI and prompt engineering certification from Microsoft. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description down below. Without a doubt, this course can set your careers to new heights. So visit the course page link given down in the description below and take your first step towards your journey as a Gen AI engineer.
Let's talk about the prompting techniques. Okay, so when we talk about the prompting techniques, right? So there are, as by now you must have realized that prompting is sort of an art than sort of a science. But interestingly enough, when we talk about prompting, there are some aspects that you can definitely control, right? So when you take up a course on prompt engineering, or when you discuss about prompt engineering in general, there are certain design patterns through which how people generally ask questions, right? What are they? So the first one, more often than not referred to as, when we talk about prompting and design patterns around prompting, the first one is your regular zero shot prompting, right? What do you mean by a zero shot prompting? Zero shot prompting is essentially simply like asking it a question and answer to resolve a particular query within that particular question itself, right? What do we mean by, so like for example, you simply ask it a question. You simply say, hey, there are 20 people. Five of them have gone to do a certain task. How many are left? So you're essentially asking it to resolve that particular question within that particular sentence itself. Or you're saying, hey, here's a tweet. Can you classify this tweet into one of these three categories: positive, negative, or neutral? And what it is going to do, it is going to try and classify that particular prompt for you immediately at that very point in time. So that is essentially referred to as zero shot prompting. It is trying to act on something immediately, right? So without really any kind of a background, so to say, right? So that is referred to as zero shot prompting. The second kind of prompting is referred to as your few shot prompting, or few shot learning, referred to as FSL generally. What do you mean by few shot learning? A few shot learning is where you're asking it a question, but you're also telling it how it could be answered with some examples. So, for example, if you say classify, an example prompt can be classify the following tweet into positive, negative, or neutral. Use the following examples as a guardrail, right? And then you can provide the three examples. You can provide sentence one or tweet one. You can say tweet one. You can provide the tweet and then classification. You can say this is positive. Similarly, example two, tweet two, the tweet and the classification negative. And then tweet three, the tweet itself and the classification neutral. So by this, what you're telling your large language model is you're saying, look, if it was a regular few shot prompt, it would have simply just been this part, right? And you would have simply passed the query to it. But by doing this, you're also telling it, you're giving it an example of how to go about doing it. You're telling it exactly how it was done in the past with some examples. So that is also a very, very good way of going about prompting your large language model. Your large language models generally do very, very well when you provide such kind of approaches. When you provide them few shot prompting, um, they generally do a very, very good job with few shot prompts. So zero shot prompting or few shot prompting is a very common approach that you would perform. With few shot prompting, you're sort of setting expectations. That's the right way of doing it. So this is essentially your few shot prompting. Zero shot prompting and few shot prompting are essentially very, very popular techniques that are often used. Now, within these, right, using the zero shot prompting and few shot prompting approaches, I'll show you a couple of examples in a minute. By the way, just like actually, let's look at a quick example, right, and then we can come back to it. Cool. So we can take any of the examples from our previous from the stuff that we've done in the past. Like for example, we can take let's pull up the LangChain 101 example. We can actually build on top of this. Okay, cool. So if you look at any of these examples, right? So let's take, for example, one of these examples. Let me just load the .env into this, and let me go in here, the LLM, the chat model, and then we can either use the chat template or, okay, let's use the chat template. Drag, photo. Awesome. So here, right? So this, by the way, is the GPT-4o. We can use 3.5 as well if you wish to. By the way, this is the previous example. Now, what I would want to do is, let's say, when I'm providing the system prompts, here is where, so if you look at this example, right, this is a simple zero-shot prompt, right? I am asking it to get to the final answer in one go. All right, I am not giving it any slack. I'm simply saying, you're a very cordial translator. Please read before you respond. You're proficient in English as well as in Hindi. After you respond, share a small piece, and I'm simply asking it to translate this sentence into Hindi. One go. I'm not giving it any other. I'm not giving it any more context. So this is like a good example of a zero-shot prompt. Now, if I were to create something very similar for a few-shot prompt, this is how it would look like. I would say, you are I'll probably go a little multi-line. You are a very useful assistant. You are good at classifying tweet into positive, negative, or neutral. Here are some examples of how that classification could be done. Neutral or sarcastic. And then you could go something like, let's remove this actually to start with, and we can come back to this. Sarcasm is not a sentiment. So you could say, example one, tweet. You ideally should try and, whenever you're providing this information, try to follow some kind of a pattern so that it's so much more easier for it to understand, right? So example one, and here, because it's the first example, you can provide that again as, so in this case, I'm following the pattern of a JSON. So the tweet here can be, this is an amazing studio that you have, and this is the sentiment is positive, right? That's the first example. And similarly, you could provide another example. This is the second example. Tweet. This is less, and here I say this is negative. And then I can, of course, provide one more example. So this, as you can see, this process of trying to create multiple examples is super, super important. Now, you can imagine where this could be very useful, right? So, for example, if you're trying to translate some code, that's another example, and that's another place where this could be very useful as well. Right. So that's it. So that's essentially like 3 examples that I'm providing here. And then I can pass whatever input I want, and I can ask it to simply, classify it. I can pass the tweet itself. And the tweet here can be classify the following tweet. So something like that. And then you simply ask it to execute this. Something went wrong. I think, did I miss a parenthesis somewhere? Let me just simplify this. I just want to follow one structure that is easy. I think it's reading this differently. I don't know why. Okay, let's try this. Okay, let's go. There you go. That's it. Done. So as you can see, it has returned the response, and it has returned the response exactly the way I want it to. And that seems to work. Right, yeah, that should not matter. I think there is one. Yeah, I think I removed that. Cool. Okay, but you get the idea, right, everyone? So I think I'm assuming this is clear. At least you know that when you ask a question, you don't simply just ask the question, but you ask the question. But in the prompt, you also pass some examples of how it could go about answering that particular question as well. And that's a very, very common, sort of a template that people tend to follow. It's called as few shot learning. Now, you could also extend this to larger kinds of examples as well, right? Like, for examples, you could say, you could do this for code as well, right? For code, this is actually a very, very good example as well. Like, for example, you could ask a question and like a SQL query. You could ask a question and like a Python query, it also depends on, like, for example, if you're doing SQL, or natural language to SQL, and if you want to build like a small template that converts natural language to SQL, you could simply use it to use the same kind of a prompt template. But in that particular case, you pass, here instead of a tweet, you pass the natural language question, and then here instead of sentiment you simply say SQL, and you pass the SQL query here. Same tweet, the natural language query, SQL query, natural language query, SQL query, and then every time you ask a question, it simply tries to find the SQL query associated with it. So it's like a very, very good approach. And as you can imagine, when you asked it to respond back, it exactly followed the same template of response that was created earlier. You see this, right? So tweet sentiment, tweet sentiment, tweet sentiment, it exactly follow the same template of a response. So that's the beauty of few shot learning. Few shot learning will ensure that the same style of responses and the quality of the responses sort of transferred to this as well. So that's how FSL works. Okay. Now, it's not a very complex, task, but this is something that I just wanted to let you know. Now, why is this important? Now, the reason why I wanted to introduce this is because I want to talk a little bit about some more, techniques over here. I want to talk about a few more design patterns over here, right? Along with these two, zero shot prompting and few shot prompting, there are some more advanced prompting techniques as well. Like what? So one of the most popular prompting techniques is referred to as chain of thought. What do I mean by this? Chain of thought is essentially asking. So I think somebody just asked me about a math problem, right? So this is the exact kind of prompting that you would have to do to be able to answer math problems. So a chain of thought prompting is, you must have observed at times, right? So if you ask the LLMs like equation, and if you just ask them to solve it like a zero shot prompt, they fail. But the same question you ask them by structurally having it to break down step by step, right? So if you tell it, break down this particular problem step by step and then get to the final response, more often than not, they do a very, very good job of it. They do a fantastic job of it. So that process of breaking down a particular question step by step is essentially what we mean by a chain of thought prompting. So this is to force the prompt or have LLM break down a task into multiple subtasks or multiple sub-steps, I would say, and answer it one by one. Right? That is what we mean by a chain of thought. Now you could also do chain of thought, right? When you're doing chain of thought, you could do chain of thought both ways. You can do chain of thought using zero shot as well as few shot. What do I mean by doing chain of thought through zero shot? When you say chain of thought through zero shot prompting, you are essentially going to simply add the sentence as a part of the prompt. You can simply say answer this question, but break down this particular question into sub-steps and answer each of the sub-steps and then get to the final response. So you will write the prompt that way. When you do it like through a few shot, you are actually going to tell it how those sub-steps are going to look like. You will explicitly tell it what those sub-steps should look like. A very good example is through chain of thought. A very, very good example is where you simply say, you can ask it a question like, okay, what are so the question could be, the query here could be something like, why did the sales of, let's say, Mumbai come down for our business? Right? So you're essentially asking a very specific question. And here, along with the question, you also say, break down the analysis into the following sub-steps and answer one by one and summarize the final response. Now here you're going to provide an FSL. So the question is, why did the sales come down and then you can provide multiple sub questions, and then like a final response of how you would summarize all of it. So by doing that, you are providing some kind of a guardrail, again, some kind of a example, a precedent as to how your LLM should go about answering that particular question. Again, it's the same thing. It's few shot learning, but few shot learning with a little more structure. So you're asking it to break down a question into step by step. So it has often been observed that specifically for math problems, this kind of works very, very well. So let me give you an example here. By the way, you could also like change how the way you're writing the prompt here, but that's up to you. So you could use LangChain's what was the system message? I think from dot prompt template, if I'm not wrong, dot schema. But anyways, so you could also say dot schema import system message, comma human message. So this will essentially, instead of you passing it like this, you can simply say system message off and human message off. That will also take care of it. But anyways, doesn't matter. Okay. So let me just delete this. So in the system message, you can simply say you are an assistant that is very good at solving math problems, right? And you could say, and the input can simply be the question that you wanted to answer. So it could simply say, solve the following equation. And you can say 3x plus 5y is equal to 320 and 2x minus 3y is equal to 110. And I can ask it to simply solve both of these equations and then come back with a response. Now, while it is actually, so look at this. So it's actually tried to solve this particular problem. It has actually already tried to break this particular into step by step, and it has tried to solve the problem. We can use the method of elimination or substitution. Here we'll use the elimination method. So it's already tried to do it. That's probably also because I'm using a 4.0 model. Let me try to go for a 3.5 turbo or something. The 4.0 models are actually pretty good. Four models are actually very good at math. Yeah, so it's tried to answer this question. I don't know if this is actually true, but we can see 3x plus 5y is equal to 230, 2x minus 3y is equal to 110. To eliminate one of the variables, let's multiply equation 2 by 5 and equation 1 by 3. Seems all right so far. First one by 5. Yeah, it's actually it's actually messed up here. Right, so 230 multiplied by 5 is not 550. So it's sort of messed up. And this one, 110 multiplied by 3 is also not 690. That's clearly messed it up here. Again, a very, very confident answer, but clearly messed it up. Now what I can ask it to do is I can say specifically here, I can force it to break down the problem into multiple sub-steps. I'm going to be very explicit here. So this is essentially chain of thought, right? So I'm asking it to break it down into multiple sub-steps and ensure every step is perfectly validated and the response is appropriate. Only proceed to the next step. Thank you. Okay. So, I'm sorry. Now let's try this. Okay, now let's take a look at this. What is it saying? We'll solve the second equation for x in terms of y. 2x minus 3y is equal to 110. So 2x is equal to 3y plus 110. X is equal to this. So far, okay. Let's go to step 4. Substitute the expression for x into the first equation. So it's taking x value of x and substituting this into the first equation. So 3 times 110 plus 3y by 2 plus 5y is equal to 230. So 3 times, that's not bad. So 10y is equal to 460. It's essentially taken the LCM and it's taken the 2 onto the other side. So 460. So far, so good. 330 plus 9y is equal to 10y plus 10y is equal to 460. Perfect. 19y is 1310. Sorry, 130, which is also perfect. Y is equal to 130 by 19, 6.8. Perfect. This is good, right? See, that's the difference. So when you prompt it and when you ask it to go step by step and validate every step, it does a much better job than in the previous case. It just screwed up earlier, right? So I'll actually leave the previous one also here. So that is chain of thought. So actually here in the previous case, it was able to come back with the right response here as well, but it made some mistakes otherwise. With the 4.0 model, it messed up. With the 3.5 model, it got to the right answer. But you get the idea, right? You understand how these prompts really matter, right? So you're essentially structuring how it should operate. You're getting it to operate a certain specific fashion. And that becomes extremely important for these models to perform. Else, what you could also do, right? You can follow now. This is taking it one step further, right? So you can take it one step further. You can follow the following approach to solve a simultaneous equation. So, what is it? Problem is, I don't know, x plus y is equal to 10. And x minus y, x minus 2y is equal to pi. And then you can ask it to solve it a certain way, right? Subtracting step 1. Multiply the, I'm just taking a slightly longer route. The first equation by 2 on both sides. And it's, so this is going to make it 2x plus 2y is equal to 20, and x minus 2y equal to 5. And equation 2. Step 2, subtracting. So essentially, both the Adding both the equations, you would get 3x is equal to 25, x is equal to 8.33. Step 3, substitute x in one of the previous equations. So you got to essentially solve it for it and show it how you would ideally solve it. And then maybe provide like a couple of examples of this. And then you can hope for it to follow the same approach. And 8.33 multiplied by whatever. So x is 8.33. So what would be y? Y is equal to 10 minus 8.33. So y is equal to 1.67. Final answer. I just went the longer route just to add a few more so just to kind of add some content here, because I ended up picking slightly simpler examples, which is why. Yeah, and you can ask it to follow the same approach. And I don't know if this makes sense. So this is what it did. This is why it messes it up. Because I asked it to add in step 2, I asked it to add both the equations, because the first one it did an okay job, right? Multiplied by 3 to get a common multiple for one of the variables. Did it get a common multiple here? Well, unfortunately, no. So it messed it up. So it messed it up here. So clearly, this one example didn't really help it. And second, it ended up adding both of them. And I don't know how it ended up with just 25x, because it did get 25x here. But then it completely missed out the 10y from this, because it just assumed that this 10y here will simply get subtracted. So which is why the other thing that you have to bear in mind is you have to be very explicit why you did what you did here. I have a common multiple for y. Now look at this. Now I just changed one letter here, common multiple for y, because that made it a lot more easier for it. Equation 1, 9x plus 15y is 690, 10x minus 15y is 550. It's subtracted to do 19x is equal to 1250, x is 65.26. Substituting that back here, y is 6.84. So spot on. It got the answers right now. Make sense? And it exactly followed the same structure as to how I wanted it to work. You follow the same exact structure. But remember, this should be few shot. I just gave it one example here. This should ideally be like 5 to 10 examples. You can provide 5 to 10 examples here, and that would typically help the quality of the responses. That would typically improve the quality of the response. Okay. All right, let's keep going. Now I'm going to talk about one more prompting technique. Another popular prompting technique called as React. Another prompting technique, React, which is essentially a short for reason and action. So the React template or the React design pattern is again a very, very, very effective one. It's actually more effective than a chain of thought one, where you are asking the model itself to reason at every step. Instead of just breaking the problem down into multiple steps, you're asking why it needs to do a few things, right? For example, let me actually pull up the paper that published this. There was actually a paper that was published on React. I'm trying to see if I can bring it up for you. So this is the paper that was published. This was a paper that was published in March 2023. So last year, again, Google, for some folks from Google had published this. Very interesting, where they talk about synergizing reasoning and acting in language models. So they talk about how language models have demonstrated impressive performance across tasks in language understanding, and interactive decision making, their abilities for reasoning, chain of thought prompting, which is what we saw, and acting. There's something called as action plan, which we can also. wherein it actually generates like a complete plan of action, and then, or it's also referred to as plan and execute, which is like the other kind of approach. There is chain of thought and there is plan and execute. Plan and execute is like when you ask it a question, it completely generates the complete plan and then executes it, which is also another way to prompt your LLMs to operate, right? In this paper, we explore the use of LLMs to generate both reasoning traces and task-specific actions. So this is a very, very good example of what we mean by React. So if you look at this, let's actually go to the query itself. The question is, aside from Apple Remote, what other device can control the program Apple Remote was originally designed to interact with? Right? Aside from Apple Remote, what other device can control the program Apple Remote was originally designed to interact with? So it's saying, okay, what other remotes can we use? Can control the program. Apple Remote was originally designed to act, so like for example, Apple Remote was designed to act to probably design a few, to control a few things. The question is, what other remotes can be used to control the same thing? So I need to search Apple Remote and find the program it was originally designed to interact with. That's the first thought. The action is search. So it's going to search for everything about Apple Remote. The observation is the Apple Remote is a remote control introduced in October 2005. So it's basically got a lot of information about the Apple Remote. Then Apple Remote was originally designed to control, and I need to search, and it again tried to get more information about the same thing. Front row media center program, originally designed to control the front row media center program. But it couldn't find the front row media center program. And then it says front row is not found. I need to search front row software. So it went about again doing the same thing. So front row software is controlled by Apple Remote or keyboard function. So the answer is keyboard function keys. So the answer is keyboard function keys. So Apple Remote can also control keyboard function keys. That's how it went about answering this particular question. So it went one after the other, right? So it is essentially trying to ask itself what are all the different sub questions that you will have to ask. So here's another example. You are in the middle of a room, looking quickly around. You can see a cabinet, a cabinet 6, a cabinet 1, a coffee machine, a countertop, a stove burner, and a toaster. Your task is put some pepper shaker on a drawer. Your task is to put some pepper shaker on a drawer. It's kind of a very weird question to start with. Think. First, I need to find a pepper shaker. So it's trying to find like where the pepper shaker is likely to appear in cabinets 1 to 6. Countertops 1 to 3. So go to cabinet 1. On the cabinet 1, you see a vase 2. Then it's going one after the other, as you can see here. So action, observation, action, observation, action, observation, action, observation, and finally you put the pepper shaker on the drawer 1. So what you ended up doing is to be able to get to the final response, you have performed multiple actions, and at the end of every action, you again had to reason. Okay, is this the right step or not? Okay, seems like it's the right step. So then let me go back. Let me redo this again. And you continuously do this time and time and time again until you get to a final response. It's a very, very, very effective approach to get to specific kind of responses. And it's very good when you're dealing with it is extremely time taking. Absolutely, yes, and that's exactly what you see here. Chain of thought is fast, but React can be a lot more time taking. They've benchmarked this against multiple models, but the quality of the responses that you get and the quality of the outputs that you get is insanely high with this, right? So correct reasoning. So if you see, look at the quality of the responses. True positives, 94%. False positives. In a chain of thought, your false positives are 14%. Hallucinated reasoning, essentially. Your chain of thought tends to hallucinate a little more than the others. So, but when you do it through React, it tends to hallucinate much lesser. Reasoning error. In the case of chain of thought, it is this is by the way failures. In the case of React, the reasoning errors are much higher. That's also because you're going to be doing multiple steps one after the other, which is why the number of reasoning steps that would fail will be much higher in the case of React. Hallucination, of course, is almost 0%. Label ambiguity and stuff like that. So there are some other aspects which are being tracked over here. You can read through the paper. I'm not going to go into this into much more detail, but the idea here is to be able to take any piece of question and break that particular question down into three aspects: action, observation, and the thought, action, and observation, right? And let's actually, with that, right, let me actually go back to the OneNote and let me quickly show you some examples of this. So I'm going to show this to you through actually the agents examples. Okay. I'm going to show this to you through the whole idea of agents. I need to also introduce the idea of an agent to you, by the way, before we go that far. But basically, I'll introduce the idea of an agent before I go that far, because it's hard for me to explain that without explaining what an agent is. In a lot of ways, what your React is trying to do is sort of act like an agent. So let me actually go back in here itself. Let me first quickly touch upon what an agent is, and then we can go back to this. Okay. So what is an agent? So what we just saw with React is essentially like an agent, right? This is React. If you think of it, reason and action. There are three steps when you talk about React. This is step 1, this is step 2, and this is step 3. Right? Step 1 is action, step 2 is observe, step 3 thought, and then go back. And then keep repeating this. Go one after the other until you get to the final response. Right? So this is like a very, very good example of how you could go about, improving the quality of your response one after the other. Now, the thing about these agents is that these agents by themselves at times are not capable enough. These agents, right, they require some tools. What kind of tools are we talking about? For example, these agents will require access to internet, will require ability to execute some code, will probably require querying a database, will probably require looking at, so some of the more advanced agents might also require access to your camera to click a photograph, right? They might need access to a camera to click a photograph. They might need access to your mic to listen to what's happening out there, right? So these agents can now start leveraging all of the tools that are around them to gather more and more context. And then with the ability of React, you could then start going back and forth, right? You could get more information because now you're not solving the problem in one go. You're not just looking at context as a complete blob. You're answering one part of the question, then going back, observing what has happened, then coming back, gathering more information, then answering it again, then gathering more information, answering it again, and so on and so forth. So as a part of it, having access to a suite of tools will always be very, very helpful. For example, what are these tools? As I said, internet is a tool, right? So imagine you have access to Wikipedia. Imagine you have access to, imagine your code has access to, let's say, executing something on your Python shell, right? So let's say it has access to shell or REPL, Python REPL interpreter, right? Or it has access to, let's say, querying against a database. It has a SQL tool, SQL tool, where it can actually query this information against a SQL database, fetch the information, and then run it. So these kinds of tools can be game changing, right? So these agents, when they're performing a specific action, they have access to all of these tools, and these tools and agents put together, they then start making better decision making. They then start improving the quality of a response. Let me show you what I mean by this through an example. Okay. Let's start with a very, very simple example of a tool, right? So we can get to the advanced one a little later. But let me start with a very, very simple example. So here's the thing. I'll ask you a question. Do you think these LLMs have access to everything on my system right now. These LLMs right now, do they have access to everything on my system? They don't. Now what I'm going to do is I'm going to try and provide them access to getting access to some time, running some piece of code. I'm going to give them some of those capabilities, right? So I'm going to give it a tool that can execute some piece of code on my Python machine and then get a response. Let me show you what I mean by it. So this is regular straightforward stuff. So if you see, LangChain has something called as create React agent. So this React agent, as you can see, this tool is create an agent that uses React prompting. I'll show you exactly how the prompt looks like in a minute. So what I'm doing is I'm creating a simple Python function over here called get current time. Very simple tool. It's a function, right? This tool is currently local, but you can imagine this tool sort of being a remote function as well. It can be an API as well, right? The way you should think of tools is as APIs, is access to APIs. It can be access to interfaces, whatever those interfaces are. An interface can be a web interface, an interface can be a physical hardware interface through a camera or something. It is the ability to invoke a small capability. It is the ability to invoke a remote functionality somewhere that is outside of this ecosystem. That's essentially what you would mean by a tool here. So this one is a very, very simple tool, which returns the current time, right? I'm saying get current time, and I'm saying pass any arguments. This does not basically require any argument. Ideally, you don't need to pass any argument to it. And inside this, all that I'm doing is I'm importing date time, and I'm saying datetime.datetime.now, and I'm returning the time. So if you actually take this piece of code, and if you simply run it, it simply says 9:15 p.m. That's what it would say, right? This is hours, minutes, and AM, PM. That's essentially what it is going to say. 9:15 p.m. It is essentially, this is running on my current system. It is accessing my current operating system, and it is returning the response. So this is executing Python code on my subsystem right now. Now let's go back here. So what I've done is, this is the tool that I've defined, and I'm registering this as a Python tool, or sorry, a LangChain tool, right? I'm naming it something called as time, and I'm saying the function is this function. Get current time is the name of the function that it will have to execute. And what is this description for? What is it supposed to do? So I'm giving it some example over here. Useful when you need to know the current time. Whenever you need to know the current time, you can basically run this piece of code. Is all that we are saying. This, you can use this tool when you need it for current time, right? Similarly, I can also I'm creating another simple function here. Now, this is, you can consider this as another tool. Every function can sort of become another tool, right? And I can register this as another tool. This is tool one, another tool. I'm going to call this as path. The name of the tool is path. And I'm going to say get current path. Description. This description is very important. Useful for when you need to know the path for the current working directory. And that's another tool. Now, Is this clear so far? Do you understand how these tools are? So this is a tool. Similarly, you can imagine, you can create functions over here that are interacting with Wikipedia, that is interacting with a camera, that is interacting with, let's say, a mic, that is capturing some information and gathering information. Tools are simply capabilities or small functions, utilities that can gather more information for you, right? They can connect to an API, they can get you some current status, current information, they can be anything, right? Weather is a good example, right? You need to know what the weather is, but I don't have a weather. Agent is the controller. Exactly. Agent will decide how to use all of these tools and then decide how to, how to orchestrate, use these tools and then answer larger questions. So now these tools are here. Now let's actually look at the prompt. So the beautiful part about this is this React reason and action. There's a very popular prompt template that's already available for people to use. So this man, right? His name is Harrison Chase. He's the guy who's written uh, who has written LangChain. He actually runs LangChain himself. So the question. So this is essentially a prompt template to have to invoke a React agent. To invoke a React prompting methodology, you essentially will have to write a prompt that looks like this. The input question you must answer. You should always think about what to do. The action to take. Action is simply nothing but. So the question is nothing but the input question that you need to answer. The action is simply nothing but so it's saying answer the following questions as best as you can. You have access to the following tools. So you'll pass the list of tools. Use the following format. Question. The input question you must answer. Thought. You should always think about what to do. Action. The action to take should be one of these tool names. Action input. The input to the action. Observation. The result of the action. Then the thought. Right? This thought, action, input, observation can repeat n number of times. How many ever times? This thing can repeat multiple times. Thought. I now know the final answer. And then the final answer to the original input question. So if you see here, you're essentially running this multiple times, n times. I now know the final answer, and then you get the final answer to the question itself. And then the question, the thought, and the response. So I just executed, prompt is equal to hub.pull. You can essentially get this complete prompt for you to use. Does this make sense? Because I'm using LangChain, but if you want to use something else, feel free to use it. That's totally fine as well. Chat model, GPT-4o, and then this is the agent. So far, I've defined the tools. I have the prompt, but I need an agent that can run all of this, right? So here's the agent. So the LLM, tools, prompt, and I just have to execute this. So if you observe, I've defined all of this. Okay, all of this is defined. So I've passed the agent and the tools that it has access to, and I'm saying run. So now if I simply ask this question, what time is it now? And look what it is saying. I need to find the current time. Action. So this is the question. I need to find the current time. And then action is time. Action input is, so it got the input. I now know the final answer. Final answer, the current time is 9:22 p.m. Finish chain. Let's return the final response for me. Right? So for example, if you say, how many directories are there? So look at this question. How many directories do I need to hop from my C drive to get to the current path? Okay, let's go. Let's ask this question. Look what it has done. Action is path. it has now decided to use the path tool to answer this question by itself. To determine how many directories you need to jump to, I need to know the current working directory. So the action. So it got the current working directory. This is the current working directory. To the current path, I need to count the number of directories in the path. So the path can be broken down as follows: users, funny, OneDrive, trainings, IP training, AI, AP, TensorFlow, NLP, RAG. There are 8 directories to hop from C drive to reach the current path. Final answer, you need to hop to 8 directories from C drive to the current path. And then it has returned the final response for me over here. Does this make sense? Do you understand how it's leveraging? So it has decided to use this all by itself. Now my question is, if it does not have access to this particular tool, do you think it would have been able to answer this question? Of course not. It doesn't. All right, let's look at another example. Now this time, take a simple example. Okay, let's take a slightly simpler one, but this time I'm actually going to show you like another tool, which is I'll show you how to access a Wikipedia tool. Remember in the previous example, we tried to copy paste like a Wikipedia page ourselves. We used Beautiful Scoop to scrape it. Now I'll show you something more interesting. So let's go. So let's take a look at this. So now you have access to this. So I'm doing the same thing again. Okay. Are you aware of how to deploy, forget about large language models and all, like regular ML models? Do you know how ML model deployment works? Okay. So step number 1 is to understand how that works. So the way to make that work is there's a whole concept there. There are multiple ways of deploying it. You could deploy it on your personal machine. You can deploy it on a on-premise server. You can deploy it on cloud. You can deploy it on the edge. There are multiple ways. You can deploy it on phone. You can deploy it in multiple places. There is absolutely no limitation around how you could deploy a machine learning model. That space has been beaten to death, meaning there are some very, very good architectures on how you could deploy the most complex or the complex ML models. To your point, even on rockets if required, because a lot of the intelligence is determined by a lot of these intelligent systems that are embedded into the into the rockets as well, right? So not when I say rockets, I'm using the term very loosely, but the point is these any sort of a space mission, if you think of, they all have very, very intelligent systems. A lot of decision making happens by themselves. So short answer to your question is ML model deployment can happen at multiple levels. One of the most simplest ways to deploy a machine learning model is there are 2 steps in the process. There's the training step, and then there is the inferencing step. What do you mean by the 2? Training is the process part of the model building, right? So this is model building. You are all aware of, you can do model building in batch, right? And then you have inferencing, which is nothing but to be able to generate predictions from that particular model. Generally, you need help with this step, not this. Training can be done on local machines. Training can be done on large, high performing computing machines. Training is not the problem more often than not, because training is sort of a batch exercise. Inferencing is the step where you need more support. Inferencing is where you would require more help, because inferencing is simply nothing but generating prediction. A good example for that is, imagine there is a website, right? This is a banking website, right? There is a user that has come to this particular banking website. Now this website, and this is, let's say, on the internet, the person is trying to communicate through the internet through everyone. So this is, let's say, a web page for that matter. Now this person is trying to apply for a loan, right? This person is applying for a loan or inquiring about a loan. Now the thing is, the beautiful part is, a lot of these banks these days have, real-time loan approval systems, real-time eligibility approval systems. What are they? They are ML models behind the scenes. All that they do is, the moment when somebody comes in, they put in all of their details, right? So they put in all of the details, the age of the person, the location of the person, the the occupation of that particular person, salary of the person, so on and so forth. And then you have all of this information, and then you also put your Aadhaar or something, or your PAN number, right? You put your PAN number or something, most probably PAN. And then what happens is the moment you add all of that information onto the website, this website makes a call to a remote server. Now I'm using the word server very loosely here. This is a remote server. You're going to make an API call to this remote server with this details, right? And within this server, your machine learning model is sort of running in like a Python environment over here. So there's a Python environment that's created in this remote server. And inside this Python environment, there is a ML model that is waiting to generate predictions. So all that you have to do is you're expected to basically send all of these details into this ML model, right? And this ML model would generate a response. So you would have done this on your Python machine, right? So you would have done model.predict. So this is basically the same thing. This is also the same thing, model.predict, but that model.predict is wrapped under a web service. So you essentially build an API layer around it, right? And you can use some tools like Django, Flask, or Fast API. There are many frameworks that are available for you to build these web interfaces around it. Now, once you build that web interface, once you pass this information through an API, the ML model takes this information, generates the prediction, and then sends the response back. It sends probability of, let's say, default of this particular person is 0.8. There is an 80% chance that this person will fail to pay back. The moment that comes back, this website over here or the back end of this particular website will take look at this probability score, and it will say, this probability is very high. It will execute some kind of a business logic, and it will say this probability is very high, so we are not going to process a loan for this particular person. We will come back and say, we are very sorry, you are not eligible for your loan given all of these information that you have passed. Now, this, my friend, this whole aspect of taking an ML model, hosting it on, wrapping it under Flask and then hosting it on a server is all referred to as ML ops. So it's important that you learn ML ops, which will teach you how to deploy a particular model on a particular machine. And by the way, this is a real-time call. In most cases, you probably don't need a real-time call. You just need a batch execution, right? For example, a lot of the information that you see here for existing people might already be available. So you don't need any kind of a real-time model. You just probably will require a batch model, meaning a model that generates predictions once every day, once every 10 days, once every 15 days. So in that case, you don't need any of such kind of a complex setup. All that you need is you need your Jupyter notebook to be scheduled, right? Your Jupyter IPYNB, your IPython notebook .IPYNB. This simply will have to be scheduled to run once every 20 days, once every 15 days, whatever. That is essentially like another way to deploy. So batch deployment versus real-time deployment. Yeah, so for example, a good example of a batch deployment is churn predictions, right? Likelihood that you will quit. So imagine you're working for a telecom company, and basis your current behavior, we would want to evaluate how likely are you to churn. Churn meaning how likely are you to discontinue the services of, let's say, using Airtel, or discontinue services of using Jio. Right? When you look at the typical behavior of a particular person, you can evaluate how likely is this person to churn. Now, this likelihood of churn, imagine if I know that a person is likely to quit, likely to discontinue my services. If I am a Geo, customer service representative, what I would probably do is at the beginning of every day, I get a list of people whose score is very high, then basis that, I'm going to reach out to them and I'm going to specifically make a call and say, sir, you have been one of our very, very good customers. Hence, we have an offer for you. We are providing you with, I don't know, we are slashing down your monthly rentals from 300 rupees to 200 rupees, or whatever, right? So we will bump you up from 4G to 5G for free, for the next 5 days. For the next 5 months, you don't have to pay a penny, or we will give you a Geo subscription for the rest of the year for free, something like that. So the point is, there will be some kind of an intervention that will be planned, you know, to there will be some kind of an intervention that will be planned over here, basis the fact that basis your churn score. It's called as a churn score, or a risk score. Now, this doesn't have to be a real-time exercise. At the end of every day, I will collect all of the activities that you have done as a customer, right? I will take that information, I'll pass it into my ML model and generate predictions for all the customers at once. I don't need to do it one by one. I can do it for everybody together at once, right? That, and that can happen at midnight, once every at 12 o'clock in the morning, 2 a.m. in the morning, so that by the time this customer service representative logs in, then this would simply get updated. So for that to happen, all that I need to do is my ML model will have to generate predictions once a day. Now, how can I do that? All that I need to do is I need to essentially take my Jupyter notebook, right, or my Python file, and then I simply will have to schedule the execution of this particular file once every 1 day. And that is essentially how you do it, and that is a very simple. You don't do it on local systems, you do it again on remote server, but you just schedule it. You never do anything on local systems. In enterprise grades, in enterprise setups, you never run anything on your personal machine. Okay. Again, all of this, my friends, is a part of ML ops. All of this is machine learning ops. Okay. Right. So let's build on top of the understanding of of agents. Right. I think we looked at a couple of examples earlier on agents. Basically, like you are using tools which are like more local, but this time I'm going to show you some more interesting tools that are available. Right. I'm going to show you, as I said, right. I just want to show you the the Wikipedia tool and how you can access the Wikipedia tools. So the good part about LangChain is LangChain comes also. So while you can create your own tools, LangChain also comes with some inbuilt tools, right? So I'm going to show you how you can access one of those inbuilt tools right now, right? Which is the Wikipedia tool. We'll also try using some other tools as well as we go along, but let's try. Let's go one at a time. So here you go. So .env, of course, this is essentially there's the simple loads. And let's say I ask a simple question. Hey, user will input. So this is, let's say I'm going to ask it about T20 Cricket World Cup. And I ask it a question. I say, who will win? User will input a year and you will need to get the T20 World Cup details. And I say 2024. But there's no T20 World Cup scheduled for the year 2024, which I think is nonsensical, makes no sense. The next T20 World Cup is scheduled to be held in 2022 in Australia, which is again ridiculous. I don't know why that's the case. TP 3.5, which makes sense because it was trained only until, if I'm not wrong, until like 2021 September or something. But anyway, this is ridiculous, as you can imagine. But now let's build on top of it. Let's use React. And let's also use the Wikipedia wrapper, right? So let's give it more context here. It's the same thing, but this time I'm going to use tools and I'm going to use the React agent. So I'm going to use two things. The React prompting, I'm going to use both of them put together, and then we'll try and solve the same problem. So I'm using the same prompt that I had shown you all earlier. The React prompt. So if you look at the prompt, it's the same thing as I had shown you earlier, which is answer the following questions as the best as you can. You have access to all the following tools. We'll pass the list of tools that it has access to. Use the following format. Blah blah blah. Now, what else am I going to do? So I'm going to define the API wrapper here, the Wikipedia API wrapper. So I'm saying extract the top 5 results. By the way, just to let you know, right? If you just use the API wrapper, and I think run, and you can pass any details. Olympics 2024, and it can actually return like all the articles from Wikipedia right now that match these keywords. So it actually queries against it specifically from Wikipedia, and it'll return the top 5 results for you from that. See, 2024 Summer Olympics. But you remember this, right? This is what we did earlier. What did we do? We manually queried this information. We copy pasted it, if you remember, right? Instead, you could just use this to query it. That's one of the most beautiful things about the Wikipedia API wrapper. The beautiful things about open source. Wikipedia is open source, so the API is open source. You and I can query against it, then you can kind of get that information for you. So that yeah, so that's how you can query, and you can execute it. You can also actually see this here. Bring this up, new window. I hope you can see my screen. Okay, perfect. Wikipedia API. And if you actually look at the Wikipedia API, this is the main page to access the API. And here's how you can access all of the APIs, the English Wikipedia API. You can go to this page and you can see how to access all of it and everything. But the beauty is all of that is nicely wrapped into this tool over here for you. You don't need to worry about anything. It's nicely abstracted. LangChain has done a fantastic job of abstracting that for you. So now all that I need to do is I simply have to say, hey, look, agent, and there's only one tool that I have provided it for access right now. But if you want, you can provide as many tools as you want, like what we did in the previous example. Here, it has only access to one tool, but you can provide other tools as well if you wish to. Same LLM tools and prompts. The LLM is the 3.5 turbo, if I'm not wrong, the GPT 3.5 turbo. The prompt is the prompt from the previous step. The tool is a Wikipedia tool. So I'm creating the agent executor, and then I'm simply going to say agent.invoke. Who won the 2024 ICC Men's T20 World Cup? Now, if I ask it this question, look what it does. I should search for the winner of IC 2024 ICC Men's T20 World Cup. Okay. Action Wikipedia. So it's using the tool here. Action input is 2024 ICC Men's T20 World Cup, and it got these 5 pages as output. Right. So it has summarized each of these pages for you. 2024, 2026, 2024, 2025 ICC Men's T20 World Cup, Asia Qualifier, 26 Men's T20 World Cup. It has looked at all of it, and it has responded back saying India won the 2024 ICC Men's T20 World Cup by defeating South Africa in the final. Do you think the LLM would have had access to this information otherwise? No. The LLM has not been trained on it. The LLM would have required access to Wikipedia. But then I would have had to put the information from Wikipedia myself. Or I would have had to extract all of it, put it in a RAG, and then run it. The beauty with this is because that interface has been exposed as a nice API for me, I was able to nicely weave that into this complete agent structure. So I didn't have to build a RAG to solve this problem. It did solve it in some sense because all that it did is kind of pulled up this information and it tried to summarize it. So in a way, if you think of it, it is RAG, but it is not actually RAG because it is querying against a API in this particular case. Does this make sense, everyone? Do you understand how this is sort of a slightly different design than that of your RAG? Now let's take it one step further. So there's Olympics going on right now. And of course, you'd want access to internet. So now let's look if there are tools that are available out there that provide you access to the internet, right? Imagine if there was like a Google API that was available, a Google tool that was available. The good thing is it is actually available. Let me show that to you. Let me pull this up. Let's go. Okay, let's go. Let's take a look at this. And this is all LangChain. I'm sure there are tools in Llama Index as well. I haven't personally explored Llama Index myself. I did very, very long ago, but I haven't really spent a lot of time on it. But let's take a look at this. Tools. There are built-in tools. So these are all the different tools that are currently available. So Alpha, Vantage, I think this is for, if I'm not wrong, for financial information. There you go. This is all for financial information, real-time financial information. So you can actually use this if you wish to. Some of them will require keys. Some of them are free. For example, you can use a Dolly image generator. You will need a key for that. DuckDuckGo search. You can access Google Drive, Google Jobs, Google Lens, of course, Google Search. But for Google Search, you need API and you need basic keys, right? So you need to set these keys. I don't have access to it, but there is this one which is free. DuckDuckGo search is free. This is anybody can access it, right? So let's try this. Let's actually try this. Let's look for if there's a YouTube. If it's not there, you'll probably have to write it yourself. There you go. There's a YouTube video access as well. YouTube's there as well. There's Yahoo Finance. Yeah, there's a bunch of these guys. So again, let's go back here, right? So let's take one example, right? Let's go with DuckDuckGo search. Now this is like a simple search. The reason I'm going with this is because this is search, this is internet, and then yeah, is out here currently. Oh, sorry. Okay, let's go to the latest one. LangChain tools. Simple, built-in tools. I don't know why this is so hard, but anyways. Anyway, doesn't matter. So let's try this. Let's go DuckDuckGo. So I'm just going to try this out quickly. And what we're going to do is we're going to try and bake that into this, right? So we're going to create the same tool. I actually tried it, by the way. I don't know if it worked, but let's try. So same thing. So I have a Wikipedia tool here, but now I'm going to add one more tool, which is internet. Okay. Useful for accessing live information from the internet. Okay. And this is going to be, yeah, actually, I don't need to mention all of that. I just have to mention the name of the tool. That's it. From LangChain and dot tools import DuckDuckGo search results. I would assume that's the one. Let me just verify here. Search run. See, search run. And well, actually no, it's the search results only that I want. Okay, search results. And search is equal to DuckDuckGo search results. I'm just gonna go here and I don't need to mention any of this. I hope that works. Let me just go back here. Query run. Let's try. There you go. This is how I'll have to embed it. A wrapper, DuckDuckGo search API wrapper. From LangChain dot to dot which is okay. Okay, DuckDuckGo search API wrapper. And then all that I'm going to do is I'm going to define the wrapper. Like how, so it's basically the same way as how we've defined this. Right, so I'm going to define the same thing. I'm just going to remove this. And I'm going to remove this. Sorry for the back and forth, everyone, but API wrapper. But this time, the only difference is this has to be the DuckDuckGo API wrapper. I'm going to remove all of this just for simplicity. And I'm going to go API wrapper is equal to API wrapper. And where is the run? DuckDuckGo search run. All right. I think that should do the trick. Okay, so I have a get time tool, which I don't know if it's useful, but anyways, I have the search Wikipedia tool, which is the Wikipedia one. By the way, I can actually define that as a Wikipedia one only. I don't know. Yeah, but doesn't matter. Then I have the DuckDuckGo DDG API wrapper, DuckDuckGo API wrapper. And I actually don't need this either. I can replace this with the Wikipedia wrapper as well. This to me honestly makes no sense. This is not required. I can define the Wikipedia wrapper here, just the way we had done this earlier. This is the Wikipedia wrapper. Okay, perfect. And then I have, cool. So I'm just going to get rid of this. And this is simply going to be Wikipedia API wrapper. There you go. Those are the three tools that I have. There's one custom tool, there's one Wikipedia tool, and then there's one DuckDuckGo search tool that I have over here. So we're all set. And this is sort of a chat agent that we have here using the GPT-4o model. The only difference between the previous one and the current one, honestly, is that this is more like a, we're kind of again building on top of it, right? So here we just were executing one question at a time. But imagine if you were to chat, if you want to like really chat, right? If you want to build an actual chatbot per se, then what you need is you need a memory buffer, right? So you need a conversation buffer which will help you sort of have the complete list of questions that have been asked so far queued up, right? So you need some kind of a mechanism where you have all the questions nicely in that conversation queued up. So why is that important? Because then you can ask follow-up questions, right? For example, if you say, what has happened in Olympics? And you get a response and you say, no, in 2024. So when you say no in 2024, you would want the Olympics 2024 to sort of be carried forward. Instead of simply saying no 2024, you say 2024, but with the context that you had previously. So Olympics and 2024 together. So which is why you have the conversation buffer memory. All that it does is basically creates a chat history and it stores messages around in that. That's it. So create structured chat agent, LLM tools, prompt. The only additional thing that I'm passing here is this memory object that you see here, just to maintain memory. Everything else is the same. You're an AI assistant that can provide helpful answers, and you have available tools. Right? And then, cool, let's go. Let's ask a question. Let's see how that goes. So now you can actually ask a question here. Where is 2024 Olympics happening? And when I ask a question, Wikipedia, 2024 Summer Olympics. I'm hoping it fetches the right results from Wikipedia. There you go. Fetch something. The 2024 Summer Olympics will take place in Paris, France from 24 July to 11th August 2024. Fantastic. Cool, right? So it's fetched it from Wikipedia here. Now, let me ask you a question. What is the current medal tally? Now I'm asking it another question. It's gone to DuckDuckGo. And underway after competition early Saturday morning has not started yet. Looks like it's screwed up. Medal tally available games are scheduled to take place 24 July. It looks like it's screwed up. Get me the leader on the medal tally currently. This is for 2024. Look what I'm doing here. I'm conversing here now. Some 346 medal events were held across. Who is the leader on the medal tally? So now, because of the memory buffer that I have, I'm actually able to chat right now. Yeah, looks like it's unable to fetch that information from DuckDuckGo for some reason. Okay, let's ask. What is the Indian media talking about Olympics 2024? Indian media is currently reporting on the 2024 Paris Olympics, highlighting that Manu Bakar made history by winning a bronze medal in the women's 10-meter air pistol event, which is India's first medal at the Paris Games. This is fantastic because it kind of found that I queried it differently, but I was able to still fetch it. Now it's actually querying it live against the DuckDuckGo search engine, fetch that response, summarized it for you, and return the results. Additionally, other Indian athletes like Ramita Jindal and Arjun Babuta have reached the finals. Oh wow, that's crazy. Fantastic. We can ask. This. We can ask this. Tennis star Rohan Bopana is the oldest athlete, while swimmer, I guess, wow, 14. That's crazy. Are participating in which events in Olympics 2024? DuckDuckGo search. Let's see what it's doing. It's still going back and forth. You see this here? It's still going sort of back and forth here, trying to find the actual response. I think it's unable to. It's got it actually. These are final the respective. No, this is not true actually. This is incorrect. So it's still going back and forth. This is still not the final response, as you can imagine. It's still trying. It's still trying very hard to find the right response. It's going in that circles back and forth. Yeah, it couldn't find the answer for some reason. But we can check. What event is Ramita Jindal participating in? There you go. That's not true. That's not true. That is not true. Ramita Jindal is not in 10-meter air rifle. Oh, is it? Is she in air rifle? I don't think so though, but we can verify. Oh, no, she is. 10-meter air rifle. That's actually correct. Not bad. Still fetched it. So it actually did have the right answer. 10-meter air rifle. So cool. You get the idea? Do you guys understand how this is sort of evolved one step after the other? We did simply prompts with stock information. We went to RAG, then we went to agents with tools, then we went to agents with tools that have access to the internet. So then we went to agents with tools that have access to the internet and have a memory sort of baked into them. So now you're actually simply chatting in this case. And I'll just hit an escape. So it'll stop most likely. Okay, clear? Okay. So there are multiple ways of going about it. So you can basically use the same exact piece of code to do it. But let me firstly draw like a high level view of how this works. Okay. So let's start with, so when you want to build like an agent, right, or an assistant. Let's use the word assistant, right? So whenever you wish to build like an AI assistant or a co-pilot, so to say, these are all co-pilots or assistants, by the way. But anyway, what are the things that you need to do? So I'm going to talk about the core AI workflow, okay, and then we can talk about the engineering and everything associated with it later on. But the core AI workflow, what are the steps that are required? Now, the first thing first, there are multiple components associated with this. One is the um, the model that you wish to that you have access to. Second is the prompt or the prompt. I'm going to use prompt or prompt template or design that you're following, right? So the third thing that you would need to have access to is a bunch of tools that you need access to. And then the fourth one is access to an agent. And if you wanted to have, you want to have it like a chat interface. If you want a chat interface, then you need to have a conversation buffer, basically like a memory, so to say, right? So, or a memory, simply put, memory. That's it. So these are the 5 high level things that you would need access to. How do you go about it? So step 1, you of course define the model or the LLM, right? So that you would need that you would want to chat, that you would want to query against. Now, typically a 3.5, a GPT 3.5 generally does a good job. If you have access to 4.0, use the 4.0 as well. That's fine. If you wish to have any of the other models, then you can access them as well. I have shown you examples through GPTs, but if you wish to try some of the others, feel free to do so. LangChain will help you access all of those models very, very easily, right? So in this case, there is a GPT 4.0 or a 3.5 turbo is what we have tried. You could use others as well. Prompt template, generally for more complex ones, a React template works very, very well for complex flows. This is generally like the most preferred one right now. There are other approaches as well around the agentic architecture. So like, for example, there is something called LangChain has recently launched something called as LangGraph. Just the way you have React, you also have something called as tree of thoughts, which is also a very, very fun exercise, right? So it basically takes a particular question, breaks that particular question down into 5 possible, or it takes 5 different paths or n different paths to solve that particular problem. Path 1, path 2, path 3. And it tries to answer that particular question through each of these. If any of them, it faces a dead end, it simply kills it. It carries on with the others. So it's like a different way of solving the same problem. It's like almost like having 5 people solve the same problem, right? Instead of breaking the same question down into multiple things where one person is sort of breaking it down, here it's more like get 5 people to solve the same problem and see what works the best kind of an approach. So it's tree of thought. So you essentially have like multiple ways to break it down. So you have chain of thought, tree of thought, React. These are all different approaches. React is generally for more complex flows. Tree of thought is something that's coming up right now as well. Tools. Now, you can create custom tools or you can create built-in tools. You can use built-in tools, right? Both are possible. I think we discussed both. So for the built-in tools, you may need, for some of them, you might need to have access to their API keys. Some are free to use. For example, Wikipedia, DuckDuckGo, they are free to use. Some of the more complex ones, like some of the more expensive ones, are Google search, right? Bing. They are all expensive. They are, meaning they all require specific API keys and they are paid. So you'll have to procure their keys before you can do it. Now, tools are very, very important, because for your agent to work, as we discussed here, right? So for your agent to really do a good job, the more tools it has access to, the more versatile it can become, right? The more versatile it can become, the better decision making it can come up with, right? So that becomes super, super important. The next one here is the agent itself, right? Agent is simply nothing but a orchestrator. There is nothing specifically about the agent by itself. The agent is simply like using this prompt template and executing this piece of information multiple times. That's it. So if you actually look at the React agent, and if you look at the code for the React agent, let's actually go there, right? Where is it? The React. So if you look at the create React agent, function, this is the simple function that's available. It's an agent that uses React prompting. Close this. And if you look at the function itself, it's actually super simple. That's it. This is the only piece of code that it has. So all that it does is it takes it's basically like a for loop, more like, so this is like check if stop sequence, stop, don't do anything. Else all that it does is it basically takes the question that you have asked, sends it to the prompt, and generates the response. That's it. It's very simple. It's just a simple LLM call. That's what it is. And it uses a very specific, template here. As you can imagine, here's an example. Here's the prompt, examples, stuff like that. So this is, by the way, from LangChain. So this is, by the way, how you can access it as well. So this is the prompt. This is how you can write the prompt. This is the prompt that we're anyways using. So it's super, super simple. So the agent per se is just basically making a call. The agent itself is not doing anything here. It's the prompt that's the magic. It's the tools that do the magic, nothing else. Okay. And last but not the least is this memory. Now, this is sort of an optional thing, right? If you are okay to just have, like, I mean, if you don't want, if you're building it for your personal use, you don't need like a chat bot, the chat sort of interface. So you can just still live with this kind of a flow. It'll still get you the response like this. But if you really want like a chat flow, you want to go back and forth, you want to try, keep chatting and everything, then in that case, you can really, build something like this. You want to do a bit of back and forth sort of exercise, you can do this. It's just adding a few more additional lines of code. That's it. So broadly, these are the things, guys. This is what you need to do. Now, specifically for math, there is an important thing that you need to keep in mind. Now, math is, there are some very specialized, there are some tools that are available. There are also some specialized chains that are there as well. So what do I mean by that? Let me show this to you. So there is something called as an LLM math chain that is available, which is sort of a bit of an older implementation, but it works. The LLM math chain is basically about, is to be able to, it essentially creates Python code to run math, right? So it interprets a prompt and executes Python code to do math. So you could sort of use this kind of a chain instead, right? You can sort of use this sort of a chain for performing anything very, very specifically on the math side of things. Right? It's actually pretty cool as well. Now these days they've actually upgraded the LangChain as well. If you actually go here, LLM, yeah. So if you see LangChain.chain, import LLM math chains. So you can either, if you're doing it through React, you generally don't need to do this. But otherwise, if you specifically want to do something for React, then essentially you can create a tool that uses this chain. So what you can do is you can actually create a function over here, a specific tool that uses that particular chain to execute some of the math related stuff. Right. So for example, what is 13 raised to 0.3432? It would execute that for you, 2.411. But under the hood, what it's doing is it is actually executing this piece of Python code. So it is doing, Python translation, code to Python translation is what's happening here under the hoods. Do you understand this flow here as to what are all the different components that you will need to have access to before you can build like a chat agent yourself? Cool. Okay. You can decide that there are some information that is already available on the memory. The memory buffer can be defined. So if you actually go in here, the LangChain. So if you go to LangChain and if you look at the memory, the conversation buffer, this is the conversation buffer window. So you can define how big this could be. You can actually define the length of your conversation buffer here. You can actually go here. See, keeps a list of interactions of the conversation. It only uses the last k interactions. The k can be defined here. We can define. I think there's a keyword argument here. See, the default k is 5. So you can decide how many more you wish to. So when you are defining it here, where did so if you see here, you can actually pass a keyword argument here. Return messages is false. Hang on, where did that go? Yeah, there's a keyword argument here. So you can pass the k here. You can simply pass the k and you can define how much that k could be, right? How many to use over here. When you are using tools like these, see, now here's the thing. Now, if I ask you a question, hey, tell me how many LLM calls have I made to be able to get to this response? And then we are screwed. Because here it would have made, I don't know how many LLM calls. So now I don't know how many LLM calls have been made. Now I don't know how many tokens have been consumed. I don't know what was asked in each LLM call. I don't know what came out of each LLM call. Hence, you need a slightly different tool to do logging, to manage observability and to manage logging. For a traditional software app, you would use some kind of a logger, right? You would use, it depends from again model to model, but sorry, from app to app. But some of them would use a Datadog. Some of them would use application insights, depending upon the interface that you're working with. But these are just simply loggers. These are simply just log management tools. But in the case of GenAI based models, you cannot use those traditional loggers. You will have to use slightly different logging system, and those are generally those are slightly more complex, to say the least. They would essentially have like, okay, you have asked one question. Under this question, there are like multiple sub questions and stuff like that. And that is basically what LangChain is providing. So if you go here, LangChain, one of the offerings by LangChain is also that. I'm not selling LangChain, by the way, just to let you know. I just use LangChain. This is why I'm explaining that. But I am by no means an advocate of this. Just full transparency here. I am just I'm just a user of it. So Langsmith is essentially sort of a tool that helps you manage logs, that helps you track how many LLM calls have been made. So as you can see here, right? So you have like a nice view where there is an agent executor. In that agent executor, this was the input. What was the expected output? What was the error rate? Blah blah blah. All of that can be very beautifully tracked in that. So that's the only difference. Other than that, everything else remains the same. Unless, of course, you are fine tuning the model and stuff like that. Then things will be a slightly different. But generally, I'll be very honest, right? So then there is very little need for fine tuning models. If you can write your prompts well, and if you can set up your RAG well, you don't need to fine tune models at all. At least in the modern day, you don't need to fine tune models. And also, it has been observed that with small data, fine tuning is actually pretty bad. It actually deteriorates the model performance. The amount of benefit that you get is very, very, very little through fine tuning. So if I were to visually represent it, so this is, let's say, your accuracy or quality. I'm not going to use the word quality here. And then there are things like zero shot prompting. Then you have few shot prompting. Then you have chain of thought, react sort of things, right? COT, react. And then you have, right, on the same page, you have on one extreme, you have, and probably here somewhere you have agentic. So from here, you're almost referring to like agentic systems and stuff like that, agents. And then last but not the least, you have, let's say, fine tuning. And what has been observed is you would see a significant improvement in performance as you go from here to here. But that quality doesn't necessarily take off after that. So from fine tuning, when you look at fine tuning, the amount of benefit that you would sort of get, right, through fine tuning is very, very, very minuscule, right? You would probably do something like that if and only if you have a very specific need. Otherwise, these will give you decent results, right? So your zero shot prompting, your few shot prompting, your chain of thought, react, thought, right? So I'm just going to put thought also here, tree of thoughts, or the agentic behavior, that will already give you very, very good results. Fine tuning is probably not required. Somewhere here, you can also add RAG, by the way, right? So somewhere here, you can also add RAG. So RAG is also probably going to be here, Retrieval Augmented Generation, chain of thought. That would already give you a decent result. So a good 90 to 95% of work can be nicely accomplished just through this. You will very rarely require the need for fine tuning. That too, only if you have a very, very large volume of data. If you have small pieces of information, that's often not very useful. It's not very enough. It's not enough at times. So it actually is counterproductive, and it actually drops the quality of the performance. So people have observed that the quality of results dropping because of fine tuning, because their data was not good enough. So just be mindful of that particular part. Okay. Awesome. Okay. So folks, that brings us to sort of the very end of our sessions, especially on chatbots, on large language models and agents, agentic systems and stuff like that. Okay.
Just a quick info, guys. Intellipaat offers generative AI and prompt engineering course, which will help you gain proficiency in creating generative AI chatbots and other GenAI tools, along with mastering the latest tools and techniques with hands-on projects and real-world case studies. And the best part, this course will be taught to you by IIT faculty and the top 1% industry experts. What's more, you'll be getting your generative AI and prompt engineering certification from Microsoft. With this course, we have already helped thousands of professionals in successful career transitions. You can check out their testimonials on our Achievers channel, whose link is given in the description down below. Without a doubt, this course can set your careers to new heights. So visit the course page link given down in the description below and take your first step towards your journey as a Gen AI engineer.